Yeah, no, they've kind of let that.
Yeah, no. I can have the slides, I just haven't uploaded yet because I couldn't get to the room. You did great. I can't get in, so. There we go. It's just. Yeah.
Or in person too. See him.
There he is, yeah.
Jane, are you on?
Okay, I will deal with this later. First presentation is remote.
Someone else from the remote attendees turn on the mic and speak just a sentence or something to verify that audio is working.
Am I
Can you
audible?
hear me? This is Mahesh.
Okay, I think I'm audible now. So I don't know, maybe I joined a little early and then, okay. Can anybody please confirm that I'm audible?
Yep, I can hear you.
Thanks Mahesh for.
Audio, so just please go ahead.
Go ahead.
Should I take as a presenter or like I'm not able to change the slides?
Yes,
So.
you can start presenting.
Okay.
You can hear us, right?
Yes, I can hear you. Okay. Yeah, I can. I'm able to switch slides. Okay. Good morning, everyone. Thanks for joining the session. My name is Saurabh Jain, and I work for Linux Technology Center at IBM India. This presentation this work. The work is done to improve the reliability of KDump in the event of CPU or memory hot plug. When we submitted this proposal. This work was still under review, and then we wanted to get some feedback from the community and see how we can take this work forward and get it accepted upstream. But when after the proposal submission and it got the patches got accepted upstream, and then now my motivation is to introduce this new feature in the KDump, or I would say new improvement in the KDump, and then how other architecture also can enable this improvement in the KDump, and like I did it for PowerPC. Here's the agenda for my talk. I'll start with the brief overview of the KDump. uh, what exactly the KDump is, how it works, and things like that, and then what impact KDump has whenever there's a either CPU or memory hot plug happens in the system. And then we'll talk about like what is the existing solution available to take care of those operation and then keep updating the FDM whenever there is such a hot plug event. And then we see what are the solution is proposed to to cover the shortcomings of the existing solution, and we see the implementation detail. And at the end I will share like what are the steps an architecture need to follow to enable this feature in their architecture. So now, like, what is KDump? KDump is basically a Linux kernel feature that allow you to, collect the crash dump whenever there's a crash in the kernel. KDump kernel boots and try to collect the memory dump. So, like I represent in this diagram, where you have this is your system RAM, and then the production kernel is running. And then when production kernel boots, right, we reserve some memory for the KDump kernel via crash kernel command line argument. And then once the production kernel boots, the KDump service loads the KDump kernel, and then KDump kernel sits there in the reserved memory area and then wait for the production kernel to crash. Once the production kernel crashes, the controls jumps from production kernel to the KDump kernel, and then KDump kernel boots up, and then try to collect the dump and then export the production kernel memory as a proc VM core, so that user space programs like migdum file filter it out the unnecessary pages and things like that, and finally store the dump into the disk. So this is a basic overview. Now, KDump has multiple components. In Linux kernel, these components are referred as a kexec segments. But throughout this presentation, I'll call out them as a KDump component for the simplicity. Now, for different architecture, the number of component may changes, but there are few set of component exist across all the architecture. So, for example, this is the list of KDump components exist on PowerPC. Uh, like we have kernel and initramfs, which basically KDump kernel and KDump initramfs. This kernel boots once the production kernel crashes. Then we have elf core header. Elf core header basically, this shares the dump image between the kernel. So basically, what does the production how does the production kernel looks like? Basically, this holds that information. And then we have purgatory and the device tree. So purgatory is elf relocatable objects. It's a binary that gets executed in between the production kernel and the KDump kernel. So when the production kernel crashes, it jumps to the purgatory, and then purgatory does some SHA verification, and then after the SHA verification is done, it jumps to the KDump kernel. So yeah, this is the flow. And then we have device tree, basically holds the device related information for the KDump kernel to boot. Now, if you further expand the elf core header consists of different datas. So it is elf file, and hence it has elf header. And then have bunch of program header of two different types. First is PT load and PT note. Uh, so first program header is of type PT note. It holds information about CPU crash notes. Crash notes consist of data related to PT register, PT regs, and things like that for each CPU. Uh, for different architectures, it can contain information of number of online CPUs or maybe possible CPU, depending on depending on which architecture you are in. And then we have another program header to hold the address of the VM core info. VM core info basically, have the data about basic data about the production kernel, for example, the page size, and few symbols here, few symbols about the production kernel and things like that. And then after the VM core info, we have bunch of program headers, to hold the memory regions for the memory regions belongs to the production kernel. So every program header will be pointing into different program memory regions of the production kernel. So yeah, this defines the different component of the KDump. Now, architecture may have few other component in addition to this, or we may have some different component as well. Just this is specific to the PowerPC, but the kernel, initramfs, elf core, and purgatory. I think these are the common KDM component available across the architecture. Device tree, I think it's available on PowerPC and other architecture, but not in all architecture. So yeah, this is the code KDump overview. Now we'll move on to like what impact KDump what impact we have on KDump whenever there is a CPU or memory hot plug operation. As we have seen, right? Like uh, elf core header represents like the CPU info. Elf core header holds CPU information and then the memory regions available for memory regions of the production kernel. So in case there's a memory, for example, if the memory hot plug operation happen and the memory get removed from the system, then this elf core header is holding the stale data. And if you try to collect the dump with the obsolete elf core header, the dump collection may fail, or we may collect the inaccurate dump, so which is not correct, right? And same goes for the CPU as well. So it holds the CPU nodes, either online CPU or possible CPU, depending on which architecture you are in, but it holds the CPU information. So even if the CPU hot plug operation happens and then that CPU information is not present here because the CPU got added later, then in that case also we will not collect we may correct the inaccurate dump. So this is the basic overview of like what is the impact of CPU and memory hot plug on KDump. Now let's move on to the existing solution. What we have is like, so we have a UDEV rule which we use to keep monitoring CPU and memory hot plug event in the user space. And then whenever there's an event observed, whether it's a CPU add remove or memory add remove, CPU add remove or memory add remove, a UDEV rule triggers a KDump service reload, what it does is basically whatever the KDump image that we have loaded, it will go for a task and then it will reload the KDump again. So this is the existing solution. This is how we bring the this is how we update the KDump. Monitor the CPU hot plug event in the user space. Whenever an event comes, reload the entire KDump image. I want to emphasize a point where here we are reloading the entire KDump image, which consists of all kernel, initrd, and then elf core header and bunch of other components. Now, there are few shortcomings associated with this solution, right? So, given that, as I showed right here, uh, we have, whenever there's a hot plug operation, only elf core header or a device tree, maybe few other components in other architecture gets obsolete. But what we are doing with this solution is like we are reloading all the KDump component. So this is inefficient, right? Why we are loading all the kexec segment, whereas only one or two kexec components are getting obsolete. And this has and this creates a major service KDump service down window. So what happens is, let's say because of the any hot plug operation, the KDump gets obsolete. And then what happens is, let's consider a specific system called kexec load system call. In that case, what will happen is like the user space will again create all the components and then load into a user space buffer, and then kernel will again copy back those buffer to the reserved area. This takes a lot of time, and then the meanwhile this process is going on, the KDump service is down. And if we try to collect the dump in this window, the KDump service the dump will not be the dump will not get collected. Now this solution worked fine till now, but as the modern workload, where in the cloud like environment, where the hot plug operations are more common, uh, uh, this makes the situation worse, because what happens is like for every hot plug operation you are trying to reload the entire KDump. So when there is a bulk operation, this makes the KDump service really reload so many times, and since we are doing it full KDump reload, it really makes things worse. And then we have seen a couple of issues where you know uh, when we do hot plug operation in bulk, and then all the reloading thing will happen, and because of there are few race condition, even after all the reloading, the kdump kernel will the kernel cache will not end up in the dump collection. So these are the few, the shortcomings of the existing solution that we have identified, and we try to solve with the trying to solve these shortcomings with the proposed solution. Now, here's the proposed solution. Like we have two principles in the proposed solution. We wanted to, we wanted to do everything in the kernel, and then only update the relevant kexec segment. So handle all four operation, whether it's a CPU add remove or memory add remove, handle everything in the kernel, and then only update the relevant kexec segment based on the type of the hot plug operation. So let's say if the CPU hot plug operation happens and you only need to update elf core header and device tree, then only update these two components rather than updating the kernel and initram fs and everything. So yeah, so this gives us tremendous gain in the this reduces the kdump service window downtime. And then and then in the some operation that we have identified that for example on x86, we don't need to reload any of the kexec component at all, because of the few changes that we have introduced and identified during this exercise. uh, and I collected few performance number, like how much time it used to take when we used to we reload the kdump kernel with the existing solution and with the proposed solution. So as you can see in the result, I have added one table where it says the CPU hot plug for existing solution it takes 1 second, whereas in the proposed solution it takes around 4 milliseconds. Similarly, on the memory hot plug, since we are doing the entire kdump reload with the existing solution, it takes same 1 second, and then in the proposed solution, it takes around 0.03 millisecond, which is very less. This number are just to show you with the single core. I mean, but it gives us the advantage when there is the bulk operations happens and things like that. This really reduces the kdump service down window to in millisecond instead of seconds. Now I will take on the implementation details of our proposed solution. Now we have to load the kdump, we have two system calls. First is kexec load and second is kexec file load. In the kexec file load, the difference between these two system call is like is how the kdump kernel is loaded and who loads the kdump kernel. For the kexec file load, the kdump is prepared in the kernel, and then in the kexec load, the kexec tool in the user space prepare the kdump and then ask kernel to load it. So in our implementation, we have a generic architecture that updates the kdump image, but there are few bits that needs to be changed based on the which system call is being used, that is specific to that which needs to be changed in the kernel for kexec file load, and for kexec load there are few bits we have changed in the kexec tool to enable this feature. Yeah, so this diagram shows like what are the things that we have introduced in the kernel to handle to update the kdump in the kernel. So we have introduced two crash notifier for to handle both the CPU and memory hot plug. So this hot plug this notifier gets invoked whenever there is a CPU add remove and a memory add remove. And then once they invoke, they call a crash handler hot plug event. This is a generic hot plug event handler. Basically what it does is it does like a few bookkeeping things, takes the necessary log to update the kdump image and things like that, and then it passes control to the architecture specific crash hot plug handler, where actual update happens. So it's up to the architecture what are the things they want to update. So architecture knows that I have these segments available with me, and this is the type of the hot plug operation, so I need to do these updates. So the sequence is something like So let's say for CPU hot plug, whenever there's a CPU hot plug operation in the kernel, this notifier will be called, and then this calls the crash hot plug notifier event, which is a generic handler, and then it takes the necessary log and it calls the architecture specific handler to update the KDM. Now, as I already mentioned that there is a udev rule which basically reloads the KDM kernel, right? So to make to keep user space in sync that the kernel is capable of reloading or updating the KDM kernel, we have introduced two sysfs files, for both CPU and then memory hot plug events. If this sysfs file contains one, that means that kernel is capable of updating the KDM. So udev rule doesn't have to update or reload the KDM service. So this sysfs attributes or this sysfs interface are introduced to make user space aware. For example, udev rule to don't reload the KDM service because the kernel will take care of updating the relevant kexec segments. And then one of the point, and that's this fourth point is specific for the kexec file load system calls. What happens is like when we when we prepare when we prepare the KDM component, right? So there is something I already discussed, that in the purgatory we do the SHA verification to make sure that integrity is there and before booting into the next kernel. So since we are going to change the elf core header, we need to skip the elf core header from the SHA calculation so that if anything changes in the elf core header, it does not impact the SHA verification. So this is this point, for the kexec file load, we have excluded the elf core header from the SHA verification, SHA calculation basically. And then to enable this disable this feature, we have introduced a dedicated config crash hot plug. People can use this config to enable or disable this feature. As I mentioned that this commit is already this feature is already part of kernel tree, and this is the SHA this is the commit ID for that introduced this generic infrastructure in the Linux kernel. Now this the kernel story, like this is how the kernel updates the thing. But as I mentioned that for the kexec file load system call, the elf core header is prepared in the user space. So there are a few changes we need to do in the kexec tool to make sure that kernel has a permission, or kernel has a permission to update any of the KDM component which was prepared in the user space, and so that the kernel can update it. So two primary things here is is kexec tool is updated to create the elf core header with the additional buffer, so that if there are resource change in the future, we can add more resources to the elf core header. And then the new kexec flag is been introduced, so that user space can convey to the kernel saying that it's okay or it is safe to update the KDM component if it is loaded via kexec file load. Because if we update if we update if we update the elf core header, and if they update the elf core header, it is possible that the SHA verification will fail, because the user space would have included the elf core header inside for the SHA calculation. So uh, the kernel for the kexec file load, kernel will only update the elf core header when this flag is passed by the kexec tool. Now, this is the chart that's talk about how other architectures can add a support for this improvement. So what they need to do is, like, they have to first add a rcrash handle hot plug event. So this function is responsible for this function is called from the generic crash hot plug handler, and then this generic crash hot plug handler tells that this is the hot plug event type. Now you can update the KDump image. So this is how the rcache hot plug handler events are handler for x86 and PowerPC. So for x86, whenever there is a CPU add remove, we don't update anything, and for memory add remove, we update elf core header. The reason why we don't take any action for CPU add remove because the ELF core header we built with the possible CPUs. So for an architecture, if the ELF core header is built with the online CPUs, you need to update the ELF core header to include the ELF node for the newly added CPUs. On PowerPC, for remove case, we don't take any action, but for CPU add, we update the device tree because we have a constraint where we have to have the newly added CPUs into the device tree, else the KDM kernel won't boot. And for the memory add remove, we simply recreate the ELF core header. Now these are the action, these are the action the architecture has to define inside the arc crash hot plug handler. Once this is defined, the other things the architecture has to do to enable this feature is to export this SFS file, one to this SFS file. Once they implement this feature, the architecture has to report one to this SFS file to advertise this feature to the user space, so that UDEV rule won't reload the KDM service, because the kernel is now capable of updating the KDM kernel. And then there is architecture specific config. It must be added in the arc k config to enable this feature. And then this is one of the example I have added how to update the UDEV rule, to only reload the KDM service when the kernel doesn't have this feature. So if we have so this UDEV rule is something like when there is a CPU hot plug operation, and then this SFS attribute contains one, then you just directly go to the end of that thing and don't do anything. No action is needed. So yeah, this I mean, yeah, this UDEV rule can be updated like this to to stop reloading whenever there's a CPU or memory hot plug operation. There's a slide. I'm up for the question if at all people have any questions regarding the implementation, regarding the feature.
Any questions in the room?
Thanks for that. That was interesting. It's not really a question. I thought I'd describe how we try to avoid this problem on ARM64. For ARM64, we don't have a memory map that the kernel maintains. We discover it all from firmware, and that means we don't pass that information along in exec or kdump. When a new memory region comes online, we don't have to update those regions, because the next kernel will be able to discover that this memory will be using the ACPI STA methods that you can use at boot to query whether this region is there or not. I comment this just in case that was going to be simpler. LPC, if you have to rewrite the DT anyway, you probably have to keep.
So if am I audible?
Yes, we can hear you.
Okay, so what you're saying is like then how I mean how is your ELF core header is built, because if we see, right, I mean as far as I know, ELF core header is built to hold all the crash memory regions, and then along with the CPU crash node and the VM core info. How I mean how do you transfer that information to the KDM kernel currently?
Yeah, so for kdump, I don't know off the top of my head, I'd have to check. But for kexec, it's all discovered again once the second kernel starts up.
Okay.
Yeah, so you can query.
I mean, I would say, like, if there has to be some way, to you should be having some way to convey. See, these are the memory regions that you need to collect, and then pass it to the KDM kernel. I mean, I was in the impression that it's always be the cache memory ranges part of the ELF core header, which contains all these data.
But wouldn't that be all memory that's not in the carve out? The carve out can be described saying it's not this range, this is the range you can use in the kdump kernel, but all other memory would be dumped, right? But for KDUM, I don't know what the ELF core header looks like off the top of my head, but if you can probe and detect regions as being there, that might be simpler. I think you've got other questions.
No, the thing is, if you have the panic kernel, it uses exactly the inversion of the memory that was used by the crashed kernel. And this is conveyed by the ELF core header. And it also has some metadata like VM core info and stuff, but the main reason is you want to make sure that the memory that was used by the panic kernel is not used by the new kernel and vice versa. So you don't want to use any other source of information if possible.
Yeah, but is there no firmware interface where you can simply query firmware on where or what memory do we have, and then simply store it in the crash kernel on, okay, that's the crash kernel memory and we don't need to dump that?
Yes, there is, and you should not be using it. It causes all kinds of headache if the panic kernel tries to reuse EFI mappings or device tree or whatever. So no.
I'm curious what the problem is then, because so on ARM64, we only have the UEFI memory map. That is the golden truth about what is memory on the platform. You can add memory regions at runtime, and they're not described in the UEFI memory map, but the KDUMP kernel will go and have to find the ACPI tables and the UEFI memory map in order to learn about the system in order to bring it up. So one of the rules we have is that those structures, the ACPI tables, the DT, and the UEFI memory map must never be modified by the kernel, because otherwise we have a massive matrix of things to support. So I'm curious to know what the problems are with that, because we're doing it on ARM64.
Thank you. So there is a special device tree attribute to override this logic, and that is used by the panic kernel. Yes. So in that case, it was already parsed by the first kernel, and it should be trusted. Okay.
So continuing this discussion, I think, so is in the case of like a memory failure, memory error, uncorrectable memory, if the firmware is the source of truth, is the firmware, when it gets queried by the crash kernel, does it make sure to remove those poisoned memory, the bad memory, or is the dump kernel going to hit it and die itself? Because there was a patch for x86 recently to fix that in machine check.
Yeah, so for ARM64, that's still all on the table. No firmware doesn't know about memory regions that you've decided you're not going to touch anymore. It can't know that. And that information doesn't get passed across. Yes, you would hit that a second time if it wasn't transient. So yeah, we would, I don't think it's supported today, but my expectation is for KDUMP, the thing that's accessing memory to produce the dump file, make that memory accessible to user space, would need to be tolerant to taking machine check or an ARM64 external board, and it would need to skip that memory region and keep going. But that's containable on ARM64 at least.
All right, any other questions? Let me check and see if there are any questions in the chat. Yep. All right, so from the chat, a question from Hari. Does ARM64 have a need for reloading KDUMP service on hot plug operations? Exporting VM core depends on ELF header core. I would assume ARM64 would have some way to set that up in the production kernel.
So this is where my comments were more about kexec than kdump, but the panic kernel will be able to discover that these new memory regions are online, and it could, if that information were missing to say dump these, it could know dump these. It knows they're not part of the carve-out because the carve-out's explicitly described to your point about knowing that you're the kdump kernel. CPU hot plug's not yet supported on ARM64, but when it is, again, you can probe to discover those CPUs are present. So there might be a piece missing here, but it doesn't necessarily need passing across between kernels because you can work it out on the other side.
Okay, if there aren't any other questions, I don't see any on the chat or in the room, then I think we're all set. Thank you very much.
Thank you.
All right, I think we're a little ahead of time, but I think we've got lots of people in the room, so why don't we just get started? Yeah. So next up, John is going to be giving an update of kernel documentation.
So we need, let's see, it looks like do I have the presenter here?
Just go to this.
So, come on, speak to me. That wasn't what I wanted.
You probably just misclicked it.
Yeah.
Okay.
So do that.
Yes.
And then,
Yeah, that's why.
here, that one.
Yeah, okay.
Very good. All right. Well, then, good morning, everybody. I'm John. I'm here to talk about documentation. So I have a handful of slides, which I will go through, but the point of this whole session is discussion, not me kind of babbling at you. So interrupt at any time, throw something, whatever, or otherwise we will be done fairly quickly and all this, which would be okay too. So a few things that have happened over the course of the last year with documentation include the big move of all the architecture docs into documentation/Arch. When I first picked up the maintainership of documentation, the top level docs directory had something on the order of about 300 files in it. It was kind of a big mess. So I've been trying to bring some order to it ever since. And one of those tasks was to take all the various architecture documentation, the x86 docs, the ARM docs, whatever, and move them into their own directory, trying to slowly make the documentation directory somewhat resemble the organization. Somewhat resemble the organization of the source directory that it is documenting, so that people can find things a bit more readily. So that was a bit of churn, but rather less painful than I was expecting. I can approach that with a certain amount of trepidation, but did not get the opposition I was worried about. We've integrated the Rust documentation. The Rust code, of course, has its own mode of documentation in the kernel source, which is very different from what the rest of the kernel uses. There's a fair amount of impedance mismatches there because, of course, the Rust stuff is in Markdown format. We use restructured text, and it has its own build system and so on. So Carlos Bilbao did a fair amount of work to do that integration and find a way that made it work with a minimum of pain, and that was, I think, a very good thing. I'm glad to have that. We could certainly integrate things better, but we've made some very good progress in that regard as part of integrating Rust in general. While we're talking about Carlos, we have the Spanish translations that have been added over the course of the last year, bringing us up to, I believe, 5 languages that we have translations for in the kernel, some of which are rather more current than others. We switched to the Alabaster theme for the HTML rendered documents, which is received better by some people than others. I think it was a definite improvement in the readability of our rendered docs, but others may disagree. We've added the ability to render the docs in the tech and info format because Sphinx will do it and somebody wanted it. This is not really taking the world by storm in general, but if you want it, it's there. And I rewrote the top level index.rst file, the thing that you first find if you go into our HTML documents, to try to make it a little bit more of a gentle introduction to how kernel development and how kernel documentation works. So those are the big things that have happened over the course of the last year, along with, of course, the addition of a whole bunch of new documents covering all kinds of things, from some pretty elaborate tutorials from Thorsten to various new documents covering new subsystems and so on. A lot of good work being done there. Way short of what we need, of course, but there's nothing unusual about that. So I have a few notes on where I would like to go from here. But again, I really want to hear where other people would like to go from here. One thing that's on my list is to continue the reorganization a bit. We still have nearly 100 top-level directories in the documentation directory, which again makes it pretty hard to find things. Many of those are device-specific sorts of things. So we have top-level directories for obscure device drivers and so on. So I want to create documentation/devices to match the top-level devices directory and move the device documentation into it. Again, that's going to be a lot of churn as we move a lot of documents around, because you move documents and you have a lot of pointers to the documents elsewhere in the source code, and those all have to be changed. And so it's a bit of a pain to do it. There's something like 30 some, almost 40 directories that would move to do that. But I think that would bring us a fair amount of organization there and come close to the end of the massive reorganizations of the docs directory that I would like to do. So I'm kind of pleased that we managed to get there. A previous documentation maintainer tried to do the whole thing in one big patch and didn't get very far with it. By taking a bit more of a gradual approach and only taking something like 8 years, actually managed to get somewhere with it. So I think this is good, but a point that I would still make with regard to moving all of these directories and stuff around is that we've been taking the kernel documentation, which was really a collection of a few thousand sort of separate Post-it notes that people stuck in there. And now we have a few thousand much more nicely piled up and organized Post-it notes that are easier to find, but we still don't really have a cohesive set of kernel manuals, which is where I'd like to go, which is why I keep raising this issue of structure. I have some slides on this towards the end, but this is a topic I've raised in these things for years. And so I wanted to actually go to a few other things first and come back to this towards the end if we have time for it, because it's kind of an old subject of trying to bring better structure to our kernel documents as a whole. So things I wanted to raise the question, this is where I would like to get some discussion, on the topic of plain text versus HTML. For the whole time that I have been working on bringing restructured text in and all that sort of stuff, we've labored under the proviso that the plain text documentation is our documentation. That is the format that matters the most. If we can create some nice HTML out of it and so on, that is good and it is useful, but not at the cost of obfuscating or complicating the plain text. People want to be able to grep it. They want to be able to read things with their editors and so on. And even the amount of markup that comes with restructured text has engendered a certain amount of opposition from certain quarters in the community who have not been subtle about their feelings on that matter. But I asked Constantine about the traffic on docs.kernel.org, which is the main place where I think people read the rendered documentation. And he said it gets about 150,000 requests per day. Now, a fair percentage of that's going to be robots. It's kind of hard to tell how much of that. But if you look at the traffic patterns there, it makes it pretty clear that unless we have robots that are very interested in kernel development specifically, we have people actually looking at the docs in the HTML format. Right? People read the coding style document to the tune of about 8,000 people a day, more than anything else out there. And our submitting patches document, which is arguably the most document we have in the tree. And then NetDev maintainer manual, which kind of struck me. But I mean, you see, so this is, in fact, an important channel for the people who are consuming our documentation. And so while I don't want to ruin the plain text side of our documents, I'm curious about what people think about this balance and if we should be trying to shift things at all. We saw Thorsten add some tutorials that were very much written with the idea of being viewed in a web browser, and they're fine because they were off to the side. But for the most part, we haven't done that, and we need the catch box way in the back. Ted.
Yeah, like at this stage, I think ignore those people. Can we? Look, those people don't even read the documents. They're just loud kernel maintainers who really probably don't use documentation themselves. It's so much more useful to be able to read the documents online than it is to be able to grep for stuff. It's Google searches it and you can find it and it looks nice. You can put tables in there and you can see them. It's like, yeah, this stuff is the world's moved on. We can move on from those people and they can, figure out how to use the internet.
As one of those people that is averse to reading the documentation but maintaining it, something that would be very nice if we push more towards HTML is to reduce the cost of verifying that it actually works and spits out. So the time to compile the docs is just brutally painful.
Yeah, that's a slide or two down the deck. But
Yeah,
yes,
so if we can improve that, I think the resistance to going more HTML heavy would go down maybe by a little bit, just because right now the threshold to try and get the restructured text to look like you want it to look and to verify that it actually will compile is just way too high from a maintainer's perspective.
yeah, the build is painful.
So I'm actually just had an example where I was trying to find nappy_disable documentation and there isn't any. But the problem with that, if I do a Google search for that, I get hits for source trees all over the place. I don't actually find the official documentation. So I'm thinking that there's still use for text documentation when you're looking for specific things, APIs and stuff like that. You're looking more for a reference manual, not a user guide kind of thing. So a lot of the things you're pointing out here for process, coding style, those are kind of user guide level things. And HTML is way better for that, right? Clearly. But I think for reference guides, we still need something sort of text-based.
Certainly for maintaining it, of course, we have all the API references and stuff in there. And the search mechanism that the Sphinx builds into the documents is actually pretty good for finding stuff like that, as well as the indexes for specific functions and that sort of stuff. It is there. But yeah, I see what you're saying too.
I'll just echo the need for the text to still be there. I'm one of those old guys that's continually going to documentation directory and grepping, looking for stuff.
So I have two docs, right? I have one in this directory, and that tells you how to use the maple tree. And then I have another doc that's kind of cut up into pieces in my code, because if I don't put it next to the code, the people who update the code will never update it. And that's just me, but
Right. Now, of course, with Sphinx, we can take that documentation that's in the code and knit it into the HTML documents as well, right?
Yeah, and I'm pretty sure that's happening, right? So I'm trying to keep that formatting, but that's kind of how I organize my thing. I have a text file in there, and I don't know if it's HTML. I don't read that one, but everyone else's stuff I look up through HTML. Right? I don't know about anyone else, but I have like a plethora of monitors, and one has HTML and the other one has as many coding windows as I can fit on it.
So maybe I don't understand the debate. So is the debate that we already write an RST and we get the HTML? Is the debate that we just write an HTML directly, or?
Nobody's proposing that we write the documentation in HTML. That is not. So that's not where we're going. The question is really where the balance lies, right? We write the documentation in restructured text.
Yes.
And I don't see changing that at this point. It took us years to get to where we were doing that. But there are questions about how much you mark up the restructured text, for example, to produce nicer HTML versus keeping the plain text readable.
So the whole debate is just how much RST that we want to actually use to produce nicer documents.
Yeah, pretty much like that. I mean, one example that I could give is the formatting of tables. Right. There are a few ways of formatting tables in restructured text, some of which are totally unreadable on the restructured text side, but make nice tables on the other side. And some people like to do that because they want to look at the HTML tables, but it makes the plain text side completely unreadable in terms of actually understanding the table. So that's where that kind of balance comes in, as well as more markup in general that some people really dislike. Back that away.
I'd love to have good HTML docs, and it might be a bit old-fashioned of me, but every time I look at the HTML docs, I think, I wonder how outdated this is. And I go look at the text docs, and I go, well, that's probably a lot closer. And then I go look at the source code. So increasing the confidence that the HTML docs are up to date might help a lot.
Well, the HTML docs are generated from the text documents. So, I mean, they are really one and the same. Unless you built it last year or something like that. But if you go to docs.kernel.org, I mean, Constantine builds those directly from the current kernels. So they are as up to date as the text docs, which is mixed. Yeah.
I think that it's also partially like a perception thing. Like, I think that most of us don't trust something that isn't as close to the source code as possible, and that the plain text feels like it's more like, just in terms of the visual cues, it feels more reliable than a web page. And I think part of it is like the poor experiences that some of us have had of finding something that's out of date.
True. Of course, every web page has a look at the RST source link right on the bottom of it. So if you want that more primitive experience,
no, I don't think it's a documentation issue more than like a trauma issue, like.
Right.
I would say I'm all for the HTML version, and I will make the point that if you develop some subsystem or whatever and you want to document it, it's your choice. You just want to make a plain text to make the people that want plain text happy, or do you want something on a HTML website that is going to attract more people? So I mean, I don't see the need to enforce anything. I feel like HTML already speaks for itself on its potential. And if you as maintainer want to document it and use HTML, it's just going to be on your own benefit, I would say.
So I have a question about maybe the audience of the documentation, and that might be sort of the key, distinction between this or that. So the kernel is the kernel, but a lot of people treat it as like the de facto source for the platform. So when a customer or user asks, how can I enable my feature set that spans the kernel and user space tools and et cetera, what's the best way to handle that? I mean, it's an open question. Should that documentation live outside the kernel? Should we have reference platform documentation in the kernel where we say, with the kernel and these tools, you can build this kind of platform? And the people who would consume that are probably people who are not coders, they're not developers. So HTML would work for them. But the question is that the audience that we're targeting with our documentation and not?
Yeah, well, the documentation has several different audiences, of course. And one of the things I've been trying to do is to orient it towards the different readerships. I really don't think that we can try to take on the task of documenting the higher levels of the software stack and how to manage it within the kernel. We can't really even document what we're doing directly ourselves in a thorough way. I mean, that's a big job, right? So I don't think we can try to do that. I mean, we have some system administrator level stuff and so on, but there are some pretty strict limits to what we can do there, I think.
So the other thing is, if we're worried about people looking at the text and seeing trash, and then, well, what I'm hearing is people look at the HTML, and if they don't trust it, they go to the text, which seems redundant. But if the people who are looking at the text, if it looks like garbage, what are they going to do? I would assume they would go to HTML. So I think we can just do what we want, and the people will check both sources right now. And so just do what you want, and then it will evolve into what it will be.
I thought one thing that I always wondered about, and what I kind of would have liked if we had a tool that was called Kman, and that you can just do like all of the admin guide stuff, basically, not the process submitting patches stuff done, but basically, I don't know, on some distros you have Linux tools or whatever, and it installs, I don't know, KDGB or whatever, and it would be nice if we had like a binary like Kman where you could just type Kman kernel parameters, and then it would show you which kernel parameters are supported by this kernel. This would be like super useful. I always wondered about this. I kind of hacked something together by just having an alias that goes into my kernel documentation directory and then looks at the text file directly. It might be a crazy idea, I don't know.
And Sphinx has some capabilities of putting out stuff in man page format. So, I mean, we could, and once upon a time, we actually did that, and that went away with the Sphinx transition, and we didn't get a lot of complaints about it. We could consider trying to restore that, and then you could just use man.
Yeah, it's just one man's opinion. One person's opinion. Most people think it's not very useful.
You know, along the same lines as Christian's quick, I'm just curious, are there any like decent tools that can render RST into text files again? You know, can we just have something that renders, you know, that you run it through this, and now your RST tables are readable?
Well, Sphinx will produce, you know, .text files, but again, you know, RST isn't that far removed from it already. So we've never wired that up because nobody's ever asked for it, and because we've tried to keep the source files pretty close to that anyway. But I mean, we could enable that if there were demand for it.
I think the pushback that people see for RST isn't so much that people want to be able to read it. It's maintainers and people that are reviewing the incoming changes to the RST that are pushing back because they don't want to have to learn RST to be able to review patches people are submitting to their subsystems to improve their documentation. I think that's the real pushback. It's not that there's like 10 people that are like, oh, I have to read everything in text. It's more the maintenance side of things.
Yeah, it's a bit more. There's more to it than that, but we don't have to get into that.
Yeah. One quick comment also, which is while we're talking about docs.kernel.org, there is the subtlety, especially if you do a Google search, whether you get the latest doc or the 5.10 doc, and of course, depending on what the user wants, making sure they get the documentation for the kernel version they want is a little subtle.
True.
Maybe last note, if there is like complaints about how the RST annotations, how heavy they are, isn't it actually kind of a criticism of how the RST annotations are done, and maybe it's a limitation of RST? So of course I don't want to go into the debate of whether RST is okay or not, but maybe the actual complaint here is that RST annotations for nice web pages are overly heavy. So.
Well, that is part of it. You know, if you put in a lot of, you know, literal text markers and all that, it adds visual noise to the plain text side.
So John, I want to get away from the text versus thing a little bit and talk about the structure you're talking about, restructuring directories and moving documentation around. So you said earlier that you were trying to match the source tree in a way for the documentation. And I'm just wondering if it's worth if you're going to do that, then is it worth moving the RST files directly into the directory it's supposed to be documenting, or a subdirectory of that?
That is a question that has come up at times, whether we should put the documentation next to the.
Because then the maintainer is there, right?
Yeah, the maintainer is there. I've found in general the idea that putting the documentation in proximity to the source causes the documentation to be updated to be optimistic.
Oh, I agree that it's optimistic. What I'm pointing out is that you're talking about trying to find it, and people are often end up looking at the source anyway. And so if they're going to look at the source anyway, and the documentation text is there already, and we're also pulling documentation out of the source, like Liam was describing, then it kind of makes sense to integrate these basic text files and then leave all the things that are how-tos and user guides into a documentation directory and have things that document the source in the source directory, right? So if you can split it up that way and restructure it, you'd have easier discoverability in a way without having to use Google search or other search engines.
Yeah, there's a balance to be made there. And if you look at what the DRM people have done, for example, they have quite an extensive documentation actually done within the source and then knitted together. They've done a very nice job of that. So yeah, it can be done that way if you want to do it that way. But there is a lot of stuff. I mean, there are a lot of users, I think, who are not looking through the source and would really rather not have to. It's a matter of which audience you're aiming for.
All right.
Right.
There are a whole bunch of comments in the slides, but they're more comments than questions, and I don't know how many more slides you have to go. So
well, I only have a pretty small number, but the point was discussion. So I mean, is there stuff in the chat? I haven't even been looking at it.
Yeah,
I should be. Let's see if I
yeah,
can.
I didn't want to read all the chats because there's
all right,
a dozen plus messages. But
Thorsten's there. I took his name in vain. Let's see. Let's find the beginning of it. All right, Willie wants to talk about enabling doc builds warnings by default. He gave me a patch to do that. I put it in, it generated something like 1,000 warnings. I kind of thought about what was going to happen if I sent that to Linus, and I took it out. I mean, I would love to do that, but we have to fix the warnings before we can do that, or it's just not going to fly.
I just want to say that the stats, using stats from Kernel from docs.org to help make a decision on what type of formats to provide is sort of one-sided, right? I mean, you're not going to see how many people look through the text. We don't have a correspondence.
There's no way to do that.
Right. So I think we should be thoughtful about that.
Yeah, that's true. So, I mean, Thorsten has some comments that you can read there pointing to some of his stuff, which is, I mean, very good documentation worth looking at. Somebody said, who would love to have HTML tables readable in text, and both are possible. It is possible. It's just more work most of the time. So some discussion there. I'm not sure is.
I have a question.
Okay, go.
So what about just moving to Markdown? I mean, it also generates HTML. It's readable.
We had extensive discussions on this when this transition was made. We were initially going to go to Markdown, and then we were going to go to ASCII doc, and then we finally settled on RST. And that was about 2016, 2015, 2014. We were having those discussions. And I can kind of review the reasons why we made that decision. But the short answer is that I really don't. We're not going to go through and revisit that now. That would be painful, and I don't see the value in doing that.
So going back to the question of if the RST, literals and things are too complicated, is there a way to maybe abstract some of that and have helpers or macros that can be maybe they're Linux kernel specific just for our code here, but it would make the review easier, the documentation easier, and have just enable people to do it better.
I mean, we could consider some sort of pre-processing, make the docs build a little slower. I mean, we've done some of that. For example, I mean, I wrote an extension a while back that just finds a function reference, function name parentheses, and creates a cross-reference for it. Because otherwise, you had to do this really ugly-looking explicit cross-reference to get it. So that sort of thing cleaned things up quite a bit. So there are things we can do, but I mean, RST is not that heavy. It's not that difficult to deal with. It really isn't. So it's not something that I think we really need to worry about much.
Something I will mention is that a lot of people document their code great. So just take those comments and put them on an RST. It will help.
Well, I mean, we have the ability to do that, right? So
No, I don't mean you. I mean whoever is submitting the code.
right.
Like just in general, it would be nice if they also take those comments. And by the way, those comments on the code are already on plain text, so you have it there in plain text.
Yeah, I mean, we're all set to extract those during the documents build and put it in there, right? I mean, we have that capability, and some people use it to a pretty great extent. All right, well, maybe I'll move on and we'll see what else we can get to here. So since people talked about the docs build speed, this has been kind of a progression for a while. Sphinx 6 takes twice as long, or even a bit more than twice as long, as Sphinx 2.4 to build the docs. This has not been a welcome thing, and I've talked with them a little bit about it, but haven't gotten much traction with them about trying to fix it. I went in a while back and simply hacked out some of their cross-reference code using a rather blunt axe, and managed to cut about a quarter of the build time out doing that without actually affecting the results at all, but never had a chance to turn that into something that I could submit and not have to leave the building in a hurry. So that kind of relates to something that I wish we had done better, which is actually working with the Sphinx community. We don't really have a lot of communication there. We don't have anybody on the kernel side who is working with the Sphinx people and trying to help push that tool to meet our needs. Because I mean, they have a lot of big users, but we're one of them. And I think our needs are relevant, but we can't just sort of stand on the sideline and complain and expect to get a response from them. Question back there?
What about leaving the generated HTML on the repo itself? Would that be too much memory waste? Or
sorry, I didn't
so what about once you you have a version of the kernel, you generate the HTML for that particular documentation version, and then when you download the repo, you already have that HTML, meaning that whenever you have to recompile to build whatever else, it doesn't take as long. You know what I mean? Having the generated HTML already on the
I mean, ship that with the kernel.
Yeah,
you think?
No, maybe not for the mainline, but having another version that already includes that for people that work with the documentation, they don't have to be generating it from scratch.
We could do that, and that would help, but it only helps so much. I think certain things you do force a rebuild of an awful lot of stuff.
Yeah, we have for the KUnit website a checked-in Git repository of generated Sphinx stuff, and the amount of random, changes to Sphinx JavaScript when someone builds it with a different version, and that it's not pleasant. I think checking it in certainly to the main repository would be an unpleasant experience, and it would make anyone making documentation changes, end up having to do a full docs build potentially, rather than just a small, one directory docs build, and that would double the time it takes to do some patches.
I mean, one of the things that we could do, since we've organized the documents into several distinct books anyway, is to make it easier to build those books independently of each other. I mean, there's a mechanism called InnerSphinx that's designed to allow that, and I've looked into it, and it's not as easy to do as one would hope. It's not quite designed for the use case that we would have for it. But I think there are things that we could do that would help a lot. As well as actually fixing Sphinx. It would be nice to do. Related to that is the question of minimum Sphinx versions. We currently support back as far as 1.7, which is pretty ancient at this point. And, they move quick. They are not hugely concerned with maintaining backward compatibility. And so we have a certain amount of glue in our own extensions and so on to support all these versions. So I'm going to push this up to 2.4. I'm going to put that patch out pretty soon, but I'm wondering if we should go a little bit further. There would be certain advantages to going to Sphinx 3. And last time I did this, I got a complaint from one of our fairly prolific documentation contributors who was still using something like 1.6. But I'm curious if people have thoughts on that. Presumably not.
Don't go beyond what's packaged in Debian.
Yeah. Yeah, I should check that. I don't actually know what Debian is shipping these days, or much of anybody else at this point. CentOS 7 or anything along those lines. Partial build support I got to. Something we could probably spend the rest of the time arguing about is the sidebar, which changed with Alabaster. Nobody likes the sidebar, the bar that shows up along the side of the HTML documents, and I can show it in a little bit. And I know how to take it back to what we used to have with the read the docs theme, but I'm not sure that's what we want either. And so there's a real question of what do we want in the HTML sidebar that would make our navigation through the documents the most helpful. So this may not be something people came prepared to discuss, but I'd like people to think about it and send me thoughts.
I like what it used to be. I like what it's become now, but there were several things in the middle that certainly weren't great for our documentation, where making sure there are not minuscule font size links to, at least everything in the current subsystem you're looking at is very good, as well as the general list of all the top level stuff.
Yeah, I mean, I work to improve it some, but do we want it to include the current subsystem? I mean, we had a suggestion in the email discussion to just list the top level books there and keep it static like that. For example, is a different way of just providing the very most top level navigation. So I'm not sure what we want. I'm probably not going to please everybody.
Honestly, I feel the sidebar is a useful feature. For example, if I'm going through a certain topic and I don't find something on that page, I quickly look at the sidebar and see some other relevant topics in that section. So maybe if certain people don't like it, we can just make it collapsible.
That is something we could consider too. It's just a matter of CSS, and CSS is fun. Did you have a question over there or no? Okay. All right. So on that, I mean, the main thing I had on this slide is I really wish that we did have somebody who wanted to work on the tooling a bit more. That's one of the many things we lack in the documentation area. So if you know somebody who wants to hack on that stuff, send them my way.
Headshot. I agree. It's probably not a good idea to compile something and then check it in. You could just compile it yourself and you can do your own customizations. But what is the community's philosophy on something in the middle where you do have to run an automated thing, but you do have to do some hand cleanup because it's just, you can't push that. And you want to keep it in sync with the current head. What is that? Just, you don't want to put that in as documentation, go make that a different project. Maybe thinking something crazy like requirements, something like that, which are going to float with the code changes. And you're not going to get a developer to write requirements. So you might be able to come up with an automated tool to take a guess at it, but you have to use a human, and then you're going to push those changes. So that's going to be a lot of changes coming in. What's the thinking there?
I'm not sure I fully understand the question. I mean, you're talking about making changes to the documentation after you build it, or I've missed something, sorry.
The documentation is a reflection of code that requires some human intervention. If you're going to run an automated process, you probably just shouldn't be checking that in. You can run that automated process yourself on your own machine.
Right.
But if there is some interim step where someone has to come through and clean it up and say, all right, that's actually gibberish, that doesn't make any sense. So you're going to have to apply some intelligence to it and then push that. That might make sense to push in, but that's also a lot of code coming in.
Yeah, we don't have a process like that now. Okay. I mean, the stuff that comes out of the code, especially formatted in the code, with the idea of being incorporated in that way. So, I mean, we need people to fix all the warnings in it and all that stuff, but there is not a manual step in there. I don't see trying to add that. I don't think that would go over very well. All right. So the last thing I had was just sort of, let's see if I make sure I haven't missed anything here. Debian 10 has Sphinx 1.8.4. Ouch. All right. Anyway, that could be. I'll have to review that. So hopefully that's at least minimally legible. There's a couple of things I want to pick here. This is the process documentation directory, which by some points of view is perhaps the most important subdirectory we have. This is the way that we get people into our development process. So I've put this slide up here because I wanted to make a few points. One, you can see the sidebar, which I think is still pretty messy. And I'm not really sure that helps us in terms of how that is built now. But that's not actually what I wanted to talk about here. If you look at this, again, arguably most important subdirectory of our documentation here, right? We're still starting with the licensing rules. That's the first thing we want our developers to learn is the details of licensing, which I think most of our developers actually don't really come here to learn about. And toss the box back there, Ted.
I don't know if people would like this idea, but something that may help with the sidebar is right now we have the titles of the files themselves, like Linux kernel licensing rules, how to do Linux kernel development, and maybe we could have like a version of those titles to put on the sidebar, like licensing, development, because it's implied that it's the Linux kernel. Linux kernel is said 1,000 times in that sidebar. So maybe we could just remove all those and have like a title that is just like the sidebar version of it.
So reducing verbosity would, I think, make it a bit more legible. Whether that would actually help navigation, I don't know. But that is something to consider, yes.
That, and also maybe put like a bar or a number to help like visually differentiate between the different. I know that there is like a little bit of a space, but you know what I mean?
Yeah, I understand what you're saying. Yeah.
Okay.
And I mean, yeah, it's just CSS.
Yeah.
Somebody just needs to do that.
Yeah, the one thing with the sidebar that I don't think this particular screen grab really shows is it's showing, you know, the duplication between here's a big list of links in the content, here's a big list of links in the sidebar.
Right.
But if you were to go into the licensing page or the, you know, how to submit a patch page, etc., you then don't have that list in the content. And if you want to go to the next page or another page about process, that's where the sidebar is really useful, looking at sibling pages, not child pages.
True.
The Venn diagram between kernel people and web developers is probably not intersecting at all. So is it possible that, I mean, the Linux Foundation already hired people for maintenance of kernel.org. Is it possible that actually some professional web developer is hired to actually handle some of the complaints?
I've had some talks with people in the Linux Foundation about doing that and helping with the structure issues in general. I haven't gotten very far with that. You know, the Linux Foundation isn't a big pile of money, and so they have to, you know, they generally have to go out and actually scrounge up the money from some company that's willing to support that work. And sometimes that works, and sometimes it's challenging.
So maybe something that could help in that regard is I know that a lot of developers don't know how to use RST, things like that. So maybe if companies just provide to this hypothetical employee of the Linux Foundation just a plain text file, then that person could be in charge of generating a pretty RST version. And also we will have like a plain text version for whoever wants to just read it on the original plain text one.
Yeah, that kind of gets to sort of my closing slide if I get that far, which is that support for documentation in general is pretty low, right? We have about 5,000 people who contribute to the kernel over the course of the year, most of whom were paid to do it. There's no one, not a single person whose job primarily is to do documentation, right? And that shows in a lot of ways. The question over there. And so, getting RST help would be running the same sorts of things.
This does seem like the kind of thing that could be paid by the Linux Foundation with the member dues it charges the participating companies, at least part-time.
Well, yeah, I mean, the thing is, there's an awful lot of things that could be paid out of those dues. And so, you're fighting for a finite bit of cash. And yeah, I mean, I talked to folks at the Linux Foundation and have made my desires clear on that front.
I also think maintainers have a bit of a role here. If you push back on people in companies to actually make documentation, they will make documentation. But if you don't, they won't. If you make it part of your we're getting stricter. And I had to recently say to someone, like, if you knack something on this list ever again, the only thing I'm ever taking from you is a documentation patch to tell me that you never have to say that again. You need to be a bit more. The maintainers have to engage with the documentation. They have to want it, and you're not going to get it if you just say, "Yeah, accept your patch." And RST isn't that hard.
No, it's really not.
It's not rocket science, like guys. You're right. You can program C, you can program Python, you can write RST.
English is challenging, though.
Yeah, English is more challenging than RST. Yeah, no, CSS is hard.
All right. I think I have about 3 minutes, if I understand right. I think what I'll do is just quickly run through what I was going to say here, and then we can kind of go on and I'll work to make better documentation after that. I was simply pointing out that we're leading off with licensing stuff, which isn't necessarily what people want to know. I wanted to point out that we have 2 documents completely separate on how the kernel development process works in general. Right? 2 of them written different times by different people, both just sort of thrown in there, separated by completely unrelated things in our top level directory here, which I think is going to be somewhat confusing to people. We have down here more licensing information kind of thrown together. The point is, I don't think this is all that great an entry point for our for developers trying to figure out how you work with the development community. So I sat down and I made something here that I think is not all that legible. We start with the documentation. Here's how the process works. All right. And then we get into some of the more technical guides of, coding style, that sort of stuff. Push the licensing stuff down towards the end a bit, that sort of thing. It's there if you need it, that sort of thing. The point that I really want to make is this took me maybe half an hour to do. But we don't have people doing this, and I can occasionally do some of it, but my time is limited. This isn't my job, right? This isn't what pays my bills. And, I'm working hard enough just sort of keeping up with the patches and all that. I really, really wish that we had some more of this. And just to kind of close with the point I was making before, how do we support this work? Because there isn't that much support for it. There's a lot of things that in the open source world in general don't get the support that they need, and documentation is surely one of them. And Joseph back there.
Echo what David said. I mean, it's up to us as the maintainers to kind of enforce this kind of bullshit, right? We should be, and I think the other important part of this that I kind of wanted to bring up is that, as far as Btrfs goes, right? We have a whole set of documentation or whatever that is adjacent to the kernel. And that's how we enforce this stuff, right? When new features come in, they're fully documented, but they're not documented in the kernel, they're documented in our stuff, right? And I think this is kind of I'm sure other subsystems have this, right? Where we have decided that documentation is really important, but we don't do it in the kernel. We do it somewhere else, right? And so I think, supporting this work is just by us doing it. It's our fucking job to do this. We are professional developers. That doesn't mean we only write code. Our job is to be able to communicate with each other and with our users. And how we do that is through documentation. It's ridiculous to me that you can push stuff into the kernel and not document how to use it, right? So I think it's just a thing of like getting more maintainers like around to this idea that like that's what you're supposed to fucking do to do this job, right?
I agree with that, but beyond just making it the developer's job to document, I wonder if we can make it more clear that it's okay for non-subject matter experts to do the basically technical writing and cleanup and organizing without having to feel like sort of intimidated, like I don't actually know the details, I'm just sort of moving things around. If that becomes more open and saying like, you don't have to necessarily write it, you're free to reorganize it, submit a patch to reorganize it in a way that makes sense for you and have it reviewed. But then who would review that? Like, is there just documentation reviewers, or do we have to include maintainers to do that feedback?
And we do have some people who review documentation some of the time, not at the level that I would really like. Tends to be more typo patrol than the sort of stuff I would really like to see.
So I'm a bit of a newer developer, and I would understand the process as I see something that I want to change. I look up the maintainers file, like, do I find the subject matter experts, CC them, CC the documentation people? How would a newish developer trying to understand a particular subsystem help contribute to that documentation?
So you're asking how you would do it? I didn't quite catch the.
So as a newer developer, I'm not exactly too sure of how I would contribute to some documentation I would clean up. Would I CC the documentation people, CC any subject matter experts, and then contribute? Like my first response was, would it be outright rejected on a public mailing list? And that'll be embarrassing, that kind of stuff. Like what kind of fixes, what kind of process for that?
The process is really the same as for any other kernel change. So, the documentation in the process manual describes how the kernel process works in general. I have added documentation on working with the documentation subsystem specifically, and the sorts of changes I would like to see and so on. It comes down to writing a patch and sending it in and getting reviews and perhaps iterating on it the way we do in the kernel community. Who you send it to is generally determined by the get maintainer script that will look at your patch and tell you who to send it to, which is usually a combination of subject matter experts and documentation person. We don't really have people as such, but there is a documentation list. And you will get comments, and people will be very happy to see help with the documentation.
Based on what you've presented on what the request from the kernel.org documentation, I think the process and the licensing, that cleanup, that top level cleanup is probably the low hanging fruit. I know the process documentation is scattered. There's like 7 docs, and some of them describe half of the documentation for posting patches and using things like co-develop by, and then another chunk's in another place. I think, and that doesn't require subject matter expertise. That requires reading what's there and just reorganizing it. So if someone is looking for an entry level, I'm new to the kernel, but I am good at technical writing, that cleanup I think is the best place to start, because you can tackle the 30-minute thing that you did with reorganizing licensing and all that stuff and clean up the process docs, and you'll draw attention, and there's some warts in there that are long past.
I was going to say too, the one thing I've noticed, sometimes I've seen, like if I'm looking for something in particular, I'll look for the docs, it's not there. I'll start looking through the Git logs for like the area of interest, and I'll find like commit messages with just tons of documentation of like that has the information I was looking for. And so just the thing I want to encourage people to, even if it's duplicated in the Git log, to at least try to put it in the docs tree somewhere in there. Because there's a lot of useful information in those commit logs that are there.
Yeah, that can often be a good suggestion to make.
So I don't think this is a totally novel suggestion because I know there was like a Google Summer of Code where people were working on documentation. But have you been working with like Shuo on the Linux kernel mentorship program, or maybe with like other newbies? Because I think like somebody who isn't already familiar with the material might bring like a unique perspective on like, is the material organized well? So like there was a talk from Joel Savitz yesterday, and I know he's trying to like work on continually improving this like university course by using the students to get feedback from them. Maybe you could also like ask them to contribute documentation fixes.
I think that would be nice. And I mean, you know, I do occasionally talk to Shua, who is in the back of the room there, and so on. I mean, I think the documentation could be a good entry point for people who wanting to work on the kernel. I try to be welcoming to people who come in and do that. I don't get as many as I would like to, and maybe it's because the documentation on how to make that first step is lacking. And yeah, maybe that is where I should focus some effort.
One thing I'd just like to add is, for a while on the K-unit subsystem, we have had actual people employed to do documentation. And it has worked very well, but it's also the very first thing that gets cut when other important things happen at the company. So it's, you know, a short thing. You know, qualified tech writers are, you know, worth their weight in gold on this sort of thing, but it also takes a very long time potentially to get them used to the kernel process, which is very different from what they're doing on pretty much any other project.
Right.
But just having someone whose job it is to do documentation also is a great way of forcing everyone else to at least pay more attention to it, because even if you know, you'll make, I think most maintainers are pretty good at making sure there's, you know, documentation in the code, but then pulling that out to a more tutorialized or more, you know,
Right.
document form of documentation, having someone whose job is to do that is very useful.
So we're actually running about 7 minutes over. I see 2 people who had raised their hands. Maybe we should do that and then let people take their break.
So one thing to add to that was, this reminds me the suggestion from Stephen Rostad at RSFMM about the documentation of memory management subsystem, which is asking maintainers to say, we will not merge this if it is not documented. Maybe we can ask some help from each subsystem maintainers about such a rule. And secondly, this is just 90% of joke, but maybe we can use the sidebar that is nearly broken nowadays as a place for advertisement.
Just a feedback on a discussion I had with a new contributor this week, where the documentation about submitting patches for newcomers may be lacking information that we as kernel developer know. First, send an RFC patch. Then you will get, let's say, improvement comments, and people won't be kind of, well, okay, no, this should not go in, no, knack, right? So all that part, I mean, yes, there's one mention of, oh, the RFC tag exists, but what's its purpose in the flow of sending a set of patches and doing contributions? It's not documented yet, I think.
I think that, I mean, that document is important, could use some work. I hate to make it longer because it's really intimidating already, but yeah, I agree. It could use some work. Sure.
So yeah, one last comment. I do have my mentees submit documentation patches. They go, I ask them to go look at run compiles and warnings and any missing files, references, and so on. When it comes to documenting a subsystem or a substantial document, sometimes they need help from experts. So that's where the problem comes in. So how much time experts have in terms of working with mentees. So I try to do my best in terms of working, but they really have to get deep down into subsystem. So what I'm encouraging them to do is, as they are learning, if they find documentation that's lacking, go ahead and submit patches. That's kind of what I'm doing lately with some people that have gotten the basics down and be able to get there quickly. But just so you know, that's kind of what I'm doing right now. But if you do have any to-dos that you have, just send them my way, because I have about 34 or anywhere from 25 to 34 each semester, each session. So I am looking for work to give it to them.
Okay, we'll do. All right, and I think we should definitely go to the break at this point.
Yeah,
So,
we ran about 10 minutes over. Clearly, people are really fascinated. We'll pick up again at 11:30. Please follow up on the chat if you've got more comments, because I think the conversation could keep going forever. Yeah.
One quick question. The dinner and the message for is there last one?
I didn't see it. Yeah, we didn't organize anything. I think we'll probably have a lot of room. Talk to Trisha at the desk. Okay, yeah, but I'm pretty sure I had like one other person ask. So okay, yeah.
You know what I mean? Yeah, I mean, we need something that is because me as a team, I can say, okay, this is I didn't answer, but I'm not sure. Yeah. 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 Oh, yeah. I also like that idea of just emailing all the maintainers and telling them, hey, I asked her like almost like 1 year. Yeah, maybe 9 months. Then, yeah, because when I wake up the web page, 9 months ago. So yeah. So I don't know, maybe they have a reason. They don't want to do it, but I think they're busy.
It is on the very side.
I always thought like all of my static functions, I leave off that second star.
Yeah.
Because I'm like, anyone who's serious about this stuff. Like the serious technical things are not. Like Kernel document.
Yeah, there's stuff that,
I saw Thomas was doing,
you know, links to the official documents and talks about how we use this, you know, we have a number of our specific extensions. It's there.
You can't start a PVC. Yeah, but it's even before us, you know, so. And then people are just like, I was going through it. No, that is the easy technical.
Yeah.
Yeah. What is this internal?
You know, /** comments
Well, let's
indicate,
start.
well, and then you put doc in capital letters and a typo. And then there's a kernel doc, you know, in the RST files, you put a kernel doc directed to include that in. So again, you can look at the DRM documentation where they've done a lot of this.
Yeah, okay. I just try to find it.
Yeah, if you just-
Like I wasn't able, and I also, maybe I also have to read more carefully the document.
Yeah, it is described there. And if you just grab doc all in capitals, so you'll see where it's being used.
How is it usually the formatting of that?
It's restructured text. I mean, it's usually in a comment, right? But the comment part gets stripped out.
Yeah.
And it's just restructured text, and you can use all the usual RST directives.
Perfect.
Okay, good.
So then I will make it. Follow it.
Oh, you probably don't remember, but I was working on this article for scalar algorithms.
Yeah. Okay. Can I just add?
Drop it. Sorry, I missed one.
It happens. If you ever get back to it,
All right.
you know where to find us.
Yeah. Thank you.
Gordon, hi. I wrote once an article for LWN about pulse audio. I promised you another article and I didn't do it. So.
We've been bad ever since.
But my question is, given how LWN is actually for the kernel community, what's the long-term sustainability of it, given that you are actually looking, you have been looking for someone to actually maintain it for a long time? Actually, I would claim that actually the most important kernel documentation is in LWN stuff. And what's the sustainability story there?
Well, we've been around for 25 years, so,
Yes,
so far so good. I mean, you know, we are trying to.
Given that you are trying to hire for a long time,
I have reason to believe it's going to go better this time. We have a different sort of set of applicants this time.
Okay,
so that's just beginning, but I have reason to be optimistic on that.
Oh, okay.
Yeah, so that's done. Yeah. So thanks actually for all the LWN stuff. That's all what you can say.
Right. Thank you.
So then have a great day. I leave you to break. And ciao, ciao.
So she and everybody's got their time, so if you want to go, that's fine. I asked you that question because I am interested in working with the SD expert about actually doing requirements. And that would be high overhead. You have to do some automated, but then you have to do some stuff. Someone's got to do that. That's a patch setting. Would that be part of documentation or would it probably end up turning into its own requirements folder with its own container? And this is waiting speculation right now. We're not even sure. Like, what's worst case? What's the impact here?
Yeah, and you have to actually see.
Okay.
See something
That's
to
fine.
judge that.
Okay, that's fine. That's a
It
fair
sounds like
response.
something separate. And,
Yeah.
Yeah, maybe, I mean, yeah, I can't really visualize.
Yeah, yeah,
it
yeah.
now.
That's okay. Yeah,
So-
that's a fair response. I appreciate that. Okay. I'll catch back up with you when we have to talk.
You can, at the bottom.
Thank you.
You can change the
Good talk,
time.
John.
I think
Thanks.
you have to change the time at the bottom.
It's one of those things, you put something out there and
Yeah.
people basically run with it.
So
Yeah.
you see when you get.
So I guess some of our documentation seems like sort of coming to being without real purpose too. I think it's probably not something I brought up.
Well, yeah.
Yeah. There's a fair bit of it that it's, or maybe was applicable 10 years ago and less so now.
There are a few things harder
Do you
than
see the
deleting the whole
session?
document.
Yes.
It's
Yeah.
amazing what
So
you run into if you want to get rid of, how to
There will be
get a
red
patch
button
with
that says
ftk.kernel.org and
Yeah.
apply a manually with patch.
Yeah, you need Linus's tarballs. Yeah, kind of thing.
I mean, there's a huge amount of
Let me see.
on the enterprise district's websites, right? First, Technology Center had a whole bunch of.
Yes, I do see you. I do see you.
Red Hat, SUSE.
I do see you. And what you need to do is, there is a plus one, blue button that when you hover there on the screen, you will see it. And then you
I
hover
don't know
there
if
and
we
it
ever
will show
tried to
you,
get them to.
it will say, take risk.
Under,
Yeah, I never really.
public license, and then we have.
And then it should say, take present. Oh, yes, I see it now.
Right.
Not very.
Awesome.
There was
And
probably
then-
some stuff that's worth having. but
Yeah, yeah. Well, especially
to
stuff for the administrative guy.
take
Because they have a
present
lot
from
of stuff
there.
that's oriented.
Yeah.
toward the society.
Yeah, and that would probably be very nice to have.
Yeah, yeah.
We just need someone who puts time to dig through it.
Yeah, and then remove all the stuff.
Are you
that's
sharing
just
this?
specific, Right, yeah.
I am not.
If we had a, energetic contributor wanting to do that, I think that would be great.
Yeah, yeah.
I don't see that I'm going to do that.
Oh, no.
You also did,
I mean, the ideal thing would be.
did you
We could convince.
take the presentation, take.
At those open source companies. and say, look, while you're writing this, you get your management to agree, you'll submit it at the same time to the.
Take presenter,
Yeah, we don't get a lot of submissions from tech writers.
No,
So,
we don't.
yeah, it would be, that would be a real resource we could leverage if it were possible.
It'd be nice.
Yeah. It might be easier from like, I mean, as a Red Hat employee, I imagine you might have a hard time getting them to release that, because that's kind of one of their value adds they see.
Yeah.
And so, but, imagine some hardware companies and things.
And I'm off mute. Okay, I'm gonna hang up. Okay, I hung up. Can you hear me?
Yes.
But,
Okay.
It's certainly happening at Red Hat. I mean, I'd be.
So I'm sharing my webcam. Take presenter. No, if you can't hear me, call me back and I can put this on mute.
Oh, we can hear you, definitely. And
Okay, good.
you
So
just
my
have.
voice is good. Okay, let me just find
Yes.
where I can
Everything is
share.
good. You have to just share the screen.
Okay, let me look. Upload, share an external video, activate. Now, I don't see where I can share my screen. Looks like it wants me to upload the presentation.
Okay.
Is that?
So there should be a screen share on your.
Share camera as content. I don't think that's it. Share camera as content. That's the only thing.
There
I
is a
see.
share screen. I was able to help somebody yesterday to share the screen.
Yeah, I don't. I don't know. I can't see it.
Hmm.
Okay, wait a
Lower
minute.
right corner.
Okay, I think I see it now. Hold on. Share my
Okay.
screen. How do I do that? I think I have to do something different.
So I had an interesting discussion today with some of these guys that are working on CXL.
She did take presenter. She should be
Yeah, I'm
able to at
almost
this
there.
point.
I'm on share screen now. I'm just trying to figure out, it doesn't work like the normal share screen. So I'm just trying to figure out, it's better for me just to close.
That's horrible. but in theory, right, you could have like cost yeah. It's kind of an interesting idea. Or even just like, you could have a file system where you could do a read and it looks and says, oh, this host already has things cached. So they just share the pages. Right. Probably there's a lot of ideas and things. Do that kind of wow. Actually, something for the next generation.
Basically, it's different like idea.
Yeah. But also.
So is it okay we took presenter from here and figure? Oh,
Do you
yeah,
see it
we see
now?
you. Thank you. That's great.
Okay.
We see you, we can hear you.
Yeah.
I'll pull your PDF you sent me and I'll.
Yeah. What I understand too, it's like they don't actually. Yeah, that's the thing about it's always how that works. It's really good, but it's not the most user friendly. May not be that efficient, but maybe one day.
Thank you
Yeah, so
for
from
the
life today, is already working on something. Like reality is more cheap.
More cheap than reality. Yeah, that seems to be it. But these are the from A&B. And they point out that there's potential in the future that we can actually use this across those.
Yeah, that's like kind of individual.
Yeah.
Extended to
CXL 9. All right, cool. I just wanted to. And I was thinking like, per diode, that's something like this. So potentially.
Well, so between guest and the host, you can have it today. Yeah?
Right. But I mean, but this potentially allows, can you use that as a model sort of? That's kind of that sort of file system where it would bring in pages from other hosts that they have. Nice for read most sources.
Oh yeah.
Yeah, just the rights. Yeah, I'm just wondering. We should make sure that's
Dr. Chance, do you want this recorded or would you like me to not record?
You can record it.
Okay, and you don't want us to, if we record though, it will be live streamed. So do you want us to not do that?
That's fine.
Okay, thank you so much. Welcome, everybody. We have a guest speaker today, Dr. Gloria Chance, Chief Psychologist and Chief Information Officer at Musa Group. She will be talking to us and helping us give us tips on how to combat stress and burnout kind of things. And we have been discussing that on our Kernel Summit list. So she's here to help us. Gloria, you can take over.
Hello, thank you so much, and good morning or afternoon, everyone. I'm in sunny California, and I'm sorry I'm not there with you today, but I'm excited to be here. So what I want to do is just, if you're not familiar with my work, I've been doing a lot of work in the mainframe industry with IBM, Broadcom, and some other groups, Rocket Software, et cetera. And my group, I was a former, and I'm still a tech person, but I transitioned to become a psychologist, and I work in transformation through imagination and the technology of the mind. And I think many of us don't realize, I'm assuming everyone in the audience is human, right? So I'm assuming that most of us, though, we don't understand what it's like to be human unless it hurts. So stress and anxiety and those things, they get in the way of us being productive. And it's becoming, since COVID, more and more of an issue. So what we do is we disrupt thinking. We do a lot of things around shifting the way people think, activating the way that they should think differently. Because as human beings, our minds are just like tech. Our mind is the operating system to our body. So whatever we put in our mind, whatever we put in our brains, whatever patterns we create, whatever stories we create, they actually go into our system from communication from the brain, and they create our lives, our experiences, and our health. And so today we're going to talk about psychological safety, how you create it, why it's important, how you support team members, because again, as human beings, we don't live on this planet alone. We need each other. We need to have skill sets so that we can help each other be sort of the best version that we can in the moment. So we want to talk about that. How do you support yourself, and how do you deal specifically with stress, anxiety, and resiliency? And so that's what we're going to cover today. Now, why do we want to talk about psychological safety? Again, the brain is the operating system for the body. And when we interact with each other and with ourselves, it can either be positive or negative. And we have around 10,000 or more thoughts per day. And think about if you were a computer processing that. That's a lot of information. And unfortunately, somewhere between 90 and 95% of those thoughts are the same, and they are negative. And so it's important for us to shift our thinking now into this positive behavior around how do we understand others and engage with others. So let's get into what psychological safety is. It's really about listening and learning. And the thing that I say a lot to very technical people and leaders is that the new hard skills are the soft skills. The things we're going to be talking about today, in the past, they were ignored. But for many of us, if we know what stress has done to us or others in our families, we get the importance of understanding these tips. So to be psychologically safe, you want to learn how to listen and learn from other people. You also want to acknowledge hard work. So really, psychological safety is about, in your environment, you support each other. So if someone's having a bad day and you're not, you support them. If someone needs encouragement, you acknowledge the work that they're doing. You understand and empathize with your teammate, especially if they seem to be struggling. And then you also are trying to create working relationships that are based on positive acts. So in other words, with your clients, with your teammates, with your leaders, you really want to strive towards, you know what, let's not have any drama because there is enough going on. You also want to set a tone of belonging. So part of this, when we look at, all of the different generations living and all the different types of people who are in our environment, it's really worth the effort to build psychological safety, which is around trust, so that you can execute and support. Come in, do your job, go home. And if you want to have drama at home, have it at home, but let's maybe not have it at work. And so one of the key things in psychological safety is empathy. And if any of you have followed me, I've done panels on wearing masks. And this concept is really for all human beings. We all know that we put our best foot forward and we show our best face when we're dealing with people. And so this mask concept is about what we show up with. So I'm going to teach you in this section how being empathetic to others also helps you understand yourself as well, and vice versa. So if we look here, usually when we encounter someone, like you see me today, and you see my behavior as I'm speaking to you, I have expressions or whatever, I'm moving my hands. I have, a certain kind of body language, and you also are seeing each other throughout the conference. So this is kind of the outside mask that we all wear and that we see. But what is really going on, which we don't know, it's not always going on, but what we don't know is what is really going on behind that mask is history, sometimes pain, sometimes trauma, loss, regret, fear. Like, for example, most people know my story that in COVID, I lost my dad. I lost my baby sister. They both lived in New York. I'm from New York. I lost a fiance. I lost a high school best friend and other people. And so during COVID, I showed up like this, where I'm doing my thing, but underneath, I was really suffering. And so it's important for you to get that concept, because sometimes when people behave a certain way, give them a little bit of compassion, because you don't really know what's going on behind the mask. And the same is for you. You also may be going through things that you are hiding behind the mask. And so empathy becomes really important, because it says that, we're able to relate to the fact that people have experiences that we might not know about, that they may not want to share. That also we can build trust just by saying, someone snaps at you or whatever, you don't understand, to go, you know what, let me come back. Let me get back to you. That's empathy. That's saying, you know what, I'm not going to fight you back. I'm just going to assume that something's going on that I can't see and you need support. And also creating empathy can provide dignity to an individual who's struggling. I always tell this story. I live in LA, and I remember when I first moved here, we were sitting in a restaurant in Beverly Hills. So it's Beverly Hills, right, where, the rich and famous are. And there's a lot of homeless. A homeless man walks by, we're outside, walks by the table. And the person I'm with sort of takes their half-eaten sandwich and hands it to the homeless man. And the homeless man smacks his hand and refused the food. And the person was really shocked. What I explained is that this concept of dignity means that, again, I may be homeless, but you don't know my history, what I've been through. And just like you, I don't want to eat food that a stranger has given me. I want to be able to, in the little bit of control that I have as a homeless person, to decide that for myself. So it's just important to provide dignity as a way of being empathetic to people. And so now what I want to share with you is, how can you start to understand some of these things that are going on? Because this is going to help you manage your stress as well. And we will get into some specific exercises about how to manage your stress. So when we look here, the common behaviors and fears that are hidden behind the mask are these four. Most people in general at work, they become either overwhelmed, they feel disrespected in what they're doing, ignored, or rejected. And I'm sure that if I were to ask for a raise of hand, most people in the audience would agree that they've all been down this path, and it doesn't feel good when any of these things are happening to you, whether it's at work or at home. And so here's a cheat sheet of really for you to understand if this is happening to you, and also so for you to understand if it's happening to someone else. So for example, when you are overwhelmed, the intensity of your feelings outmatch your ability to manage them. So in other words, I have all of these things to do, and I feel like I want to crawl under the covers, is what overwhelmment feels like. And here are some emotions that show up when a person is overwhelmed. So these are things that can help you identify whether you're overwhelmed or not, but also how you can identify whether or not your teammate or your partner or someone that you're working with is also going through this. So being overwhelmed, overwhelmment usually impacts the body a lot, and it causes anxiety, which we'll talk about a little bit later. The next one is disrespected, and that one is around the idea that another person's feelings have been impolitely disregarded. So again, if your feelings are disregarded, or if you are disregarding someone else's feelings. Oftentimes when you're disrespected, what happens? You disrespect the person back, right? Because it's like, oh no, you are not going to speak to me this way. And so acting rude and polite, over talking, all of these things are symptoms of someone either feeling disrespected or showing behaviors that are disrespected or disrespectful. And the other two are being ignored and rejected. So again, when you're being ignored, believe it or not, and this was always fascinating to me, when I think about being ignored, I think about it being very cold. Like, I am not talking to you, I'm not responding to you, you don't exist to me. But also being ignored from a psychological standpoint can have a hot form also, which is when you have heated arguments, you're actually ignoring the person's issue. So you would rather argue about the issue or argue about something else, so that in a way of showing that you don't care about the topic. So again, if you are ignored or being ignored, here are what some of the behaviors look like. And usually being ignored, it makes you feel self-doubt. It makes you feel like you're not worthy, and so on. So these are the things, again, that you can start to identify, because remember, in this computer system we have that's called our mind, the operating system, these are programs, these are routines that are built into our minds. And now what we're doing right now is uncovering that this is what our bodies are told to do from our brain when we feel this. And finally, being rejected. So being rejected is probably one of the most serious implications in our psyche. Most people who are rejected are ostracized people, and they can become very aggressive and can turn violent. So it's really important, a lot of times in organizations, there are people who we ignore or we put in a corner because somehow they're different or they don't think the way that we are. I would really caution and encourage everyone to not reject individuals, because this is a person who will be able to sit and ruminate and get frustrated and can really become passive aggressive. Oftentimes this looks like hurt feelings. You can see that sense of loneliness, jealousy that they're not included, guilt, shame, social anxiety, embarrassment, etc. So I think that you could likely identify yourself in any of these feelings. And also you could likely identify that it maps back to some of these behaviors. And so this is how, from a team perspective, that you can support people. So when we talk about psychological safety and human behavior around whether you feel overwhelmed, rejected, ignored, etc., so these are just tips, and these are in the workbook, the handout that's attached. But you can ask things of others when you observe those behavior is, how can I best help you? Hey, it looks like, and you don't say this verbatim, but you sort of introduce it and say, hey, it looks like you're struggling today, or it looks like, I've had a rough morning. It looks like you have to, can I help you? Or, what do you think about what's going on? Or is there something that I've done? So in other words, you can leverage some of these questions, but you have to have context around what's going on. You can also show engagement, again, by asking, are you okay? Tell me more about what's happening, etc. You can also demonstrate understanding and empathy, which is what we've been talking about. You can also sort of say, and I don't know how many of you know what your unique skills are, but when we do branding work, we talk about what is your unique gift that you bring to it. And so if you know that, like if you're a person who happens to be funny, or you're warm, or you're good at listening, you can just offer to say, hey, I'm just listening. Do you want to talk it out? So again, whatever it is that you know that you can offer, that's something that either will support them or is something that you're really good at, it's important in these moments in psychological safety to do those things. And then finally, even especially for yourself, encourage positivity. You know, again, you can do this. We got this. We got this together. But you know, the whole team is here to support you. And most of us think that people don't want this kind of support. But I will tell you, in today's world of stress and change and meanness and madness, people actually do want this support. So I encourage you, if you haven't tried this, to try it. It might feel awkward. And let me just mention another thing. With the minds, anything that you do that is not your normal routine will feel awkward. It's like when you develop a new code and you got to put it into testing. It's not going to act right until you test it and you debug it and you update it. You have to go through a process to get that code. This is the same thing with introducing something new into the brain. It's going to feel awkward. It might not work right first time, but the more you run the routine over, it becomes, your brain will learn, and then it will become automatic. Okay, and so that was about the team and also about some, you know, traditional foundational things that humans struggle with around and how psychological safety can happen. But now I want to talk about self-support for the individual. How can you deal with your stress and resilience? Okay, so when we talk about stress and emotional resilience, there is a cycle. And again, as I mentioned, much of the brain is just like a computer program. It is once you get the routines in, once you get the processes going, they run automatically. And that's how this resilience cycle will work once you get into it. So the first thing that happens is you have a traumatic event, whatever it is, unemployment, poverty, an illness, something happens in your family. Then the next thing that happens is your brain, because of the way you've trained it, says, oh my God, this is like something really bad. And you're going to have an emotional reaction. Usually it's going to be fight or flight. Now that process is normal until you do it for everything. So once you have this, and you notice the word perceive, because if you practice some of the tools I'm going to give you, then your perception of the issue is, yes, this is bad, but back to around to the next bullet here, I have the coping mechanism, the communication, the guidance, the emotional support, and the tools in order to support myself when this traumatic event happens. So it's important to have stress management tools so that you'll be able to overcome these things, because guess what? We want to get to emotional resilience, where you have internal strength, where you're able to be flexible and to adjust to things that are happening that you don't have any control over. Because guess what? Like any good old routine or program, it starts over. Sometimes we get 2 or 3 traumatic events at one time, and this cycle is going on over and over and over in our minds. But if we can get to the point that we have the coping mechanism, then we can have a more well-balanced and emotional resilient way to stay balanced even in the face of tremendous stress. So this is basically what is happening in your mind, and it's driving information into your body. So what is resiliency? Resilience is a muscle. It's just like our brains. Our brain, in addition to being an operating system, is also an organ. It's a muscle. And we don't use that muscle enough. And that's why it feels awkward when we're talking about some of these brain and mind things. So when we talk about resilience, we have to flex it enough back to practicing, back to getting routines going automatically. You want to flex it enough so it'll take less effort to get over trauma and stress whenever it happens. So this is a way that we grow to avoid actions that might lead us into continuous stress. Now, I almost didn't include the slide, and I was going to make it less, but I think in this case, more is more. This is what is going on with stress in your mind and body. And so I do want to call out a couple of important pieces here. And this is where the cycle gets really dangerous for us in today's world. So the ideal state is this resting or working nervous system, right? Where we're calm, our muscles feel relaxed, our mind is focused and clear, our blood pressure is normal, we're breathing well. This is good. But oftentimes we don't stay in this state. So what starts to happen is, as we mentioned in the previous slide, we have a perceived negative event. And when this happens, all of a sudden now, we have either a physical threat or something perceived, and we go up into this space here, which is the danger zone. And this red space, which is the fight or flight, this is how the body works, and it's normal until we have so many different things coming up all the time that we start to stay in this zone where our muscles are tense, our mind is thinking about 100 things, we're releasing stress hormones, which actually shut down our immune system. Our heart rate gets higher, our breathing gets shallow and quick, we can't digest food, and on and on. Unfortunately, this danger zone, when it's repeated over and over, starts to indicate stress and anxiety. And 41% of adults have chronic stress, 41% of adults in America. And if you look at this table here, if you look at fatigue, poor concentration, poor memory, decrease in performance, and on, we end up with so many illnesses like diabetes, heart disease, all kinds of things that land us in the hospital and also can impact our ability to work. And so this is the situation that we go back and forth. Unfortunately, we don't stay in the state over here into the green and orange, which we're going to talk about in a minute. We don't stay in the blue, which are ideal state. We kind of go quickly and stay in this danger zone. So what it really is important is that only human beings, we're the only species that carry stress around in our minds. Worries, fears, expectations, regrets, and self-criticism is what we have to learn how to reprogram our brains so that we get rid of those things, or else we stay in this danger zone and we start to increase the chronic stress and the diseases that it causes. And so again, back to this slide, when we have a traumatic event, in this all that one page I showed you is what is going on when we have a perceived stress event. So the idea in resiliency is to get to coping mechanisms so that we don't come back to this chaos. So we want to get mechanisms that will keep us out of the danger zone. So what exactly is anxiety and stress? So anxiety is rooted in the fear of the unknown. And I actually spend a lot of time working with people and organizations in the unknown. The unknown is actually a wonderful place because it's a place of possibilities. It's a place of what ifs, and it's actually a very creative place. But as human beings, because we're programmed to, I want to know what is getting ready to happen. Tell me what's in this for me. Tell me what's going to happen to me. Because we want to know, we're afraid of the unknown for the most part, and that fear causes us anxiety. And it's very crippling, and it keeps us from moving forward and experiencing life to its fullest. So again, as I mentioned, the 41% of people who are impacted by chronic stress and anxiety, left unchecked, it can harm the body physically and emotionally. In addition, it also impacts our performance. So if you didn't think the psychological safety and understanding the stress matters, it impacts your decision making. It adds pressure to time constraints because when you're not focused, you can't really think and you're not as efficient. It limits your creativity. It also makes it difficult for you to process information. You ever notice when you're stressed out, you just can't seem to remember what's going on, or just your brain's cloudy and you know it. And finally, you default to thinking in extremes. So I also realize when I'm stressed out, whether it's because I'm tired or I'm overwhelmed, I will tend to do extremes like, oh my God, the carpet, I spilled something on the carpet. You know what? Now I'm going to have to replace the carpet. And that's extreme. All you got to do is clean up that one section. But you become irrational when you are also under stress and anxiety. I don't know if anybody can relate to that, but that's an important thing to get. So what we want to do in order to help with this and keep us resilient so that when we have problems come up, we have processes to manage them, we understand what's going on in our body, or we understand what is happening a little bit to someone on our team. We have the empathy because we have psychological safety to say, can I help you? Let me help you. We want to do a brain check. And I like this slide because the brain, again, it's not only our operating system, but it's a muscle. And it needs to be worked out as well as all the other organs in our body. So I'm going to share some things with you. And because I'm not physically there, I won't be able to necessarily demonstrate, but I will walk you through some of the techniques that you can use in order to be able to start to shift your brain so that you will learn how to be more relaxed when things occur. Okay, so here are some relief valves that make you more resilient. So one of the things as a stress buster, here are just a couple of tips. You can plan breaks, rest, and fun. Now again, some of these things you might be like, oh my God, we've heard of this stuff, but have you done it? Just taking a break, like some people will say, well, I'm taking a break. And what that means is I'm going to read about this, this process while I'm sitting down on the beach. That's not a break. The break is for your brain. If you're still working, but your body's resting, that's not what we're talking about here. We're saying that your mind and your body are both resting. They're not doing anything, but having fun or resting. You also want to develop realistic expectations. There are 3 things that we believe in psychology that makes one happy. And one of them is having realistic expectations. You know how we are. We will plan all of this, but we really have time for this. So being realistic can also reduce stress. You know what? I really want to get this code done or documentation or the user manual, whatever it is you have to create. I want to get that done by next week. And in your mind is saying, no, you can't, but you still commit to it. And so listen to yourself and develop realistic expectations, and that will help reduce stress. Also prioritize your work and also ask for help. If every one of you who can hear me start psychological safety, i.e., I'm supporting my environment, I'm helping others, then you have the space to ask for help because as a team, you all are there to support each other. Also, eating well. Again, the body is the fuel, and that when we eat, it gives the body fuel. It also gives the brain fuel. So again, it's important to eat well. We all hear about exercising, although, studies are really changing the advice on how to exercise. So read up on some of the new things and see if any of those will work for you. Like now there's lazy exercising, which I really love. There's this thing where you can lie in bed and they show you how to do the leg lifts and the arm lifts and how to run in place in bed. I mean, that sounds like amazing to me. There's also like wall Pilates now where you can just lay on the wall. And actually science says that these things really help. It doesn't have to be this full out, let me put on gear, let me run up the mountain and down the slope. And you don't have to do all that. So figure out, do some investigation about what kind of exercise can work. And finally, on the exercise, even now the sprints, like 3 to 5 minutes of exercise, throughout the day also can be really important. For those of you who work at home, for example, in my space, I have exercise balls, medicine balls, weights, and all of those things integrated into my workspace so that when I'm taking a moment, I can just pick up a weight or get on the exercise ball or something. So integrate exercise into your room. And then finally, learning a mindful technique, whether it's meditation, yoga, Tai Chi, Qigong, just try some things because training your brain to be calm is one of the most important things that we can do. It will help everything in your body be calm, and also it'll create a life that is calm because when you are calm, the way you approach people is calm. Usually the outcomes that you get are calm. And so you really, this mindful technique piece is very important. So let's look at a couple of techniques. So when we look at relaxation techniques, and I love this one because I always ask people, how many people in the audience are holding their breath? Pay attention right now. You're likely holding your breath. So what I want you to do is I want you to just in your chair, just sit comfortably. And I really appreciate those who will do these exercises with me. So now I want you, as you notice your body, just turn your awareness and notice your breath. Are you breathing? And let's go ahead and take a deep breath. If you just hold, just take a deep breath and release it like a really good deep breath. And I bet that you will notice that immediately you feel a bit more relaxed. When you're relaxed, you're able to notice more things, you're able to do more things. So just simply breathing is important. It shifts you from an automatic response. So in other words, if I'm not breathing and you walk up to me, likely I will probably be startled. And probably I'm going to look at you and go, what are you doing? Versus if I have breath in my body, I notice that you're coming. You're not going to startle me. And I'm going to say, hey, how are you? I'm happy to see you. And so that's an example of how a small thing like making sure that you have breath in your body will help you be more calm. And also, if you're in a stressful situation, remember to breathe because that also can bring down the stress. And it signals your body to calm down. Now, the next technique that I want to look at is around something called cross crawls. Now, this is about, and most of the work I want to tell you that will help you reduce stress is mind-body. Whenever you can do something where you can engage your body and also your brain, that's when you're going to get the most results in the quickest way. And so part of what we do, a lot of the work that I do is around integrating the creative mind, which is in the right side of our brain, to our logical mind, which is the mind that we use to do coding, to do business, data analysis, and those kind of things. And we use 20% or less of the right side of our brain. So when we engage both sides of our brain, it helps us think better. It builds our immune system up. It gives us more creativity. And again, you can see things more clearly. And so here, what you want to do is you're just basically alternately touching your right hand if you're standing to your elbow. And you can also do this, sitting down. So you touch your right hand and elbow to your left knee. So and some of you have probably done these exercises before. You're basically just doing, touching elbow to the opposite arm. And you do this for 25 times or 2 minutes. And again, these are good exercises because, we all work from home and we generally sometimes work around the clock. These are things that you can do in short increments that will reduce your stress. So I usually do this when I am shifting between doing like boring administrative work to wanting to now start to sit down and to design something, design an experience. I'll usually make sure that it sort of signals my brain that I'm going to do something different. And then by, again, engaging my mind and my body. While I'm doing this, what I'm thinking about is just allowing my mind to wander about the next thing that I'm going to be working on. So, and it's amazing because the brain, by the way, has this executive function that's in the back of the brain that is always on. And so when you're trying to work through a problem, you know how you can't find a solution, but you get in the shower or you take a walk and or you go to sleep and voila, the answer comes. It's because the brain, again, it has a background system that's always working. It's like when we're looking at security, security code is always checking to make sure that applications are safe. Similar thing that it's checking to make sure that the things that you haven't figured out, that it's working on them. So this exercise will help you also problem solve. Some of the things you're trying to work out solutions may show up when you're doing the cross crawls. And then the lazy 8. So this is one of my favorite ones. And again, there's so many ways to be resilient, but what I'm sharing with you are more sort of office related things that you can do, that are things that you can leave today and begin doing. And so again, if you follow these directions, you're making a fist with your dominant hand and you're positioning your thumb up. And then you're going to hold your arm straight out in front of you, bending your elbow slightly. And the idea is that when you lift your thumb up slightly, you're going to begin making horizontal figure 8s. And if you notice, if you can see me, my eyes are following the horizontal figure 8. And if you were to do this with me, you will notice that you get a little bit, but do it slowly because you can get dizzy. When you do it slowly, again, it's making you focused. It's making your mind focused. And if you do this for about a minute or two, let's say you're outside you're going into a meeting, you know it's going to be stressful. You do this, it focuses your brain. So again, you're out of I'm not going to rush and be stressed. I'm just going to relax and focus. Again, you're breathing while you're doing all these exercises, you're making sure that you're breathing. Now this, and then you can do it if you want, you can do it with your non-dominant hand and then do it again. And also this one I like because you can doodle. If you're a doodler, you can doodle on your paper. When you're in a meeting, let's say you're getting stressed out about something or you're disagreeing with the speaker, and hopefully no one's disagreeing with me, but you're disagreeing with the speaker and then you are just, whatever it is, silently, you're writing on the paper, you're doodling. And if you do this slowly and let your eyes follow it, you will notice that you will begin to get relaxed. And if you're upset, your temperature will start going down, down, down. And you'll start to feel like, okay, now I can handle whatever this situation is. Okay? And so this particular one looks like a lot, but it actually really isn't. This one I absolutely love. It's like I guess it's my first favorite. The one before is my second favorite, or maybe they're tied. But why I like this is because if you do this exercise, it will feel like you just left the gym. And it usually takes 1 to 2 minutes. Again, a lot of these exercises, once you do them enough, remember, we're just like a computer. Once you program this into your brain and you do the routine enough, it becomes a pattern. And then it will automatically start operating without you having to intervene. So the idea is that you're tensing muscles. So you're going to sit, let's say, in a space, close your eyes, and you focus on your breathing, right? And again, the breath becomes really, if you don't remember anything from this presentation, can you please just remember to breathe? If you can breathe, that'll start to unlock and release so many things in your body that you're walking around carrying. Because when we don't breathe, we're stiff. Our shoulders are up, our neck is sore, and so on. So that's why we want to get comfortable and breathe. Then I want you all to try this in the audience. Use your hand to make a tight fist. So you're making a tight fist. And then you squeeze this fist for a few seconds for like as hard as you can. And notice all the tension in your hand. Just notice it. And then if you slowly start to open your hand, so visualize that you're opening every muscle in your hand, one muscle at a time. So you're doing it slowly. And you will start to notice the tension leaving your hand. And eventually your hand will feel lighter and more relaxed. And so if you were to do this for every muscle in your body, like you can now start with your shoulders, you can tense up your shoulders and hold it for, a few seconds, as much as you can, and then slowly releasing your shoulders, you start to feel like, oh, okay, wait a minute, my shoulders now feel more relaxed. And so you actually can do this for your entire body. As long as it's not an area, like if you have an injury, let's say, then we don't want you to tense up the muscles in the injury area. But these are this is again, really short, very simple techniques. But if you do them, I promise you that they will start to relieve and reduce your stress. This is an entryway to get into stress reduction and resiliency. And once you realize that these things work, it will encourage you to explore other modalities like maybe meditation or other things. So what I'm sharing with you are tips that you can do now without leaving your office, without having to get up and do anything. So there's no excuse. You can try this now and then move on to the larger and bigger things. So this is removing anxiety. And again, I encourage you, I think you guys are going to lunch after this. I would encourage you, when you get back from lunch, try this exercise, because usually we're sluggish from lunch and we're not awake. This exercise makes you feel like you just worked out, so it will wake you up. And then, the final thing, which is a whole, I can do a week or 2 or 3 or months course on shifting your thinking. This is probably one of the most important things that we can do, because remember, the majority of our thoughts that we have, and we have a lot of thoughts every day, tend to be negative. And so it is important for you to begin to, as you take a breath, recognize, what am I saying to myself? Did I just say, you know what, I don't know why you're sitting in this conference, because you have all this work to do, you don't have time. That's negative. I don't know why I'm sitting here listening about psychological safety, because it doesn't work. That's negative. And so on. So this is why we have to shift our self-talk, because when we shift our self-talk, it shifts our thinking, and our thinking really equates to our behavior. So again, just like a computer routine runs, our behavior, based on what we put in our minds, our behavior shows others what we're actually thinking, whether we believe it or not. And so in this way, we look at this concept called fixed mindset and growth mindset. And again, I'm just going to spend a moment on this, but it's sort of like, for example, it's embarrassing when I make a mistake. And most people are embarrassed when they make a mistake. But if you're in a psychological safe space, hey, look, everybody makes mistakes, and mistakes are opportunities to learn. So it's like, okay, yeah, I didn't do that so well, but what did I learn from it? Because when you can have a more positive outcome, then you're likely going to take that learning into something, and you're going to keep growing, so you make less and less mistakes. I don't try new or difficult things, then I won't fail. So for example, why would I try these silly exercises? Because it's new and it's not going to make sense, or it's not going to work. But the positive message in your mind should be, you know what, I have to try new things and or difficult things in order to grow. Even if it doesn't work the first time, let me keep trying, because I want to find something new to do. When I fail, I get frustrated and give up. This is what most people do. Well, when I fail or get frustrated, I try again. So you can see the difference in the way that we're thinking, or when we say, I can't do that. Well, no, I can't do that yet, but I'm going to keep trying new strategies or asking for help until I understand how to do this. So you can see the importance of shifting your thinking and how that can make a significant difference. And so in closing, I just want to offer that, there's no separation of mind and emotions, and even because they're linked together to your learning and to also the way that you show up. So I hope that in this short time that I've been able to give you some tips that you can use, that you can start, so you can start the journey of trying to manage your stress so that you can be and contribute in the way that you need to in your organization and also in your life. And then finally, we have set up, and I just want to say how impressed I am that the Linux Foundation has set up an opportunity for you all to spend time with me at no cost to you. If you go to this calendar, you can book, believe it's 20-minute sessions, and I can help you with the stress reduction, or you can ask me any question you want about the psyche or something that you're challenged with in the workplace, as long as it's something that we could deal with in a short amount of time. And so here's the information to do that. I wish you all an amazing rest of the conference, and I wish you all the best in your future endeavors. And more than anything, I wish that you will become more resilient in ways that will reduce your stress and anxiety, and also that you create a psychologically safe environment in your workplace. Thank you so much.
Thank you very much, Gloria. Any questions you might have? Looks like everybody is taking your tips and they're going to use that. And then thank you for showing that slide for the booking time with you. Thank you, Dr. Chance.
Thank you so much. Have a good rest of the conference. Bye-bye.
So lunch break looks like. After the lunch break, Ted asked me to close this out and come back after the lunch break. Yes. How do you think?
I think like the sponsorship from personal section. What does LF ever do for
This bringing Janssen is, they're paid for all of this, right? So yes, I know I kind of went and said, hey, we got to do this, and then last Monday.
It's good to see them. So she's right. I have always been saying. She's robust. And then. There's yeah. And so, last time on. And they have their own, they get off on that one. He doesn't talk. And Michelle.
I put lipstick on. What do you guys think? It's dark pink. It's dark pink. I don't want to use it.
Great popsicles.
You're allowed to read. Yeah. When you were talking about. Okay.
Providing a framework. Yeah. Hard out of the way. That's what it is. Until, you know.
Tractor door.
When I live in Ottawa, I didn't have cars, like really clean schools. So Richard does back there. And then he's like that.
Yeah, that's what it is. It's the way that I remember. Yeah.
Oh, it's part of my.
Oh, I didn't realize it.
Yeah. Good thoughts. I don't put it forward. And then when I'm scared,
So he's looking at.
I wasn't working with it. I bought the organ before I had my phone.
So same here, he's living in the person, I mean, from one party, digging it all, but living in an apartment with a bunch of organs on the same time, to get the form to sort of. And so, several months ago, where the zones uses to, people say that after doing like that, put it in silly and, figure out some way of getting the apartment design for the stupid ideas that one bicycle. Sure.
Basically, you're going to $7 per day, help them stress. And so.
Truck up a little better.
Right, which is, you know, for Kernel, getting the marbles, Washington. So we find projects really focus on, like the first one is the
Wow. Yeah. Here, pick up my return fire on my bike.
Yeah, the closing dog clerk was, I was going to use it that kid comes over there, clipboard, as soon as he's marking down.
Yeah.
Customers, vehicles, everything. Kind of pull up on it. But they, really play. So the jurisdiction, in our area for issuing license plans on carry government. So somebody in our guys in the passenger said, auto, human driver vehicles, HPV logo. And it's exactly the same font, and colors, all that kind of stuff like that. So it's like, somebody looking at it. Kids, yeah, all of this. A lot. You go, you all one of them.
Did you live in something? No.
Yeah. You did.
You live in
I know.
I'm sure you're sorry.
I'm
trying to imagine Oregon or the Washington.
Wow.
Sometimes it's serious hearing and so.
Even in my van, working is not, the van is not, I was taking my work, I don't know.
Yeah, this thing, it's a tandem. So it's a lie down train. So it's very low, but.
So it's definitely.
No, no, it's very stable, because it's 3 wheels, and there's 2 people. Because it's a tandem. So, always a tandem, you change, and as you phase, they lean over to a wheeler, you don't want to strong. Right, it's stable, so you can put them by phase, and by the day, with the one phase, you get some asphalt on the force of one dimension. You can cover them for dead spots in their cycle. So, and the gearing in that truck, well, I have it customized, and it's a ridiculous application. So most, bikes, the lowest gear is like 4. Most road bikes are 42. The low gear is 32. So it's a winch gear, and yeah, we won't get there fast, but we'll get there. You can't do that like, oh, that's. We've had people where years later, something like that, oh, yeah, there was something. Yeah, I noticed the really big one in the center. The one that worked. It falls in the realm of what's called the SE. Somebody else's problem. You read the SE field from starting out. Yeah. Yeah. I mean, like the left rail. Oh, I very impressed with this. I custom ordered it. They already been building single families, but one. So they had like working units like too long. So I'm the first production unit.
Oh, new essence, like 20 years.
I think they made a total of about 3 dozen.
Wow.
we asked her to do something how far didn't it, and I had to seriously think back and count. But I think I can even say, you know, about the sentence I should say, and I can adjust it. Some of it, I wrote out all.
That's what I learned.
All of a sudden, our hands are down on the lake, like, up on the hill, looking down, and everybody's like, can't see anybody. It's even better, yeah, you can see the lights. And the road I'm on, the boundary between the municipalities, the village, down the hill, and my house is in rural, you know, farming municipality, so my property tax is that's
And you're on hills, you have a higher ground than the microphones and unfortunately, they'll be short, try to count.
You can roll over and
It's an hour. I mean, well, it's a political problem, right? It's a problem. Your neighbor or.
Well, in your area, so like I was noticing riding through there, same history.
Some more.
It's
Never shoot like.
1790.
Something bigger. The area I live in, 100% until the English British people started building, you know, mills and factories.
And they needed labor.
And they needed labor, and all the French came from up north and back there, you know, driving beavers and whatever else, right? That was labor. So the transition gradually happened. My village, when I started coming from what happened is about 80% English now, 60%.
I'm still a bit puzzled why I know the name North Hadley. It's a tiny place, and yet, you know, 400 kilometers away, it's a place that I know the name, and I'm trying to figure out why it's this when there's so many little towns.
Yeah.
Through the area.
I mean, it's all the responsible Americans from the South. That needs a summer place that wasn't as hot and humid as the plantations in the summer. So they built all these huge mansions around the lake, and they built the railroad coming up from the States so that they load their entire family on a railroad car and take the train up to North Hadley for the summer and enjoy it. Not as hot and humid.
So coming from the south, I'm vaguely thinking that there might be some kind of Unitarian connection, but coming from the south doesn't sound very Unitarian. I know that there's some Unitarian activity in Boston.
Yeah, these were mostly plantation owners. So there was nobody in the winter and all summer. There's still all these mountains that, we have an airport in Sherbrooke, the next major town, close by, and it was built by people with cottages that needed to be able to fly in now after they can't take the railroad anymore. So now they're flying in. They extended the runway and everything so that they get just or whatever they're climbing on. Anyway, I've not met any of these people. I just, they don't go hang out with the locals. feeding the village, right? So they have staff that come to go to the office and that kind of thing.
Didn't think so.
Well, we have a few friends down there and stores down here. For groceries and mail, food stuff, but it's,
The race is probably, yeah.
yeah.
Some people in here, watercraft, a little late, dude.
Everything came from the bottom. But friends with the cottage family. That you can't drive to or walk to, really, you know, really get there by boat.
That's an idea.
I know, you get to my boat.
Just need an adapter for the gear and drive it for color check.
Anyway, and that's where it's from. That, every summer. I don't know what, where it's from, but it does.
I usually can.
Yeah.
You know, it's basic. That's basic.
Chicken?
Frank.
Great.
RTB.
RTB. Yeah. Charging it up. I mean, normally around this time, it was still be like about 5 hours of power left. But, just in case you want to charge since it is an hour and a half. Yeah. And now all of the charge. Including the batteries. Okay. Let's see a little bit. Okay.
where we were.
The Android one?
Yeah, I was allocating a whole bunch of other objects, and then I put like the majority of them back.
Yeah.
But we ran our benchmarking, whatever, on perf, and it didn't show that we're wasting all our time in alloc.
So we do perf on the servers.
Yeah.
And they screwed up perf on the files. So it could be that you were only profiling half the cores because of the big load time. So it could be that. There's all manner of things, but I need to go and speak to the Android people and say, can we not have two versions of perf, the Android one and the Extreme one? Because people get confused. There's bugs in your one. If it's all in the kernel, people will fix issues with it. And you know, any features that you have that we don't have, we're happy to merge that.
I noticed that they use they don't use perf, but they use
simple perf.
Yes.
Yep.
And it had a different flag. It had like a capital F or a lowercase f, and I had the reverse in my call.
And then the main reason is they do the stack capture thing, and then they do like a dwarfing line through the stack capture thing, and then they write out to the data file the as if they had frame pointers version of it. And so then they can use the same second one, but in Android for profiling, as debugging, for everything.
Yeah.
But they have like half an engineer working on it, and the amount of stuff that is like on top of that, and there's a kind of open sourcing way it's more over the board.
Yeah.
You know, it's not like
I'm familiar with this. Yeah.
Yeah, so you can send them patches and they'll go like, isn't that cute? You know, we won't merge it. Like, thanks for the thought.
But now it's open source, so I don't have to worry about any ramifications. Good here.
Yeah.
So that's probably what we're hitting. Because it doesn't make sense to me why we weren't seeing a huge amount of wasted time for her.
It could be that. It's. I know that's a problem. We did a fix it in 6.5, but the fix in 6.5 requires you to have like a 6.5. No, it's fixed in 6.6. Requires you to have like a 6.6. 6.5 code will work. On the kernel side, you need 6.6. And but that doesn't impact the simple perf, which doesn't allow you this anyway. And their thing is like don't use like the inbuilt events. You should always use like CPU defined events. But then it's the case of like, well, so like the big cores will have LTTLB and the little cores won't. It's like that.
Yeah. I could see that being a huge pain in the ass with trying to track as things switch around for us.
Well, what we do is if you have a task and you open an event on the big core, you open an event in the little core. When you get together on the little core, that the little core event counts, and when you get together on the little core, the big core event counts. And then we aggregate them. We show them as two separate accounts, but there's an option so you can see it as a single account. Which maybe the wrong set of defaults is the set of defaults that we have for us. But you know, people didn't sit around in a room and go like, this is how we should do it. What happened was like Intel, like, we're going to launch a processor like this in like 2 months, we want to merge all these patches. And we were like, that nobody wanted to review it because it wasn't like nobody wanted to have fun. The guy who did review it like said, I guess so. And so it all landed, and then I had to clean up the mess.
Great. Am I the one who sent you the patch then for the, there was like I needed something moved in the header and I had to move it all the way back to common code. I moved your implementation of something back out of tools and testing.
We haven't got
because you're in tools perf, right?
We're in tools perf.
And I'm in tools testing radix tree, and I was using something that was defined, I think,
Something
in
like
tools,
that.
and it might have been a lock. RW semaphore lock, I knew.
Oh, yeah. I did some stupid things with that recently. Because I added a define so that we could use a mutex rather than a lock. Because if you're using mutex, yes, you can't have multiple readers, but you can get the problem we had is we had people taking the read a lot recursively.
Yeah. Maybe it wasn't that one. I had two things that I needed to fix, and I eventually had to bring it way back.
I also tried to add the thread safety annotations to the relevant to the mutex stuff for most of the use.
Yeah. Because I use that for my user space testing plus URC.
I did some new obscure and stupid, which is, do you know how much OpenDIR allocates when you do an OpenDIR?
No.
Minimum is 32K. So imagine you're traversing a file tree recursively.
Yeah.
So it's like a store tree, you go to an
Yeah.
32.
So
Perf does this
Right,
for
yeah.
discovering more
And,
trees, and it ends up allocating.
You don't have any demos, right?
Oh,
You're just
boy.
presenting your slides. No demo.
Really
Okay, great.
good
So we'll
discounts
just,
and so on.
you can just present.
Not only your
our
programs
laptop,
not
we'll just
released,
switch
but
the slides.
often you want perf not to be running.
Yeah.
And who picks 32 kilobytes? So I did a version in the tools API IO, where I tries to stack out
Yeah.
its multiple buffer. Maybe it's too little.
I'm guessing 32 gigabytes is like the maximum length of something or whatever.
No, minimum is 32 kilobytes, maximum is 1 megabyte. And they
Can I
based
download
that
this
on
again? I mean, I have uploaded a new version of the slides just 10 minutes ago.
Yeah.
What, you want to make changes or? I have uploaded a new version of the slides. Oh, yeah, okay. Yeah, sure. Do you want to upload it to Indigo or can you just download it from here? I can download it here. Okay, yeah, just
Maybe here.
And the only thing it really contains are file paths. So you've got to think like a directory where all the file paths concatenated would be 32 kilobytes in size.
Oh, I see. You already uploaded the new version to Indigo.
Yeah.
Yeah, okay.
But how can I download this?
That's print, the other one. Cancel.
Sounds like a standard guide is never adjusted. This ought to be big.
Back.
Probably somebody who's benchmarking.
Upload manage.
But you grab all the memory in the system, I'm really fast.
And then browse.
Okay, this one.
You have to wait for it to finish. Yeah, sure. Downloading, but it should be there.
Makes my structure 206 bytes. Very large.
Processing.
The thing is, I was like, okay, we've got OpenDIR, ReadDIR, they've really been, so I guess like the C++ guys, they've like
Okay, there we go.
of these and chosen some reason.
Cool. Yeah, that's your new one.
Okay, great.
Another 2 minutes or so.
It's funny how much similarity it is to the different things that we've seen. Your constant pointer to itself, and and my pointer to itself when it's considered dead. What did you call that? Not the tomb farms.
Oh, the Brooks pointer.
Brooks farm.
Yeah. There's also a similarity, so if you're doing knowledge collectors, there's you have like what we call abundance, where you have like small arrays with a big backing element, And the big backing arrays are useful. Because the other thing that I want to then point out are the small arrays. So you can take advantage of that for doing, so that you can, if you want to relocate in a way, like you can relocate like a single Canadian array. And it's quite a lot of size. In that.
Oh, interesting.
Right.
Array that's
Even that's, yeah, like small.
Okay.
My daughter is 7. Everybody else.
All right, we've got 2:30, so it's time to resume the Kernel Summit. And the first talk is Damon, Current Status and Future Plans by Sungjae Park.
Thank you, Todd. So yeah, thank you very much for joining this talk, and let's get started. So first of all, as always, the views expressed herein are only my own, not from my employer. And so my name is legally Sungjae Park, and I have a coffee shop name, SJ, and nowadays I prefer SJ because it's easier to consistently pronounce. So please feel free to call me SJ. Currently working on AWS and currently maintaining a small Linux kernel subsystem called Daemon and its user space tool Daemon. So today I want to introduce about Daemon in a nutshell in short time as much as possible. And also I will provide you some Daemon side updates that made since last year's Kernel Summit talk because there was some more changes. And also, I'd like to spend some time for sharing the future plans of Daemon that will include 3 small sub-projects for Daemon itself and 2 more projects that will use Daemon as its framework. And finally, conclusion and remaining Q&A will follow. And also, because I'm almost always very bad at managing time, I will try to keep time for each of the topic, and we'll give you some Q&A time at the end of the topics. But if you have some questions, please feel free to interrupt. Yeah, so Daemon in a nutshell. So why we are doing all of this kind of crazy thing? Because the demand for memory is increasing while the costs are not dropping like the demand. And fortunately, there are some hardware solutions like CXL memory or somewhat interesting things, but unfortunately, those will not come as a drop-in replacement, and therefore it would be difficult to get free lunch. And therefore, we need some software side change to maximize the benefit. And therefore, we need some more access-aware system operations. And how we can be access-aware to that, we first need to be able to monitor the data access pattern and understand that. And how the data access would look like over time. So if we draw a picture by time and the address range of the memory, we will show access are being made sometime, somewhere, occasionally, like this way. As time evolves, the access will be made in various address spaces. And what would be the ideal shape of the data access monitor? That should capture all the access of the picture, and for the space granularity would be ideal to be bit. That is, it would be ideal if we can monitor all the access in bit level, or maybe electron level would be even much ideal. And in terms of the time, it would be very ideal if we can catch the access in 1 second divided by the CPU frequency divided by number of CPUs.
then that would be really ideal, right? And in some case, because there could be some more case, it might be better to pursue speed of light. And also, how much of these pictures should be recorded to get the full picture? Maybe we should at least start from the beginning of the monitoring. And if possible, if we can have a time machine, it would be really ideal if we can start from the Unix timestamp 0. Yeah, these are just ideal thing, and therefore it would be really hard to achieve. And therefore, Damon starts from the fixed granularity monitoring, and in here, the fixed granularity is just letting users to somehow know best one and set that. For that, Damon is providing two parameters called NR mean regions and sample interval. Those are 10 and 5 milliseconds by default for those. And then Damon checks access to only one page per region. Here, the region is the total monitoring target address space divided by the NR mean regions in same site. And here we believe that the users are wide enough to know the regions, the pages in each region would have similar access frequency, and therefore we believe that we are okay to sample access to only one random page inside each region, because user will be wide. User know many things, right? And so if someone wants very, very fine-grained, accurate monitoring research, then they may be able to set the NR mean regions as the total monitoring target memory size divided by page size. Then they can do the page granularity monitoring. And we think that that is good enough, but maybe we can further compact the amount of the recording output, the monitoring output, by aggregating some of the sampling research. For that, we introduced new user specifiable time interval called aggregation interval, which is 100 milliseconds by default. And then we count number of the sampling intervals that we have found the access to each region per aggregation interval. So we count that from beginning of the aggregation interval and then reset that at the beginning of the next aggregation interval. In this way, we can know which region is how frequently accessed. We call this counter as NR accessage or just access rate. In this way, we can further compact the monitoring research size. And then let's remind the definition of the region. So the region is supposed to be formed as all the pages inside the region are having similar access frequency. And therefore, that would make no sense to have this kind of snapshot because there are 3 regions that having similar access frequency. And therefore, we can merge adjacent regions that having similar access frequency at the end of the aggregation interval and then let the users to show the merge done snapshot. But the access pattern will change over time dynamically, right? And therefore, the merged regions will not keep the good definition of the regions. And therefore, we split each regions randomly at the beginning of the aggregation interval, which after user has already seen the merged research, we split those in random way. In that way, by continuing this at the beginning of the aggregation interval and end of the aggregation interval, we can make the split operation to revert unnecessarily merged regions operations and vice versa. And we can, and therefore the definition of the region still makes sense, and therefore we can continue sampling only one page per region. And here, because the number of the regions cannot exceed some of the range, users can set a minimum and maximum number of regions using 2 parameters. And then Damon will avoid doing splitting and merging operation if the research of the splitting and merging can violate the user-specified range. In this way, users can control the accuracy and the overhead. And we wanted one more thing. So we now get some make sensible snapshot research, right? But each of the snapshot is having only the information for last aggregation interval. That could be a very short time, and it would be not sufficient to make some wise action. And therefore, we add one more count per region called age. The age is the number of the last aggregation intervals that the region was having similar access rate. And therefore, now each of the snapshot can have some of the history information. As a result, we can say that Daemon as an access monitoring research snapshot generator, and the users can record that or just use each of the newly generated snapshot. So in short, the snapshot that Daemon provides answers to which memory region is how frequently accessed for how long time, with controllable overhead and accuracy. And these are the snapshot outputs that you can get using Daemon user space tool. From this point, by showing this snapshot, someone might think that isn't this information enough to make some kernel just works? Say, we have found the 7 megabyte regions that not accessed at all for 59 seconds. And there are some regions that accessed 100% time for 12 seconds and 17 seconds. So maybe we can make some wise operation to those, even inside kernel. And therefore, we made a new feature called daemon-based operation schemes. It finds regions of interesting access pattern of the users from the snapshot and then apply a requested action. For example, we can page out memory regions that are not accessed at all for more than 2 minutes, or use THP for access regions that showing 50% access rate for more than 1 minute, and et cetera, and multiple requests can be requested to Deimos. And therefore, Deimos receives firstly 2 basic parameters called access pattern and action. The access pattern is the access pattern of our interest, the user's interest, and it can be specified as 3 ranges of size of the region, access rate of the region, and age of the region, and therefore 6 parameters in total. And of course, we need to receive the action input, which can be some memory operations like page out, use THP, use regular page, etc. And the target access pattern-based specification of the Deimos target region can be effective, but not that easy to be tuned. That is, it at least requires to set 6 parameters, and the optimum variable would depend on the dynamic characteristic of the system and workloads, and therefore it could be very challenging to set the maximum values. And therefore we introduce a new parameter called quarter, which can be set by user to specify the maximum amount of resource that Deimos can use to apply the requested action to the memory regions in specifiable amount of time. For example, we can ask Deimos to page out memory regions that are not accessed for more than 2 minutes, but up to only 100 megabytes per second. In this way, we can avoid Deimos consuming too much system resource or making too radical change to the system. And also, inside the quarter, Deimos is prioritizing the region and then apply the action to more prioritized regions first. And this prioritization logic is based on the context. For example, if the action is page out, colder pages are prioritized. And if the action is, for example, using THP, then more hot pages are prioritized. So that was the Daemon basics. And any questions about this side? I think we have about 2 minutes to handle this. Of course, if you don't have question now, you don't need to ask right now. We will have the time for remaining Q&A. If not, I think we can just go forward on more time, because the real topic that I want to discuss with you is the final one. So let me provide some updates that made on Daemon since the last year's Kernel Summit. So the first major changes that we have made on Daemon after last Kernel Summit was not that I have shared as a plan at the time, but a new feature that requested by some users. So actually, no future plans that I shared last year at the Kernel Summit has not made, but some few users requested features has made, which were I also didn't expect it. The first one is demonstrate regions. This is a feature for exposing the demos found target regions to users. This can be useful for this was firstly requested by users who were unable to trust Deimos anyway. So they was unable to trust Deimos, and they wanted to know whether Deimos is making some silly actions, and therefore this feature can be used to debug the Deimos itself or the Deimos request that users made, for example, whether they have made too naive target access pattern or not. And also this can be used for query-like efficient monitoring research collecting. That is, as I have explained before, the Deimos scheme can specify the target access pattern, and therefore using that, the daemon output, the daemon's monitoring output snapshot is not that huge, it could still take some space, and therefore you can pick only the monitoring results of your interest. For example, you can get only the which of the memory are not accessed for more than specific time, and etc. And this feature has been merged in 6.2. And the second feature is called Deimos filter. So most of the difficulties at using Deimos is, to be honest, the tuning problems. And though we have the target access pattern and even quarters, sometimes people also want to control the target by not access pattern, but non-access pattern information that users can anyway know. For example, they can, for this, we have made this feature that users can filter the Deimos action target using non-access pattern information, like whether the backing content of the page is file or anonymous data, and what is the belonging memory sigroups of the page, and address range of the region, and belonging processes. Using this, we can, for example, ask Deimos to apply this action to anonymous pages of these specific cgroups if it's in the address range of the NUMA node X, but exclude the pages for this critical process or some important process. So this feature has first implemented with the backing content filter and memory sigroup filter, and then merged in 6.3, and then expanded to support the address range and the belonging process in 6.6. Then the third major feature was called pseudo moving average access rate based snapshot generation. As explained at the beginning, Daemon snapshot is only completed for every aggregation interval, which is 100 milliseconds by default. Having the snapshot by 100 milliseconds would be not that slow, but users can set the aggregation interval as they want, and we found some of the users are setting it actually pretty long, and therefore, in some case, if they want to set it too long, the snapshot generation would be too slow in some case. And therefore, we have made some pseudo moving average like algorithm that can provide some reasonable access rate for every sampling interval rather than every aggregation interval. Using this, users can get some reasonable data access pattern research, monitoring research snapshot for every sampling interval. And this we believe that this could be useful for some cases that who want to turn Daemon on by default always. That is currently with the basic parameters, basic values of the parameters, which using the 5 millisecond sampling interval and 100 millisecond augmentation interval. Usually Daemon's CPU usage is about 2 to 3% of single CPU time, but I want that to be much lower to be able to be enabled by default always. And the final major feature of this update is Daemon's apply interval. Actually, the moving average snapshot was developed for this one, to be honest. That is because the snapshot was made for every aggregation interval, Daemon's timing was unnecessarily coupled with the aggregation interval. That is, Deimos was able to work only for every aggregation interval. That is unnecessary coupling, and that makes the Deimos a bit unflexible. And therefore, we modified Deimos to use the pseudo moving average based access rate. And this feature has merged in 6.7 RC1 now. And yeah, so that was the major daemon update, but I wanted to share just one more update about daemon user space tool. The daemon user space tool was basically designed assuming the offline monitoring usage of daemon. And after that, daemon has evolved so much for online usage especially. And there was some problems in daemon user space tool, but recently it has designed again to support the online daemon usage, and recently released as one of the part of the preparation of the OS Summit Europe 2023. So yeah, that was the second thing, the update of the daemon since last year's Kernel Summit. Any questions or comments about the updates?
In the chat.
Cool. Yeah, we can earn more time for next topic, which I want to spend most of the time if possible. Yeah, so finally this one, the daemon future plans. The first plan is called aim-oriented feedback-driven daemon aggression, aggressiveness auto-tuning. So basically the tuning, I already mentioned about the difficulty of daemon tuning. Basically the access pattern-based target specification is difficult because it requires 6 parameters tuning. And even though we have quarter, the quarter value is still not that easy. And therefore, currently, most of the daemon users are setting different aggressiveness setting of daemons, and then should run tests and find the best one and use that. But the situation can be changed. That is, once their system, once their service is deployed to the wild, then they will show more dynamic access pattern and workload and characteristic and unexpected usage of their service. And then sometimes it turns out that the quarter value that they were believing that it was best was turned out to be not the best. And also this is especially difficult when multiple daemon schemes are being used and need to make some balance between different two schemes. And therefore, we have designed very simple feedback-driven aggressiveness auto-tuning. That is, what we were thinking is that daemon quarter could be a good way for controlling aggressiveness, but currently we are asking users to be perfect at understanding of the underlying mechanism of daemon and find the best value for best output of the daemons. That is, we are asking users to teach daemons how to work. That could be in some way can be thought of as unnecessary coupling of policy and the mechanism. That is, users are currently needed to understand the underlying mechanism and make the best policy based on that. So the idea is to let the users to feed and tame daemons. And they can let daemons know what is the resulting system status that they want. That is, someone can want 30% of free pages of the system. Someone can want the demos to keep the pressure store time for memory pressure store time of the system about 1% or 0.05%, and based on the until keeping the PSI level, just proactive memory as much as possible. And also, if we have two conflicting schemes like making THP scheme and splitting THP scheme, and then we can ask the goal of the collapsing scheme as increase the utilization of the THP to specific percent and making the split scheme to aim at dropping the utilization rate of THP in such a way. So we have made very, very simple feedback loop algorithm and applied this to receive the user's goal and current score of the target value, and then automatically adjust the next aggressiveness based on current aggressiveness. Using this, actually this idea has shared quite long before. The idea has shared on last year Kernel Summit, and while for preparing of this talk, I had to make some progress, and fortunately, I was able to send the first RFC patch set for this feature just a few days before. So yeah, it was done by presentation-driven development, and it works very well. So for testing this, we have tested some of the realistic benchmark workloads of Parsec 3 and Splash 2x, aiming 10 seconds, 0.5% memory pressure store time as our goal. And then we have compared the research of the residential set size and runtime of the workload and the PSI for original one and the proactive reclamation scheme that is not tuned at all, and the schemes that tuned for each workload offline using our previous work called demos, and this one. As you can show, all the bars are better as lower, and the auto-tuning based online tuning approach has achieved something similar to the offline tuned ones, but in terms of the PSI, it was the best one. So any questions or comments about this new plan? Cool. Thank you very much. So I think we can go to the second one. So I have prepared 3 future plans. This is the second one called access contiguity aware memory auto-scaling. So background, there are some people who are trying to use collaborative memory over subscribed virtual machine systems. That is, in this system, guest virtual machines are supposed to voluntarily report the pages in guest that the host is okay to reuse for any purpose, probably for high utilization of the memory and memory over subscription. So the best good example is the free pages reporting, of course. And after that, the guest can just access the pages as usual. That is, they can just allocate that again and access that again. Then the host will detect the access using the page fault mechanism and then allocate a new physical page frame to the guest. In this system, guests are having some requirements. Firstly, the guest should be memory frugal without performance impact. If they don't, they will have no pages that can be reported to the host, and therefore the entire memory utilization of the host will be low. Secondly, they should keep the report time free page contiguity, because free pages reporting, like reporting mechanism, should cap the aggressiveness of the reporting, because if we report all the free pages in page granularity, the overhead could be high. And therefore, by default, the free page reporting is reporting in 2 megabyte granularity, and the 2 megabyte granularity free pages are needed. And therefore, the contiguity, which is still the long-standing issue of the Linux kernel can apply here. And even though we somehow made the report time free pages contiguity, post-report time contiguity is still required in some case if the host is using some kind of huge page size. In that case, for example, if the host is using only 2 megabyte page size, and if the guest is using 4 kilobyte page size, and guest has reported 2 megabyte contiguous free pages to the host, but if the guest needs to access to only one page inside the 2 megabyte contiguous memory region, then the host should return whole 2 megabyte memory to the guest. And therefore, it would be better to keep the contiguity of the reported pages even after the report. And finally, in some more aggressive case, the system users want the guest to even forgive the pages for storing the metadata of their pages, like struct page, to maximize the oversubscription. Here we already have some existing solutions, but they have some challenges. Firstly, to be memory frugal, we can use daemon-based productive reclamation or some other similar productive reclamation approaches. Nowadays, we have some productive reclamation approaches, right? And secondly, for report time contiguity, we can do productive compaction, but the compaction could fail due to the isolation and migration failures, due to some pinned pages or some pages that still actively being used. And in case of the proactive reclamation, more than really required granularity compaction could be made. For example, we need only 2 megabyte contiguity, but the compaction would try to compact more than that. And therefore, that could be some waste of the resource. And for the post-report time contiguity, unfortunately, I was unable to find a good solution. That was my best knowledge. I hope to learn if there is any possible solution today. And to minimize the metadata for reported pages, we can use memory hard remove. That is, we can offline and hard remove the entire memory block, then we can free metadata for the memory block, and therefore we can free out the struct page like metadata. And one of the remaining challenges for this approach is we will need to orchestrate this kind of multiple kernel features which were not designed to be worked together from the user space. And therefore, it is quite complex and could be inefficient. And therefore, I am proposing a new kernel feature that designed for these requirements, that is access continuity aware memory autoscaling, or ACMA in short. So it aims to provide better solutions for each of the problems if possible, and provide efficiently orchestrating each of the solutions, and provide some easy-to-use user space interface so that users can feel that kernel is just working. For this, we introduced 2 new definitions. That is something that we will need to implement on top of current Linux kernel. The first one is a new metric called daemon working set. That is the memory regions that daemon has shown some access within some user specifiable time period. For example, memory regions that daemon has shown access within last 1 minute or 2 minutes or something. And this is something that daemon can always be able to get. And the second one is something that might be radical or controversial. So I'm calling this as a stealing operation. This operation will receive the memory region as an input, memory address range as an input, and migrate pages in the given physical address range out of the range, and then take the pages of the range, which is very similar to the contig-mem alloc. And then it will do nothing with the pages, but just report that to the host as free to use from the host side. And if as a result of the stealing, if an entire memory block is completely stolen, then this operation will further hard remove the block and free the metadata and report the freed pages to the host so that the host can use all the pages and the metadata of the memory block. So this might be quite similar to volatile MEMS memory reduction operation. And using these two new concepts, the workflow of the ACMA will be like this. If the daemon working set to free memory ratio is higher than a threshold, say 200%, that is, if daemon is finding more than 200% of the working set is free, then it just thinks that the system is in quite calm peace and therefore starts steering the report granularity contiguous regions from the last available memory block, call the pages first. And then this will reduce the ratio. And if the ratio becomes lower than a threshold, say 100%, it will stop stealing and then start running daemon-based proactive reclamation until the ratio reaches the threshold. That is, if the daemon-based reclamation is starting, then it will find cold pages and then remove the cold pages which are not the daemon working set. And this could work based on the access pattern of the system, but wouldn't work based on the access pattern of the system. That is, if the system is not having enough cold pages, then proactive reclamation will not make any more progress. And therefore, the ratio can be further decreased. And if it decreases lower than yet another threshold, for example, 50%, then we start returning the stolen pages, the pages that closer to not yet fully stolen memory block first. And also, we will do hard get the previously hard removed memory block if needed, based on the memory demand, to make the ratio over the threshold. And yeah, so our expectations about this idea is that the system will get the free memory over size that relative to the working set by the setting of the threshold. That is, we can have 50 to 100% of free memory of the working set if we use the above example. And the compaction will be done for only report granularity contiguity, and the stealing will fail less frequently, hopefully, because we are stealing cold pages first, and that would mean that there are no active user of the pages, and therefore that would have lower probability of meeting the active user of the pages during the migration process. And there are only 3 thresholds, and therefore maybe it could be easy to use. And more hopes or crazy thoughts would be, maybe this was initially designed for virtual systems, memory oversubscribed virtual systems, but could be useful for general memory oversubscribed systems, and auto-scaling might be. And also this could be somehow in future could be extended to be yet another memory pool for contiguous memory allocation. That is, if we can have the contiguous memory allocation interface on ACMA, and if the ACMA is using the stolen pages, which are contiguous anyway, as the memory pool for the allocation, maybe it could also be used for contiguous memory allocation purpose. In that case, we may call ACMA as access over CMA, maybe. So currently, no implementation at all, but just the sheer idea, and detailed RFC idea has sent to the mailing list. Any questions or comments about?
I have some question about the pages stealing. Actually, in my opinion, maybe you can consider offloading the pages entirely from the guest to the host. I mean, for code pages, first we could reclaim the page, offload the pages from the main memory to the storage. For the even code pages, we could actually do one step further, steal the pages from the guest to the host. And the advantage of this is once we trigger some page fault, the pages will be automatically pulled back to the guest. So I don't think we need to worry about in setting the what is that called, the how to remove, how to add pages memories.
Actually, I think that the hard remove and hard add is still needed for freeing the metadata of the pages that reported to the host.
So I have a question about the whole stealing, which is the host will remove the pages from the guest without actually asking the guest for any kind of permission, which implies that if the guest wants to map that page into any process's page table, because the process wants to use it, it can't do that until it first tells the host that that particular region is no longer eligible to be stolen. Is that right?
Yeah, so, and in here we are just make that as an assumption that host will not remove the guest memory while guest is not aware of that. That is, host should still keep the memory that already had removed from the guest point of view, so that the guest can still hard add that back when it's needed.
Right.
So this is the collaborative approach, and therefore the host should also collaborate in that way.
Right, but it also implies that either there will be a certain amount of delay whenever you want to first instantiate a page in the page cache that was previously cold but now needs to be in use, because you can't do that without first notifying the host. And since these are contiguous regions, if the guest needs to map a 4K page from a small file that happened to be in that large contiguous region, the guest has to pull that entire contiguous region back from the eligible to be stolen list. Is that fair?
Yeah, that's fair, and that delay could be problematic in some case, and that's why we are providing the third threshold, which can guarantee the minimum amount of free pages that relative to the working set. That is, if we can ensure the working set's memory demand will not increase that much, that rapidly, say no more than 50% of the workload within at least some time, then maybe we can set a 50% as the third threshold.
Mm-hmm. Yeah, I mean, because part of it is it's not just simply free memory. It's just if that page happens to contain the already cached file from the storage device, from the file system, then we either have to pull back that entire contiguous region from the host, or page that page into an existing free page and reread it from the file system, just so that we can avoid releasing this large contiguous region back to the host. And that becomes an interesting trade-off that the guest needs to make.
Yeah, that makes sense.
Yeah. Any other questions?
Yep, so we have one more future plan, and we have 3 more minutes. So the final one is Deimos auto-tuning based tiered memory management. That is, from the early days of the daemon, there was some people who are crazy enough to use that for tiered memory management. That is, finding the cold pages and place that in the lower tiered memory, and find the hot pages and place them in more faster upper layer tiered memory. And unfortunately, we made no progress in the area so far from the at least upstream version of Deimos, mainly because I wanted to do, but I still don't have the test setup, unfortunately. That was one of the reasons. Anyway, while I'm not making the progress, some people have made their own downstream approach of using Deimos for tiered memory management. but they were having quite various approaches that depend on their use case and also there's some creativity. And for the research were also very varied. For someone that was just a waste of time, and for someone that was something that quite interesting. And therefore, I wanted to at least share some of the ideas, because with the auto-tuning feature, maybe we can have some reasonable idea here. So the idea is very simple. So for each CPU-independent NUMA node, which we can also call each of the tier, if the node has a lower node, then we demote cold pages of the current node to the lower node, aiming the little fraction of free memory of the current node, say 5% of the current node. And if the node is having an upper node, then we will again set yet another Deimos scheme, which will promote hot pages of the current node to the upper node, aiming high fraction of utilization of the upper node, say 96%. In that way, if we have only one node, then there will be no upper node, no lower node, so no change will be made. If we have two nodes, then we will have one scheme for demoting cold pages of the node 0 to node 1 and promoting hot pages from node 1 to node 0. And if we have more nodes, we can extend the scheme in this way. So the expectations is that using this, the Deimos auto-tuning will control the speed so that it doesn't make too rapid changes and high utilization of the upper nodes and low utilization of the lower nodes, with the hotter pages and colder pages are expectable. And also we can maybe think about future extensions of making this as a general NUMA balancing idea or combining with the ACMA. And we have no implementation at all at the moment, and the detailed RFC idea is sent to the mailing list. I think it's out of time. So I will just skip some part and just wanted to say you that if you have questions, you have more channels, and also we will have Daemon BOF after next break from 4:30 at Potomac E or G. So hope to see you again at BOF for addressing more questions. Thank you very much.
All right, thanks. So next up, we have a talk about KSM.
So next talk is about KSM. I'll talk about what is kernel same page merging, or KSM, give a short architectural overview at a high level how KSM works. Then I continue with how your applications need to be configured. And then as a next step, how do you actually trace that, how are you able to trace the KSM operations? After we have the basics, I will talk about how KSM is being used at Meta. We'll look at some metrics. And then I continue with how you or we evaluate new workloads if they are good candidates for KSM. And at the end, I'll mention also some limitations and security concerns that you should consider if you want to use kernel same page merging. So what is kernel same page merging? The high-level idea is very simple. It's that you want to deduplicate anonymous pages. It's not a new feature. It's been in the kernel since 2009, but in the last 2 years, there has been increased interest in it. Originally, it was only developed, or the original use case was to support virtual machines and support deduplication of memory there. But as you will see, there are additional use cases which can benefit from KSM. So how does KSM work? So KSM is using a kernel background thread, which is called KSMD. And that background thread is scanning pages which have been nominated for KSM usage. In this presentation, I will call these pages the candidate pages. So in comparison to all the other pages which are not used for KSM. So at a simple view, KSM basically uses 3 phases. And here is a short picture which tries to describe these phases. So you see, you do a M-advise system call to say, I want to use KSM for a certain memory region. Then in the first phase, for all the pages in this memory region, you call something which is called RMAP items, which are representing these individual pages. At the first step, you create a hash, and that hash is there to see if the page changes, because if a page changes too frequently, it's not a good candidate. So in the next iteration of scanning, if the hash hasn't changed, then it's entered in what is called an unstable tree. And if you have pages that, or if you find a page that is already part of the unstable tree, it's added to the stable tree. And what is also happening at that point is that there is a KSM page created, and the other 2 or more pages basically point with the page table entries to the KSM page. I made a simplification. So in the beginning, actually, you do not calculate the hash. You first look into the stable tree if that page that you have is already in the stable tree. But in terms to explain it, I thought it's easier to go through the stages. So what do you have to do to enable KSM for your application? So there are 2 approaches. There is the old approach, which was the M-advise system call. And there is a new approach that I introduced with process control system call, which has a new option. Not all memory regions can be used for KSM. So there are certain exclusions. So if you have DEX, if you have a huge TLB, if you have shared VMAs that are shared, then it cannot be used for KSM. So memory region must be compatible. So the old way of enabling KSM was the M-advise system call. So you were saying, yeah, for this region, I want to enable KSM. And if the memory region is compatible, then that region was enabled for KSM. You can also do the opposite and disable KSM for a memory region. The problem with the old approach is that you kind of had to guess which memory regions give you benefits, because there was no feedback which telling you how many KSM pages did you actually have in that memory region. So the new process control option that was added with 6.4 operates a bit differently. It operates at the process level, so that when you enable it, all the VMAs of the process inherit, or that are compatible, have KSM enabled. In addition, the setting is also inherited when you fork the process. So when you create child processes, also they will have KSM enabled. I will explain a few slides later why that is important for us. You can see there are two examples of the API, how to use it. And one is to set it, the other one is to query it. So now after we enabled our applications to use KSM, we also want to configure it system-wide. So to configure it system-wide, there is syskernel mmksm. There you find several files which are for monitoring and for controlling KSM. One of them is called run. So if you write run, if you write one to the run file, then KSM gets enabled. There are also two other files that I want to mention, which are parameters. One is pages to scan, and the other is sleep milliseconds. Pages to scan tells you how aggressive the kernel background thread KSMD will scan for pages. And the parameter is a batch value. So what happens is you scan a batch of pages, then you sleep, then you scan a batch of pages, and so on. And sleep milliseconds is the sleep time. So the other challenge that you had is monitoring KSM. So in syskernel mmksm, there are several files, and also in KSM stat. Some files in KSM have been added recently, and I talk shortly about them. The other thing that has been added with 6.6 is new additions to proc-pit SMAPs and SMAPs rollups. So you can actually now figure out which VMAs or virtual memory areas benefit the most from KSM. So there is a KSM entry for each virtual memory area, and it tells you actually how many KSM shared pages belong to this virtual memory area. So the general monitoring for KSM is in syskernel mmksm. So there are several that are helpful and important. So pages shared is how many KSM pages you have. Pages sharing is how many are using these KSM pages. Pages skipped, I will talk later. It's a new feature. Pages unshared is they are unique, they don't change, but you have no sharing for these pages. And pages volatile are simply pages that change too fast, so they're not good candidates. And pages scanned is a new addition because it actually tells you how much work you do per scan. That was missing. You couldn't find out how many pages you were scanning for each scan round. And full scans is the number of scans that happened altogether. So another challenge that you had is you couldn't really figure out how long a scan took because there was no tracing. So you didn't know when tracing started and stopped. So I added also trace points. So the two most important is KSM start and stop scan. There are additional traces that might be helpful. Enter and exit is enter is when a new virtual memory area has KSM enabled, and the other one is when it's disabled for that VMA. The other four are more for internal debugging. So now that we have the basics, like we know we have to modify our applications, we know how to configure the system, we know how to trace or how we can trace or monitor the system now. How did we use it at Meta? So, or why do we use it at Meta? So Instagram was facing memory pressures, and on older architectures, it was not only facing memory pressure, it was also facing CPU pressure, so which is a more difficult combination. How does the workload look like? So the workload looks like you have a controller and you have at least 32 worker processes. The number of worker processes depends on architecture and how powerful it is. So, and all the worker processes do the same thing when they start up. They initially load their interpreter in memory, but not also that. They also share a lot of other data structures that often get loaded on demand. So we thought that KSM seemed to be a good fit for this type of workload because there is potential a lot of memory sharing possible. So at this point, there was only the M-Advice system call. But at Meta, we needed something different because generally we start C groups and we start C groups through system D. So that's why the idea of the process control changes came. Because what we wanted to do is we enable when we start the C group, KSM in the seed process, and then it gets inherited for all the child processes. And that's what process control interface or the new option in the process control interface that I described earlier exactly does. So you have it in the seed process, and when you fork, all the child processes inherit the setting. But of course, that was only part of the story because we also needed a change to system D. So system D now has also a new option, which is called memory KSM. With memory KSM, you can specify that option when you define your service, and when you start it, then KSM is automatically enabled for you. So advantage is you don't need to change your application to use it. So when I originally started testing KSM at Meta, the results were very disappointing, to say the least. Basically, no sharing was taking place. So after analyzing a bit what's going on, I figured out that pages to scan value by default is set to 100. So 100 is way too low for any real workloads. And later on, I also saw in documentation, it says only sufficient for demo workloads. So, so yeah, it's you need to know that. And of course, at that time, there was also no tracing available. So it took a bit longer to find out. So in the experiments that we have run with production workload, 4,000 to 5,000 seems to be a good compromise for the pages to scan value. I also tested with some other workloads to a lesser extent, and there we see 2,000 to 3,000. So generally a good guideline how to set the value is that you look at the memory savings and that you look at the scan time. If the scan time is in the range of 20 minutes, then probably this is not, your pages to scan value is way too low. We generally run with 2 to 3 minutes, something like that. It depends also how many pages you have to scan. So how do the metrics look like for a typical job? So you can see we have pretty good sharing. We share over 2.1 million pages in this example. We have KSM pages over 70,000. So if you calculate it, this is on a 64 gig machine, we're saving around 6 gigabytes in memory. So which is for us a huge saving. And if you consider the fleet, then this multiplies accordingly. So what you here can see, this picture shows the pages sharing after the software is started. So you see how we have a ramp up, and then it stays pretty nicely in the 1.8 to 2.1 range. Depends a bit how high the load is, but it's very effective for our workload. Here I have a more extreme case. Here we run the box to close to the maximum. You can see here we're saving around 5 million pages. If you look at the second line, pages shared, you see it's close to 5 million. So, but of course, this is an extreme case. We want to test how the system behaves under extreme load, but that's not how we generally run our software. So when we looked at some additional data like this, how many pages we scan per cycle, we were seeing that we're scanning a huge number of pages. So especially during the startup time, the number of pages that we scan is huge. So in the startup time, we're scanning per cycle 20 to 26 million pages. During once the memory usage stabilizes, it's more 8 to 12 million. But even for these 8 to 12 million, we have a lot of pages that we repeatedly scan, but they're unique, so there is no sharing. So the idea was, let's keep some additional information per page in the RMAP item. And based on that, if it hasn't been successful a couple of times to share that page, let's keep that page in the next scan. So, and then after that, we try the page again. And if it doesn't work again, so we increase the skip count. And we go to a max skip count right now of 8. So the new feature is already upstream for 6.7. Feature is on, and what we see is that it reduces the number of pages that need to be scanned per scan cycle by 10 to 20%. So if you think about 20 million pages, 20% is a lot. So, and we will see later on, I talk about a second feature, which is currently in design review or discussion, that in combination with this feature, this can translate to considerable CPU savings. So that second feature is auto-tune or advisor. Name is unclear. There are different sorts. I already talked during startup time, we have to scan a lot more pages than later on. So, but how aggressive we scan, we have to basically base on the initial startup or ramp up time. Because we want to scan these pages as fast as we can. So that means we have to increase the pages to scan value. However, later on, when we're more in stable state, we could actually scan a lot less aggressive. So the idea is basically to have some information, do some optimization based on the pattern that we see, and adapt the pages to scan parameter accordingly. So the idea was to optimize for a target scan time. And target scan time is basically that we say how long, or what is our goal to scan all the candidate pages. And there are 2 parameters that you can limit how much CPU we spend. There is a min CPU usage and there is a max CPU usage. And these basically translate into pages to scan values. So we know how much CPU we used in the last scan cycle. We know how long the scan cycle took, so we can make the corresponding calculations. So the results that we've seen so far are very promising. So during startup, we scan with up to 5,000 to 6,000 or 4,500, it depends a bit. So once it reaches steady state, we can see that it automatically reduces the pages to scan rate to 2,500. Sometimes even less. So it depends on the load that you're currently seeing. So what this translates to are CPU savings for the KSMD kernel background thread of 20 to 30%. so which is considerable savings for us. It also has shown that that helps improve the throughput of the system that we see. So throughput is a bit better. The other point is that the configuration in terms of scan time and CPU min and max is a lot more meaningful for admins, because for an admin it's rather difficult to reason about pages to scan, which is a batch parameter, which will run n times until the scan is finished. So how does this look like? So you can see at the beginning, when we have more pages, you can see what we see here on the y-axis is pages to scan. On the x-axis, you see the time horizon. So you can see when the software starts up, we automatically start up or increase the pages to scan rate very rapidly. And afterwards, after the initial spike, we basically go back to a lower scan rate, and if demand changes, then the pages to scan parameter is adjusted accordingly. And you can see it's around half of what it otherwise would be if we have to adjust for the startup phase. So that basically concludes the Facebook section. Now I'm generally talking about how do you approach it when you want to see if new workloads are actually good candidates for KSM. So the easiest way now is to enable process control KSM for your application. So you can either change your application, you can use the new system D switch, or you inject it into the executable with LD preload or something similar. The first two approaches are, of course, preferred. So then you run the application. And to get an idea how well KSM works, there is now, in syskernel MMKSM, there is general profit. General profit tells you how much memory you actually saved. And so it calculates it in such a way that it also considers the internal data structures that we need to keep for KSM. And then you can look at individual processes. So if you are on 6.6, you can look at SMAPS rollups. There is a small typo here. The S is missing. The SMAPS rollups, which basically gives you a breakdown over all the VMs that you have and how much KSM usage you have. So that's probably a pretty good idea. To get meaningful values, it makes sense to repeat this exercise with different pages to scan values, because depending on that, you have to see how the savings are for your workload. The scan time, as I mentioned earlier, gives you some hints if the setting is in the right ballpark. And the default, as I mentioned earlier, is not adequate. So if you want to optimize further, because often it's the case that an application has certain memory areas which especially profit from KSM and others do not. So there is also procpit SMAPS, and also procpit SMAPS has now a KSM entry. So you can basically look through your SMAPS and see which virtual memory areas benefit the most. And then you can change your application to use M-Advice calls, especially for these ones. And later, and after you've done that, you can remove the PRCTL API because you basically changed your application to optimize the use of KSM. One general advice is smaller page sizes generally work better for KSM because the sharing opportunities are simply bigger. So there is an additional idea currently, and I would also like to hear some opinions. So to evaluate new workloads, currently the only way is you run an experiment to find out if that workload is a good candidate for KSM. However, you might not always want to enable KSM, or you can't run an experiment. So there are two approaches I call. One is the kernel approach, and the other one is an approach based on Dragon right now. So Dragon is basically, it's a proof of concept. It's not quite ready. I hacked something together. It works, but I haven't open sourced it yet. Basically, the idea is with Dragon that you go through all the virtual memory areas, collect the hashes for the pages, and store it in a map, and then say, yeah, what is my sharing for the system or for the processes which I'm interested in. That's the simple version, the simple approach. Of course, that approach has a certain disadvantage. It's pretty slow. Right now, if you only have a few processes, it's probably okay. If you want to do it for the whole system, we need to do something else. So for the kernel ones, two ideas are that we calculate the hashes for the pages, or we have a means to calculate the hashes for the pages. So we can then figure out if KSM makes sense, if there is sharing. And the more advanced idea is that we actually keep the unstable and stable tree. We do not merge, only keeping the trees. Of course, that would give us the benefit that we have more accurate information how well the sharing is. Yeah, it's only an idea that I'm floating right now, because we also have that challenge at Meta that we have new workloads, and we have to see how well KSM works for them, and creating new experiments for each of them is pretty time intensive. So I also talked some limitations. So I mentioned it already, KSM works best if the page size is smaller. The bigger the page size, the lower the probability that you have sharing. Also, security needs to be mentioned. So if you control your workload, then this is less of a worry. However, if you run virtual machines or something like that, then you should probably look into the papers, because there have been, at least in the described side channel attacks for KSM. So you should also consider if that is a problem for your workload or not. The other thing is KSM is not for every workload. So if your workload is latency sensitive, then it's probably not the right thing for you. So as a short recap of what I talked about, so we got a lot of new features with 6.4. So we got new metrics in syskernel MMKSM, especially the general profit metric. We get per process metrics, and the new process control API also came with 6.1, and we added the trace points. So with 6.6 additional metrics came, which are helpful, like pages scanned and KSM stats. And with 6.7, the smart scan is coming, and on the horizon, depending when we agree, also the auto tune or the advisor is coming. So I also want to thank people who helped. So David, Johannes, Rick, and Teshun, and of course, which I missed, are the System D people, which helped me getting the change into System D.
All right.
Questions?
Yeah. Do we have any questions from the room?
Oops.
Thank you for the nice talk. Actually, about 2 years ago, there was a patch set for Daemon that for extending Daemon to for the monitor read-only or write-only monitoring. And the purpose of the patch set was to use the information to find better candidate of the KSM, that is finding read-only the pages that more being read rather than written, and then use that as a candidate of the sampling for KSM. Do you think that makes sense? I mean, the author has not sent the new revision of the patch set, so it has already lost more than 2 years. But this reminds me of the patch set, so I was just wondering if that idea makes sense.
Maybe you can direct me to that patch set and I can have a look. But I think at least for our workloads, it's writable pages where we see the sharing. It's not read-only pages. So, but I'm sure there might be workloads that can benefit from it.
So for auto-tuning, would it make sense to do more aggressive scanning if the system is low on memory, and then less aggressive scanning if the system has enough memory? Because it's not a big problem if the system has a lot of memory, right? So would that be another approach that you can take?
If we are already in a hole in terms of memory, I think it's already too late.
Okay.
So because the danger that I see is also that you aggravate the problem. Because when the system is already trying very aggressively to scan at that point, and we might not have CPU for that.
So just to channel John, because I don't see him, it seems like a lot of this was about learning how to properly profile and configure KSM and all that stuff. Have you put that in the documentation in the kernel? It seems like that would be a good, like.
Yes. So there is additional documentation. So the stuff that I have is documented.
Okay.
So if you go to the 1 second. So here are some useful links. So if you go to the KSM documentation, you will see these additional features documented. Excellent. And also explained how it works. So that's all there.
Awesome.
Something that wasn't clear. Oh, sorry. Something that wasn't clear to me from the description was: is this the auto scaling feature you're proposing? Is that happening from the kernel itself, or a user space daemon that's tuning it?
It's the kernel itself.
Okay.
So basically, you set three parameters. So you set target scan time, CPU min, and max, and that's all. And they have default values, which should probably work for most cases. But if you have a very high number of pages, or if you have very little number of pages, you might want to tune accordingly. Also, if you are tight on CPU, then you might also want to squeeze these values a bit to your specific situation.
Okay, thanks.
Hi, I have a few questions. Yes, the first one is about what is the overhead did you observe when you enable KSM, especially the CPU and memory overhead for the KSMD?
So the memory overhead you can actually calculate. So you can, if you look at the documentation, there is a formula that you can follow, and it explains you how to calculate the memory overhead. But it's not that much, because the only thing that there are two things that you have. You have the RMAP items, which is small, and then you have the one for the stable tree, because the unstable tree doesn't cost you because it's part of the RMAP item. The list is overlaid with the tree. What was the second part of the question?
CPU overhead.
So CPU overhead, of course, depends how aggressively you use scan. But what we see during startup, when we scan with 5,000 on a Skylake machine, we see up to 60% CPU usage for the KSMD kernel background thread. If once we're in a more stable phase, it goes back to 30% with the new features that I described.
Thank you. The second question is, you didn't mention this in your talk directly. I assume you noticed no performance degradation on the service level after you enable KSM.
I'm not sure I understood the question.
Did you notice any service level performance degradation after you enable the KSM?
So what we saw, actually, because we're memory bound, is because our memory boundness is alleviated, we see throughput increases. So our throughput increased, at least, or especially on the Skylake machines, which are the older machines where we have memory bound and CPU bound. On Copper Lake, we see also memory savings, but in terms of throughput and latency, it's pretty much the same.
Thank you. Yeah.
But this is all you have to consider, this is all very workload dependent. So your workload might behave differently.
Yeah. Sorry, one last question. Yeah. So why do we need to do this in the kernel space? Because I assume the user space already have all the information, like the entire physical memory, and the user space could scan the entire physical memory and find some duplication and tell the kernel, hey, just deduplicate these pages.
I think that would be pretty expensive.
So for some applications, you could absolutely do this better, but at least for this particular case, it's a giant Django thing, and that modifying that to have any intelligence is out of the question, right? So this is more useful for applications that are built on some sort of stack that you don't have that kind of fine-grained control over. But you're right, obviously for more complicated applications, it'd probably be better to use the end-advise stuff, as Stefan pointed out. Right?
Hi. Have you tested this on machines which are large and have very distant NUMA nodes from each other? And any idea? Any tests on that?
We're not really a NUMA shop.
Okay, then.
So, but I can say, so there might be a future update. So because currently I'm starting to evaluate this with some AI workloads. Some of these machines have humongous memory, but I cannot share anything yet. So we might need bigger changes or different approaches because the machines I'm talking about, we're talking about 1.5 tera main memory. So there most likely require changes to KSM to make it work there. Also, the other, or at least the initial discussions that we had, is not all parts of the AI workload will benefit from this. So there are certain pieces. So 1.5 tera sounds scary, but actually it might be a lot less because you have to consider which ones are actually good candidates. Because there are certain things like inference which are very, at least for us, very latency sensitive, so they are not good candidates.
Thanks.
Just a note more than a question. We've written a few things that have IOMUs and some KVM stuff. And KSM is tuning that up really, really high to get it to rip pages out from underneath you. Is a really nice way to check your TLB invalidations and make sure they're working right, and then like run a hard workload and make sure things aren't corrupted. So we used it a lot in that case just to hammer our hardware and our drivers. Not a question, just a statement.
Okay.
Tips for others doing similar things. You do what?
Does KSM page merging affect anything about how the pages are accounted with MemCG?
No.
Okay.
So KSM works at the global level, so it doesn't work on the individual C group level. So when you say you want to share a certain memory region, it's basically sharing it globally.
All right, we're coming up on our break at 4 p.m. Any final questions? I didn't see any on the chat, so. All right, thank you very much. Thank you.
Sure. Would you recommend this on CPU?
You need some CPU to do this. So if you're already CPU bound, that's probably not the best idea. But if you're only CPU bound, why do you care?
No, but you have both.
So you have both. You have both. So yeah, it depends how much your wiggle room is. So because we have the same problem on Skylake. So we're CPU bound in memory. So it's I call it a careful dance. So you might have to adjust the parameters a bit so that CPU say that the CPU consumption and the memory savings make sense.
Yeah.
But it's possible.
The auto tuning part is really like you can play around with it.
With the auto tuning part, it becomes easier. That's why we did it, because we have to deal with different platforms, and we cannot individually invest in tuning or finding it for each individual platform and for each workload. That's not possible.
No, but you could tune. So this was so you could tune like for CPU usage. If the CPU usage is too high, then
yeah.
I mean, there are different ways to tune, I guess. But
Okay. Yeah. So for us, it's right now it's 3 platforms that we're supporting. So for that reason, it's a challenge. So that's why this feature came to life. Also, of course, the memory, the CPU savings.
Yeah. Thanks for the talk. It was really
interesting. Thanks for the email last night.
Oh, yeah. Was helpful? Yeah. Great. Thank you for the talk.
Yeah.
Okay, so you can change the list or something. Hopefully, well, the thing is, on that part, it's actually. So I have to mount the. Well, it works. It's the growing phase, so it has our installs itself, so it includes input, so it's in that. It's running some data, saved into
I'm actually.
more information for it, but I think it's in that information, so otherwise. Here's the default that I want to use. I don't want to corrupt it, where now I can't have to go and reinstall it. Anyway, it's a test box. It's all. Trust. It's what I don't feel like we can test this from. No. Oh. Oh, thank you. So I would. Oh, okay. Oh, yeah, yeah. Yeah. I think, I don't know. Yeah. I think that. Yes, I think that. I just. Yeah.
Okay. You mean just the top one? It was long. Okay.
Yes, and this thing happened.
Never lost the cost for that. Yeah, so. Seems to be the difference between. Before that, I was looking.
With your final. I finally do pieces. Yeah, I really want.
So I am not sure if that's the set fucker or the PC. I believe both had with both. If everyone is both, then we'll look at it here. I need to look into that. But right now we know at least one of them. I saw you had it. Okay, so for Q code here, so how do you, when I was typing up seeing around so the more people that here as the runtime of the measuring the something and I think the I was seeing microsecond level. Actually, not micro, not millisecond. Sorry. So right now, just to one hour and 1 minute is called or play and so you can support multiple that's better or resources are able to the but as to the scope on that to the entire how do you feel right now? I had some for because I did that. But I feel like it's more, I think, oriented. So the style more like you're nervous or not told you have to do much. It's not like they're going to like have a question. Yeah. Yeah.
好，是肯定有我们最后的什么？对，这个，哎，这是漂亮。对，中国银行你的那个时候也是白，就是你上面靠的时候，它就哦，他们那个对的啊，对对对，啊，因为它的平衡靠比较上面一个3个大概快3个啊3倍。啊，我的意思是，我知道结果是这样，我的意思，它背后的逻辑是，第3个靠的3个2个以上，对吧？所以这边我先不说，我之前算过，我之前自己算的。
Okay, great. I was wondering if you were the speaker. Okay, all right. Okay, all right. So we have two options. One is he could project and then advance the slides, or it's actually easier if we can project from this laptop and you advance the slides. Is that okay with you? Or?
So actually we'll try the system and we think we're able to like transfer to control.
Okay, all right, yeah. Okay, so is he on? I didn't think I saw him on in the room yet.
Oh, okay.
I'm not sure if you can hear me, but yeah, I am.
Oh, there he is, yeah, there's Bobby, yep.
All right, let's see, Bobby, can you take the presenter?
Yeah, let me see. Yeah, I got it.
Okay, why don't you go ahead and present or share screen, so what you're going to do. We did upload all the presentations to the room.
Got it.
Yep, there we go. All right, well, it's 4:30, so let's get started. Up next, we're going to hear about VSOC and Performant VirtIO with Amory and Bobby. So take it away.
Okay, appreciate it. Thank you. Yeah, so my name is Bobby, and as you just heard, I'm here with Emery. We're from the Systems Technology and Engineering Department at ByteDance. We are Linux kernel engineers here, and we're just here to present VSOC from convenience to performant VirtIO communication. The agenda is going to be first just giving some background on VSOC usage, features, just looking at like who's using it and why you might want to use it. The thesis of our talk hopefully will transform that a little bit, and we'll talk. You'll kind of see what I mean by that. And we'll kind of talk about the protocol, how it works, and then look at the performance characteristics of VSOC's design, and then look at recent work that we've done on VSOC, which is really like heavily slanted towards finding a more performant socket-based protocol, and then looking to future potential work. Excuse me. So yeah, VSOC is another socket type marked by the AF VSOC socket family. It's a way to describe it is a zero configuration communication interface between virtual machines and the host. What makes it zero configuration compared to other socket types like AF INET is that VSOC doesn't require that you set up an IP network. You don't have to set up like an Ethernet device in your guest and do the setup required for to get IP networking from your guest to your host. You simply just start up a socket and you have communication between your guest and host. So that's that zero configuration piece. The addressing scheme for VSOC uses context IDs. These CIDs are kind of uniquely allocated to guests from the host. So each guest will have its own CID, and hosts and hypervisors have a well-known CID. Ports are used as usual. For Linux, and specifically VirtIO, VSOC is found in the VirtIO specification, of course. There's also Hyper-V and VMware implementations. These are not like cross-compatible. They're very different implementations, but they do share the top socket layer, and they differ at the lower level known as the transport layer. So as you can see here, this is kind of like a typical kind of architectural layout of a system using VSOC. You have your guest, Inside the guest, you have an app that uses the socket interface to talk to VirtIO VSock, which then across the guest and host boundary, using vert queues, as is done in VirtIO, communicates, sends packets to the host VSock, and those get forwarded to the host application. And traffic goes in the reverse order of that flow as well, if sending from a host app to the guest. So for use cases, the people who really like to use VSock are typically implementing some kind of agent that runs inside the guest. Excuse me. So QEMU guest agent supports VSock. QEMU guest agent is used for suspend and backup capabilities. Kata agent supports VSock. Kata agent is an agent that runs inside Kata guests and starts up containers and communicates back with the Kata runtime. It's used for managing and supervising containers inside the guest. And the reason it's kind of popular for this use case over, for example, TCP/IP is because adding a NIC is pretty intrusive if you just want a simple communication interface. Additionally, as mentioned before, TCP and IP requires changes and maintenance to both host and guest network configuration. So if you have a service that depends on this communication protocol, and it's possible to have maybe an administrator that maybe isn't aware of your service and might configure your network in a way that ends up breaking it. So there's a little bit of an unreliability in TCP/IP given the maintenance needs of maintaining that connection. It's also preferred over serial, which is also a way that are a supported communication protocol for some of these agents. But serial doesn't support the socket API. Multiple senders and receivers often require like an additional proxy service so that packets or messages can get multiplexed to the different receivers. Additionally, the serial link limits read-write access to a single process at a time, so it doesn't scale very well. And you kind of have to write your own protocol to get some protocol level features like message boundaries if you're trying to implement something like datagrams or get some reliability guarantees. The VSock protocol itself is pretty straightforward. You'll find that VSock is very simple because it's a point-to-point protocol. There's a lot of like simplified measures that can be done. So just to look at the protocol real quickly, connections are established using a two-way handshake. So the client, in this case, hoping to establish a connection, sends a request packet, and the server just responds with a response packet saying, hey, I'm happy to establish a connection. And that's the two-way handshake. After that point, data transmission can start, and either end can begin sending packets. These are marked RW packets, or that's the packet type. And then the received data is then obviously forwarded to the application by the destination socket. Once that data gets passed to the application socket, the destination socket sends control flow information back to the source. And this is the credit update mechanism. We mentioned that here because we'll talk about it because it's a kind of a key part of where datagrams differ from streams. So connection termination is also a two-way process. The disconnecting side sends a shutdown packet, and it's acknowledged with a reset packet. So a very, very, very simple protocol. So for streams or connectable type sockets, control flow is managed via credit allocation. So all packet headers contain these two fields, forward count and buff alloc, that enable endpoints to inform each other of how much data has already been forwarded to the application and how much total received buffer has been allocated. And this allows sources to calculate how much free buffer the other endpoint has. I put the equation from the spec here, but it basically just allows the sender to say, okay, I can see that the receiver has 100 bytes left, and I only want to send 5, so I can feel free to send my 5 bytes. So senders always know how much more data a receiver can handle. Implicit updates happen when sending these RW payloads, because this information, again, is packed into the headers. And updates can also happen explicitly via credit request and credit update messages. In Linux Vert.io VSOC, these credit updates are volunteered after the destination socket sends them upwards to the user application. So every time your application calls receive or read, the socket layer underneath it will then send credit updates to the other end to say, hey, we've just released this amount of buffer. You can send more. So now looking at the kind of performance aspects of how VSOC is set up. And I want to note that, like, originally VSOC is really optimized for convenient usage by applications and design simplicity, as well as those original use cases that we talked about. So the zero configuration piece being the primary attraction to VSOC historically. So it wasn't originally designed with performance as the primary goal. So at the lowest level of VSOC, at the device level, there is a single avert queue. Unlike Vert.io.net, which supports multi-queues, in VSOC there is a single avert queue. All transmission has to go through a work queue sender. So there is inevitably a work queue wake-up latency that's always incurred. This is kind of amortized by batching. So if you have a really busy socket, it might not matter as much for throughput, but that latency is definitely present and needs to be accounted for. This is different than, for example, the IP-based protocols where the socket layer, given given an appropriate queue disk and buffer state, a send message call can propagate all the way down to the device layer. In this case, the socket layer will propagate down to a work queue, wake-up call, and then there will be some scheduling latency there unconditionally. So there's some possible room there for improvement in terms of both the vert queue, the single vert queue, and work queue latency. But there are some implementation details about VSOC that are very helpful for performance. One of them is batching. This is also done in Vert.io.net. It's not unique to VSOC, but packets are sent as groups, so they're in queue to divert queue as groups, so it minimizes the amount of context switching between the guest and the host. And there's no need for much of the networking stack, routing, filters, etc. This ultimately saves on cycles because these features are not needed or they're not supported depending on your use case. If you need those things, you need them. But for a lot of VSOC use cases, they might not be needed. So you get to save cycles by not executing like that code. Currently, VSOC's not really often used for performance-sensitive workloads. But the point of this talk is that we're starting to see potential for this use case, and that's the impetus for the work that we've been doing. So some of that work involves implementing datagram support for VirtIO VSOC. If VSOC were to become a replacement for TCP/IP for very performance-sensitive workloads that just need to go across the host and guest boundary, it needs to support, or I should say IP-based protocols or the AFINet family. If it is to be a true replacement, it needs to support all of the socket types, so stream, secpacket, and datagram. So this work has been to support, to implement datagram support. It's not upstream yet. Proof of concept patches are on the mailing list, as well as a first revision for VirtIO spec changes. I should note that datagrams are already supported by VMware, just not by VirtIO. Datagrams for VirtIO VSOC currently are the same as any other datagram-based protocol. They're connectionless, unreliable, packets may be dropped. Different than the connectable socket types, they don't use credits. This is because there's no destination socket to necessarily allocate credits to a sender because there's no connection. And destination and source socket lifetimes can be out of sync, so the accounting formula doesn't add up if you have, for example, a destination socket that comes up and down, then the counts get out of sync. Currently, what's under, what was mostly under review in the specification was congestion control, so that's currently being developed and will be included in the next revision. We've gotten really, I would say, promising results from the datagram implementation compared to UDP. These numbers come from a test setup in which we use VirtIO Net over vhost with configured for multi-queue, so one RX and one TXQ per CPU. We're using 8 virtual CPUs and one sending thread per virtual CPU. Just this one VM running on one host, not nested, bare metal host. Tried to equate the buffer space allocated to both socket types. And for all of these different payload sizes from 64, 512, 1K up to 4K, we're getting almost double throughput on all of them. And the test is just sending as many of these payloads as possible in a loop. So very promising numbers. And we're investigating, why this performance improvement. And this is the working theory right now. In UDP, IP, VirtIO, you just have all of these additional components. You have the traffic control subsystem that is there to configure the queuing discipline and flow shaping or traffic shaping, IP tables, net filter. Calling into these subsystems are fast. They are very fast, but they still take time. And so when we take away these components, we're just left with what is almost essentially allocating a packet and then queuing it onto the vert queue. And that's really what we're hoping for. That in theory is the fastest case for socket-based communication across the VM and host boundary. Is the socket message is almost copied directly into a vert queue buffer, and VSOC gets really close to that. So that's the working theory, and the numbers to support that come from just the call latencies themselves. So if we look at the send message latencies, VSOC's datagram send message latency is just really tiny compared to the latency incurred by UDP send message. It's worth noting, and that's one of the reasons that this number is here, is that, again, sometimes UDP send message calls down into the driver layer. So that's the latency from start transmit. But even if we take out the latency of start transmit, there's still a big gap between the two. So getting packets in queued for the device on VSOC are just really, really fast at this time. And as I mentioned before, an important number is missing here, and that's the work queue delay. And when I ran these tests, I was seeing upwards of 300 microsecond average on the work queue delay, which is significant. So that will very likely tie into the future work if we keep on going down this path of optimizing VSOC. But yeah, that's the current hypothesis on where the throughput improvements are coming from for VSOC datagram versus UDP. So just to compare all of the different INET and VSOC family socket types, we did this test, which is single-threaded throughput. And TCP, it's a little bit hard to see on the smaller payload sizes here, but TCP is more performant by a decent margin, pretty much all the way up until 64. There's a dip here on 4K, and I'm not sure what happened there. That might just be like statistical noise. But TCP seems to be pretty reliably better than the alternatives for just single-threaded throughput. In this test, VSOC was giving it a run for its money, but the datagram and in a couple of these instances, UDP is kind of falling behind there as well. The 64K payload size, I think, is probably because of MTU limitations, but I'll leave that like guess for future investigation. For the multi-threaded case, kind of looking at how these sockets scale, we see actually really good scaling from VSOC. So this is a similar setup as before, VirtIO over vhost. And we see UDP keeps up with VSOC as the payload size increases. It falls off at 4K. I'll leave a note here that UDP we were seeing like excessive out of buffer errors once we got to the 4K size. I'm not 100% sure what was going on there, so I left that data out because it seemed to be corrupting the result. But in any case, for the throughput numbers on the multi-threaded case, so the scalability of VSOC actually seems to be pretty good, which I found to be surprising given really the single vert queue limitation of it. I was expecting there to be a greater bottleneck on that queue, but it does scale pretty good. So yeah, now I'm going to hand it off to Emery to talk about the work on SockMap.
All right, so the next recent enhancement for VSOC is the support for SockMap. So SockMap is a type of eBPF map that allows you to do programmable escape-of redirection using eBPF programs. So the way it works is that you just store references to sockets into SockMap, and then you attach a special type of eBPF programs to this map. And then you can use the helper function to do packet redirection in the kernel space. So it's useful for our use case. So we have the use case that we have multiple apps in the guest space, and then we have to aggregate the traffic and then send that to a final destination. So we need a proxy app in the user space to kind of aggregate the data. And by using SockMap, we can actually reduce the number of data copying between user space and kernel space. And here we do some performance evaluation using a simple setup. That's in the guest, we have one single thread client sending UDP traffic through a Unix domain socket. And then on the host side, we have one single thread server receiving the data from VSOC. So between those, we use two different mechanisms to redirect the packets. So one is doing it solely in the user space using socket, and another one is using SockMap. So the data I'm showing here actually show it looks weird because you can see as we increase the payload size from 64 bytes to 64 kilobytes, you kind of see that the throughput will be capped at 100 megabytes, and that's because the client here we're using is actually very aggressive. It just keeps sending data, so there's no so there's the buffer, the send buffer is full, and then it will be throttled. So actually we did another test, but we didn't include in this slides. So we try to add a delay between the so in the client we just add a delay between the send data loop, and then we see actually after 4 kilobytes we're still seeing around like 3 times the throughput. And then we show that by using SockMap, we're actually also able to reduce CPU usage. And the data here is also using that aggressive client. So like after 4 kilobytes, it's been like throttled, so we don't see like any CPU usage here. So in the future, we're wrapping up the implementation for datagram. Basically, we're adding a congestion control using start-stop signals, and we're sending the patch set. And in the future, we'll also like to look into the support for multiple vert queue. That's because if we can use multiple, right now we just have one vert queue for ARCs and one vert queue for TX. And if there are multiple apps using VSOC, then with multiple work queue, we'll have better cache locality. So that means maybe more performance. However, current protocol does not support this. That means we might, because when we're sending the data, the K worker might be interrupted and then scheduled to another CPU. So we need to have a way to aggregate the data again, and maybe we can add a sequence ID to support this. And also we would like to maybe look into the work queue related delay, because right now when we are sending data, it's being dispatched into another K worker to batch the data and send the data. And there's a delay there, and we want to see if we are able to optimize that. And finally, when we're looking at the internal logs, that's the RX log, TX logs, we think there might be some rooms for improvement. Basically, we want to reduce the scope of those logs to further improve the performance. So to summarize, VSOC is a easy-to-use communication channel between host and guest. And we have two recent improvements, namely the datagram and also the stock maps makes it even more performant. And we're looking into optimize it to make it to be more performant. And with that, we would like to take questions.
Thanks. Two things. So first, regarding the performance optimizations for higher throughput and lower latency, what is the main application for this that you really want low latency, high put communication between your VM and your guest? Because from your first slides about typical applications, they look more like some daemon running in the guest and some like casual chatter between them or something. It didn't look like they need this high throughput, low latency.
Yeah, we're actually interested. Yeah, I can take that one. We're interested in using it for sending metric data from our VMs to our host. It's a reasonable use case because that data doesn't need to be sent to other VMs. We have a daemon in the host for aggregating that data, and we're sending a lot of it, and our users are sending a lot of it. So we're looking to sort of relieve the overhead currently seen on that setup.
Okay, yeah, I'd be interested to know what the actual overhead is, right? Because you're surely not doing like 100 megabits per second metric throughput, you know. Like how much CPU time are you actually wasting on overhead at the moment, and how much could you save? Anyway, maybe I should ask my other question.
Off the top of my head, I'm not sure.
Yeah. Regarding the SOC map stuff, there was a talk this morning about doing zero copy networking. If I understand correctly, the main motivation for SOC map is to avoid the overhead of the copy, the mem copy. Could you do something like doing zero copy into user space supplied buffers and do IOU ring and get your performance benefits that way?
I think I can take this one. So we're actually also looking at that data copying right now. So right now there is a data copying in the kernel space between the sender and the receiver, and maybe we can somehow like reuse the SK buff, and then we don't need to actually allocate one more SK buff again. So that will reduce one data copy. But for is that zero copy? That I'm not sure.
Yeah, it might be good to collaborate with the other authors working on network zero copy.
Hey, first a bit of background and then a user space interface question. The bit of background, so there's another similar interface. There's the Zen vChan thing, which came from CubesOS a couple years before VSOC was created, which is an analogous concept. The user space interface for that has two things that you can do. It has a data ready, which allows you to get the number of bytes that can be read from that have been received by the kernel, but that's not exactly how it works in Zen. But in VSOC have been have been received by the kernel and can be read into user space without blocking. And then there's also a buffer space that returns to user space the amount of bytes that can be written into the other side without blocking. And this is used by consumers of this interface. In VSOC, we have, this is actually, it's just your presentation that made me realize that, oh, we are actually propagating that information across about the amount of space available on the other side. And certainly we would also have that on the receive side because it's in some buffer somewhere and we can count that. What is the people's thoughts on adding a mechanism to expose that to user space, maybe in a similar vein of like how with pipes we have an ioctl for FIO and read. That would allow VSOC to match the Zen semantics and allow things that are currently depending on that for Zen to be ported over to VSOC.
I think that's interesting. I guess it could be done through the VSOC ioctl mechanism right now. Perhaps what's the actual access mechanism for Zen vChan on from the application side to get the buffer allocation?
Well, there you've got this is all done in shared memory, like Zen style front back transmit and receive queues, and so you have a head pointer and a tail pointer that you can just like see where it is. There's some library that wraps that and provides the semantics that you want. So it's a bit different in terms of how it's implemented in the back end, but yeah. So the ioctl thing, I think that's on the VSOC like device node or something. Maybe like a sock opt might also be another option. I don't know if I don't know what the right answer is. I don't know if people have preferences or thoughts, but that would be cool.
Yeah, I think that's a really interesting idea.
Any other questions? One on the chat. From Marco Pina. I'm currently working on VSOC latency optimizations for my master's thesis. Is there any tool you can suggest to perform tests and benchmark latency for VSOC?
Yeah, the test directory for VSOC in the kernel source recently had some perf tools added to it. As far as so there are some throughput numbers there. There might be, it might report latency. I can't remember. So I would start there. We've done a lot of writing our own, just because porting other tools to use for like, I ran into some issues porting, for example, uperf to VSOC datagram because the with packet dropping and the fact that the control socket needs a reliable connection, it was just a eventually I want to do that. It was more expedient to write my own, but you might have to do a little bit of writing your own as well. But the perf tools inside the test directory are probably a good place to start. Oh, and I'm not sure if it's upstream, but either iperf already, so uperf has VSOC streams upstream, and Stefano has a uperf port for VSOC streams as well that can give you some numbers as well for the stream numbers.
All right.
That's on GitHub.
Yeah. Great. Any last questions? If not, let's thank the speakers for a great talk.
Thanks, everybody.
Hey.
Check, check, 1, 2. Right. How does it work? What do I do? Like this. Okay, perfect.
All right, great. So we're running a little bit early, but why don't we start? That way we can get out and be ready for dinner sooner. So our last talk for today is in. Oh, okay. Are there people? All right, we can wait 5 minutes and then we can let people, we can start on time. Yeah.
Certainly have enough slides.
What?
You certainly have enough slides.
I had animated slides in Google Slides until I learned that I have to upload the PDF. And, so it's just animations that have been split into several patches, slides each. So yes.
What's the latex thing then that you use for slides again? It looks like the output from that, because that like generates a new slide for every like animated part.
I didn't find any tool like that. I had to do it by hand.
Yeah, there is slide tech, but it doesn't do animation.
Yeah.
No, that's not like animation. But if you load like a subscript part of a bullet point list later, it renders it as a second like slide in the PDF.
Can you do that? I didn't find any.
Talking about Beamer or? Yeah, Beamer. Yeah, Beamer does that.
Yeah.
Beamer techniques.
Yeah, I think we no longer have templates for that. We used to have templates for all the conferences. Now it's all Google Docs.
The narrow or?
The narrow. I would assume that the Plumbers conference talks are all Beamer, but I don't know. I haven't checked, but I don't know what you think.
Yeah, we had templates, I think mostly for LibreOffice, et cetera. And then we have people just simply uploading PDFs because that's what BBB can support.
Yeah.
So.
Last year I thought that was going to be like shameful, like PowerPoint and any of these things. So I would make sure that mine would have been later.
Yeah, I had to convert at least one PowerPoint slides to PDF and then actually upload that to the BBB. And it was sort of like, hope that I didn't even think about the fact that there might have been animations when I converted it. But yeah.
Can Google Docs do that? I haven't checked it.
I opened it in LibreOffice and then exported to PDF. So
okay. I didn't know that. Yeah.
It actually did a pretty good job. So I was like, oh, wow, okay, it didn't mangle it. So.
Last days.
Yep. Well, you got all the important people here.
So the maintenance thing is tomorrow, right?
Yeah, the maintainer summit is tomorrow, but this is the last for plumbers.
It's not the end of the week for you guys yet.
Yeah. Yep. But more importantly, it means the plumbers closing party is tonight, so.
And a lot of time will be before the maintenance.
Yes. So it's not to be missed.
Buses go right away, like 6:15 or something?
I believe the buses start right away, but I suspect many of us will be going up to our rooms to dump our laptop bags.
Yes. We only do the race.
I think we're coming up on time. All right, so we're at 5:15, so let's get started. Improving resource ownership and lifetime in Linux device drivers.
Hello, welcome to my talk. My name is Bartosz Golaszewski. I'm with the Qualcomm landing team at Linaro. I've been doing Linux development for 15 years and using it for close to 20. I maintain the GPIO subsystem and its user space counterpart, and I have a personal interest in complex software architecture, like what the kernel represents. And I would say that I'm a bit of a jack of all trades, which is great because it allows me to not be very good at anything in particular. This is going to be the 4th episode in the Netflix miniseries about object lifetime in the Linux kernel. So the first talk was a year ago at Plumbers by Laurent Panchat. And then my response at FastDem, and finally Wolfram's last talk at ELC in Prague. I didn't want to spend too much time on introductions, but some summaries in order. So DevRes, the device management system, has been blamed for a long time for certain memory issues used after FreeBugs. But upon some further investigation, it turned out that it's not really DevRes. It's mostly the fact that that drivers embed the reference counted struct device within private data that is freed when the driver is detached. And subsystems either ignore it and explode when that happens, or go on and try to implement the wildest workarounds just not to crash. And when the driver is detached, when there are references still active to the embedded struct device. And this problem is very old. It predates Git, actually. And there are some comments that are 18 years old that mention this issue, so it's not a new one. And also feel free to chime in whenever you have let's make it a discussion. And the agenda for today, I was supposed to be talking about solutions exclusively, but the more I experimented, the more I dug deeper, it turned out that there are actually more problems than what we found out initially. So the agenda is quite simple. We're going to discuss another set of issues. And then I'm going to use the certain terms quite freely. So I want to clarify what I mean when I say a resource. I don't mean struct resource as understood in kernel device drivers. What I mean is a software representation of any hardware asset, so a regulator or a GPIO or a clock. And when I say resource handle, that means the software structure, the structure data that it represents it, be it a struct, some opaque structure, or an integer, like for interrupts. And then when we speak about providers and consumers, so a provider will be a device bound to a driver that exposes certain resources to users, and then the consumer is the driver that gets it assigned via some way, and then gets it and is able to use it. And finally, the kernel subsystem. So when I say kernel driver subsystems, I mean any of the libraries that provide abstraction layers and allow to group drivers logically or physically. So we have, let's say, logical abstraction layers like NVMem and hardware abstraction layers like GPIO. And we have subsystems. Often drivers will, especially provider drivers, will often go through multiple layers of abstraction without one knowing about the other. And also we have, it seems that a lot of subsystems have been simply copied and pasted and reworked to create new ones. And they don't get as much care, I suppose, as the core kernel components, because there are so many driver subsystems. And with that out of the way, I would like to start with a thought experiment. So and then it's going to be a quiz. So let's consider this. We have a resource provider, which is just a driver in the kernel, and we have a subsystem to which that resource provider subscribes, and it exposes a device to user space. So now we have a process that shows up, and it opens the device file. It gets a file descriptor, and in the kernel we create the corresponding struct file. and the resource provider now exposes the resource handle. But this resource exists on a detachable bus, so we have it on a USB bus. And oh no, what happens? So now the resource is gone. USB was unplugged. What should we do with this user space process? So should we kill it, send it a signal, and then just terminate the process, or should we make the process subscribe for some secondary channel? I'm making this up, unbind FD. I'm just making stuff up. But the process opens the device file and also subscribes for some notification mechanism, so that it will be informed when the resource is down. Or should the process just see an error the next time it calls into the kernel using a syscall? So which one? See, I was so certain that this is going to be the answer that I put a smiley face in my slides. So now a second question. So this time we're in the kernel entirely. We have a driver and a provider, and the driver calls get foo. In exchange, it gets a structure, which is the resource handle for the resource. And now the driver can call into the provider API using the handle. But again, the provider is now gone. So the driver now calls the same function. What should happen? Or the driver will be detached and it will put the resource. What should happen even more? So the answers are analogous to what we discussed with the process. So option A, an analogy to killing the process, would be forcing the consumer driver to unbind when the provider is being unbound. We could do that somehow. We could, whenever the provider is being detached, we can use the bus remove callback to detach all the resource consumers and force their remove callbacks to be called, where upon the foo put function would be called, the resources of the provider would be freed, and the provider can proceed with being detached. Or B, whenever we get the resource, we force the consumer to subscribe to some notification channel to get informed whenever the provider is gone. Or C, consumer will call on the next API call to the provider, will simply return an error. So which one? I would. Okay, so yeah, I think C is the most sane thing to do. However, let's now, where am I getting with it? So real life example. This time, nothing abstract, just a real name. So CP2112 is a GPIO and I2C expander on a USB stick. We plug it in. It comes up. GPIO lib exposes the character device, GPIO character device to user space. We have a user space tool for monitoring interrupts on GPIOs that comes up, and it calls an ioctl, requesting the interrupt. So GPIO will go to the GPIO driver from the CP2112 hit driver. It will request the interrupt. We're back to space. We kill GPIO mon, and yeah, and we kill GPIO mon, so it will call free IRC because it's like the kernel side representation of the context of GPIO mon will call free interrupt, and we're going to see fireworks in DMSG. So the splat that you're going to see is going to come from procfs, because we're going to be removing. We're going to be leaking procfs files from the interrupt subsystem, because we have destroyed all the mappings, interrupt mappings. We have already freed the domain when the USB was unplugged, but there are still references to those interrupts, and now we're freeing them and we're leaking resource. So nothing crashes, but there are resource leaks in the kernel. So you would think that we're still within the users, within the GPIO subsystem, and we could make something up to notify the context created for the user space tool to free that interrupt when that domain is being when the interrupt domain is being free. And yes, we could. But the problem is actually generic, because if we consider any driver that gets an interrupt from wherever, in device 3, for instance, and then it requests it, and then that provider, that interrupt controller is unbound for whatever reason, then that driver has no, like, it doesn't have to be in the same subsystem. It can be something completely else. We'll never know that this interrupt provider is gone. And this is not a problem that is specific to interrupts. I've just encountered that issue when experimenting. But try to use Ethernet PHYs. You want to?
Yeah, just a question. So yeah? What you're saying is this is completely independent of the problem, that interrupts are identified by integers, not pointers to a structure.
No, this is irrelevant. This, like whether the handle is an integer or struct, opaque struct, that a pointer, that doesn't matter.
We're still talking about kind of two orthogonal problems in this specific case, and in general, which one is the problem that you are getting at is needing potentially some form of notification to know that something you rely on is gone before you do an API call, or in the case of interrupt, because you never actually do an API call, you just expect something to happen, it never will. And the specific problem we have there where the freeing of interrupt after the fact is causing splat, it shouldn't, that's bugs. Like, we should be able to hold on to a partial remnant of a resource whose backend is gone correctly.
I'm definitely...
And those are kind of different problems, and they both need to be addressed, but yeah.
So yeah, I'm getting there. The thing is that so interrupts, because they're using integers, as you said, they have a lookup radix tree or something, some kind of mechanism to look up the interrupts. So when they are not found, then resources are leaked, but nothing crashes because they are not found. On the other hand, if you try to use a PHY from an Ethernet driver, and that PHY is gone for whatever reason, it can be gone because it can be on the same on a different MDIO bus than the Ethernet controller. Then everything will crash and burn because it uses a pointer and you're dereferencing it, and there's nothing behind it. So yeah, this is. I'm sorry. Yes, and I'm definitely getting there. So what is what is going on? Yeah. So yeah, go on.
The first one shouldn't be true, at least anymore, with DT-based devices. Consumers of resources are now notified when the providers of these resources are unbound.
Shouldn't they?
They are. No, I mean they're forcefully unbound. Is that not sufficient?
There is no forcing of there is no forced unbind of the consumers.
At least in DT-based systems, there should be.
No.
I'm like 99% sure. You have like device links created.
Only child-parent relationship will force any unbinding, but not.
No. Okay. No. Okay.
Any provider goes away, the driver never gets notified. Right? Clocks, resets.
Who's speaking?
For any provider disappears on you, no API notifies you, the consumer.
Yes, no. There is no such thing.
Okay.
Yeah.
So there are device
Clocks
links.
has the same problem, resets, everything.
And so maybe let me go through a couple more slides because I'm actually going to describe I have a slide for discussion in a few slides coming up. So let me just get through the following ones. Yeah. So the thing as discussed, there is no way of consumers getting informed by the providers being gone. And in GPIO, it's funny because GPIO handles that. I noticed that it's fine. I didn't design it, but when when I'm looking at what GPIO does, and it's the same for regulators, for instance, there is a certain pattern that it follows. So when you have a GPIO device driver, it implements the GPIO chip structure which holds all the callbacks, basically the implementation and some metadata for the GPIO chip. But what the GPIO lib does is it wraps it in a reference counted GPIO device struct. This is not something that the GPIO driver touches. This is provided by the subsystem, and it's reference counted, as you suggested. So the GPIO chip is owned by the provider, but the GPIO device is controlled by the library. And what happens? Well, it's reference counted, and then what happens when the GPIO consumer gets the GPIO, it gets a descriptor, which is an opaque structure, and this structure references GPIO device. So as long as there are references still being held to GPIO device, it's guaranteed to stay alive. So that when the provider of the GPIO is gone, the wrapper around it is still alive, and then whenever the consumer will call into GPIO lib, it will, well, I would love it if it's so an error, but actually it's going to see 0 and we're going to emit an error. I'm working on it, but because GPIOs are so ubiquitous in the kernel, it's hard to modify anything without breaking 100 users or so. So GPIO lib handles that barely. It still needs work. So there's no synchronization, for instance. The locking that is in place actually gets everything wrong, and I've been doing that for the last three months, and I know that it's going to take probably a year or so to fix it entirely, but yeah, the work is in progress. So what is the problem? We have these abstraction layers, but one abstraction layer doesn't know that it's built on top of 7 other abstraction layers. So an example is that you have an NVMem, but this NVMem actually actually represents an EEPROM driver, but that driver uses regmap, and regmap goes into I2C, and I2C goes, it's actually an adapter on a HID device, and you go through the HID layer, and then you go through the USB layer, and the top 4 layers in this example don't even know that they can be detached. They have no idea. So that you probably know, Wolfram, that when you have a reference to, like when you're using an I2C device, you will unplug that USB device. For as long as you're going to be users, you're going to block on the completion, and you're not going to crash, but you're going to get stuck. So what I'm thinking would make sense is to completely change the philosophy. So don't think that the resources that you get as a consumer are something that you control. You weakly reference it, and when I say a weak reference is what I mean, and what we understand in software development as a reference that in order to be used has to be first converted into a strong reference. So when you have, like, if you have virtual memory, you know that when you kmalloc it, and it will not go away, your virtual memory will stay there. So you control it, and you have to key-free it. But when you do foo get, and where foo is a kernel resource, then you don't really control it. You just weakly reference it, and then you will strongly reference it for the duration of any resource can go from under you at any point. And the provider API should be able to handle it. So now the proposition for a common model for resource providers, and this is close to what GPIO or regulators are doing, but many subsystems are not doing it and are doing like a completely different thing. So you have your provider, which is the driver, the implementation of the resource provider. You have your library, the subsystem, which provides a common interface to consumers, and you have your consumers. So the provider should create and own the implementation of that resource, but the library should create and own a reference counted wrapper around that implementation. So now this the implementation is removed when the provider driver is detached, but the wrapper stays alive for as long as there are references to it. And now the resource provides the resource handle, as explained before, which increases the reference count on that wrapper, and the resource consumer just holds that resource handle, which is the interface to the provider's API and allows to access. So then whenever the actual provider is gone because it's on a USB stick and it's been unplugged, the reference counted wrapper stays alive, and when you call a provider API function, you will simply see an error because you will see inodev because the actual provider is gone. So now even the subsystems that get the previous part right, which have this reference content wrapper, they provide no synchronization. I'm talking about GPIO regulators. So despite the fact that the resource implementation can be gone at any point, including when you are in the middle of an API call, they don't synchronize it. So my idea for that would be simply to use SRCU, because it doesn't limit you in terms of what logs you can use inside your provider API. And so that whenever your consumer makes the call to the provider, you enter the SRCU critical section, and then you see, okay, now is this implementation pointer, which is now protected with RCU, still not null? Okay, if it's not, then you can do whatever the API does. If not, you return an appropriate error. And then when you're done, you unlock the SRCU, you exit your critical section. And when the resource provider is going down, then it's just a matter of assigning the pointer to the SRCU protected pointer and synchronizing it. Does this make sense? Yeah?
Okay. So device links are created, at least on DT-based systems. Device links are created between consumers and suppliers. When the supplier is unbound, we force unbind the consumer before we unbind the supplier. But at least it doesn't have this bug, right?
It is terrible. You know, not like.
You can have a loop on a dependency.
This is what I want to say. Like a driver may remain functional even though one of the resources is gone, and then it's like killing the process that opened the file, and that file is on a USB stick, and you unplug the USB stick, then you kill the process because the file is gone. Well, it's not.
So
it's quite a terrible idea.
So let's say theoretically, let's say notify that your provider is gone. What would you want to do in that instance as a driver?
Return an error, just like this slide. So you check if it's still alive, and if it's not alive, you return an error. InnoDef, the driver sees InnoDef, and it does whatever it needs to do.
I mean, and if we end up creating some generic boilerplate for subsystems to use around that, we can also add an optional callback to notify for things that don't have regular API calls, such as interrupts.
Mm-hmm.
But yeah, I mean, you want to let the consuming driver decide what its policy is if its provider has gone, because this is fundamentally a policy decision by the consumer.
Some want to revoke.
Huh?
Some do want to revoke and kill the whole thing.
Yeah. So if you. Yeah. So if all you want is a notification when one of your suppliers is gone with an indication of who the supplier is, that's super easy to do. You can do that today. Would that help you make things easier and better? At least on DT-based systems.
But yeah, this is what I want to say. This is a generic problem. Like if you rely on a DT-specific mechanism for device links,
no, this is good. We didn't, when we came up with like the original reference counting objects and K objects and stuff, we didn't really have SRCU. We couldn't do that.
Mm-hmm.
And we thought we'd be smart and just pass around handles. But my question is, you talk about a handle. Is a handle the pointer, or is it just an opaque type like a handle?
It doesn't matter. It can be an integer, like for interrupts, or it can be
so
just a handle. It doesn't matter what it is.
We're doing what Windows does, right?
So if your handle is an integer, you can imagine that you have a lookup table, and internally the provider will, like the subsystem library, will get some kind of a reference counted object or.
So I think it's very good because we have a really hard problem of abstractions leaking out of the core or whatever, because we have C. We can poke into structures wherever we want. If you don't even have access to that and we just have a handle and you have to do all operations.
I don't like handles because the lookup that you do, it's an operation that is completely unneeded. Well, all you need is an opaque pointer.
Yeah, being an opaque pointer is great. I'm okay with that too, but I'm just saying that's good. We want this. Yeah, no, I like this. This is good. And that'll solve a lot of the abstractions problems we have, and it'll make Rust easier.
The opaque what?
This will make the interfaces with Rust, because this is going to be our biggest problem with actually writing a driver in Rust, because our resources and our management of objects are totally independent of what they want to do.
Right.
And we need to rewrite it.
And if you resolve that boilerplate in a generic way,
yes.
Yeah.
Yes.
Then we can bake into that whatever Rust needs. And no, that's excellent. That sounds really good.
Yeah. So the.
Another way of framing this, it sounds to me when I've stepped back, you're asking for accessor functions basically to access the reference that you have, right? Kind of.
No. What I'm
That's the
saying
wrong
is
way of
just
looking at
that
it?
first of all, I had Greg, you were CC'd on my discussion with Thomas Gleixner, and he was not on the same page as I was in terms of how the interrupt subsystem should handle this situation. It's a euphemism actually, but so yeah.
I'm agreeing with you, but Thomas was right in we shouldn't have been accessing those things at that point in time anyway. But if you do this, we have the fact that we know the object's gone and we're okay.
Yeah.
Yeah.
So I'm getting to let's find a solution and agree that this is the right one for handling provider-consumer relationships, where providers can first thing is providers can go away or can be detached. The provider drivers can be detached at any point, and consumers must handle it, or rather, not even consumers, but the libraries, the subsystems must have a common way of handling that.
Yeah, I think what Bartosz really suggests is this wrapper, which is maintained by the subsystem. The API itself can be anything. How do you access this handle or what it does? But the key thing, which is important for the subsystems, that the drivers implement something and the subsystem puts a wrapper around it, and it controls the lifetime of this wrapper. This is all we're talking about here.
So that
everything else is a detail.
When the provider driver goes down, the subsystem still maintains a shell around it as a safe interface that will not crash and burn whenever the consumer. Yeah, can you throw the mic to Greg? Whenever the consumer accesses a resource that is already gone.
Yeah, I mean, think of a USB device. The core created it. The driver, it's handed off to the driver, and it can do some things, sending data across the socket. But if it disappears, the driver still wants to be able to.
Right.
It's going to take a while before things clean up, and that's. I mean, yes. Yeah.
All right, so let me get to the next slides. Let me get through the slides in the remaining time, and then we can have a discussion. So the question was, does it make sense? Does it make sense? It makes sense. That's great. Now let's go back to last talk by Wolfram. So this is a common pattern in device drivers where you have your physical representation and your logical split into struct devices. So you have any of, like in the GPIO example, you can have your platform device that is a GPIO controller, and it can create several struct devices for each, like one struct device for each bank. So you have that split. And now what do we do in provider drivers? So a common pattern right now, especially in those subsystems that fail miserably to detect a provider being gone, is that you have your struct priv, which represents the private data of the provider driver, like for instance the GPIO controller. You have your struct foo, which is the structure exposed by the subsystem for the providers to implement. And what you would do, you would typically allocate it and then register it with the subsystem. And the subsystem, the problem that you have now is that the struct device, the logical struct device that is created by your driver, or rather by the subsystem for that driver, is inside the structure that you just allocated. And this structure will be freed when the provider driver is gone, but you still can have references to that struct device and it will crash miserably. So this problem is well known. This problem has been around for years, and different subsystems have different ways of dealing with that. Some just outright explode. Some will have a combination of, for instance, of the subsystem exposing APIs for allocating the structure and then registering it with the subsystem, and providers will hand over this allocated data to the subsystem so that it will not be freed at driver detached, but it will be controlled by the subsystem and only freed when it's safe to do so. Or some subsystem will do completely crazy stuff, block until the last consumer is gone, have special fields in the structure saying that this is a managed structure, so don't free it until the last reference is gone.
You should never, ever, ever, ever have a KRF inside of something which is in dev mem.
I know, right?
I mean, I wrote plenty of those bugs myself. Remember that FSI subsystem that I wrote, and I had that bug in it. Eventually, I rewrote it to not have that bug in it. We should just dynamically allocate those struct devices on their own with subsystem helpers potentially. A subsystem can be the ones owning the lifetime of them. We should never statically lay out something with a struct device inside of another structure that has a different lifetime, and never put them in dev.
You would think so.
It will be slow, but can we have a debug option that detects these things? So when device initialized, for example,
I let Wolfram.
So not at runtime, but this was exactly my talk in Prague, where I used Coccinelle, one Coccinelle script checking for like this embedded structure, which generated 400 Coccinelle scripts, potential candidates, and ran all through them. And then I looked where the hits were, and I expected it to be worse. There were only 10 hits, but these subsystems were all affected. So I knew, because I'm the I2C maintainer, I knew that I2C was affected. I didn't know that MTD was affected. And while I2C tries to, it has this completion, which does not crash, but waits indefinitely, but MTD just explodes.
The problem is I catch this all the time when doing reviews of new subsystems, but it's like the Rusty Russell's Guide of APIs. It's really easy to get this wrong. We have nothing to prevent us. If it doesn't have to go through me or somebody who knows to look for that, it always happens. But that being said, this consumer relationship, I've already changed the driver core to do this for classes and buses, and nobody noticed. So it can be done.
But what does it do?
It has opaque types that the core of the driver core for a class and a bus logic are now owned by it, and you have handles in the reference, and that also allows us to move a ton of stuff into read-only memory. We got a bunch of security benefits out of it, so you get a bunch of whole really good things out of this stuff.
I wasn't aware.
Yeah.
Nice.
Yeah, see, it happened and nobody noticed.
Yeah, it's good.
So it proves that it can be done in an incremental fashion.
Yeah, definitely.
Do we have the dev M stuff is a whole bunch of different classes of things. Do we have one of them that just says drop a KRF, do a put, and then we can?
No, it triggers on the KRF drop.
Yes, so we could.
Off of it,
I know it does, but could it be that instead, when we take out the device, we automatically go put a number of things? That's what it does, right? Okay.
Okay, so I'm going to quickly go through the rest of the slides because I only have a couple of minutes more left. So this is what Wolfram suggested during his talk as the preferred solution. So you have your struct priv. It has a pointer to, and now note that this doesn't embed the structure for the subsystem. It has a pointer to it. You have your struct foo, which is the subsystem structure, and that you should have this. So you allocate yourself the private data for the system specific data, which will embed. You're not agreeing. This is what SPY does, though, right?
The dev M here is a problem, though. Sorry.
Well, I mean, SPY. I think SPY returns you a pointer that to your private. Like you give it the size of your private data, and
exactly.
But it's it's pretty much it's the same logic, right? You make the SPY subsystem or your abstract subsystem allocate memory for you.
No,
and
it's a bit different because in this picture, the driver allocates the private structure.
Yes.
While in the SPI solution, where you say this is my device and I need that amount of memory as an integer, you get a pointer to that memory you can use, but you're not responsible to. You're not owning it in that way that you need to free it.
Yes, but anyway,
yeah.
It's just about not referencing any reference counted resources from your private data, and however you achieve it. Let's say that this is someone's preferred solution. Let's stop see the Wolfram's name.
Well, one other issue with this is also you can't use the container up trick, which is really ubiquitous in the kernel. Is if you have a struct dev, you can't get your private data from it. Very
Yeah,
easily.
yeah.
Which you can argue whether that's a good way of doing things, but it's pretty common, right?
Yeah.
I mean, with Spectrum Meltdown killed function pointers, so following a single pointer is okay, but when we start putting function pointers out there, we got to be very careful.
Right.
But container hub is at build time.
Anyway, something like the like this slide is something close to that is Wolfram's preferred solution. But what I will say is that this is this whole approach. It's a whole family of different ways of achieving that. But this, to me, it's not necessarily wrong technically if it works, but it breaks the logic, because you should keep your resources within the scope, so that if a driver allocates something, then if it allocates it at probe time, you should free it at remove time. If it allocates it with devm, then it should be freed after remove. If you do get, you should do put. If you do alloc, you should do free and not do alloc, and then expect someone else to do that. This is my issue with this approach. So I was thinking that the wrapper approach that I presented previously is actually capable of fixing two things at the same time, or two families of bugs. So let's consider this. You have now three structures. So the struct priv is the private data of the provider, of the resource provider. Struct foo is the data, is a structure exposed by the subsystem for you to fill in, so that this is where, for instance, your callbacks will live, and you will assign those callbacks and do whatever. And then you have the struct foo wrapper, which is what I on my previous slide it was represented as the resource wrapper. So this is it. It contains struct device, and also in this case it contains the RCU protected pointer to the implementation. So the struct foo we will call it the implementation. So now what happens is that the driver is free to allocate its own private structure in however it pleases. So let's say devm case alloc. Then it assigns the implementation structure. It's not different from regmap config or nvmem config, where you assign a set of fields, then pass it over to the subsystem. The subsystem picks whatever it needs from that config, and whatever happens later to that config is irrelevant, because the subsystem already copied all the data that it needs. And now you register that resource with the subsystem, and it is responsible for creating that wrapper and for managing its lifetime. Does this make sense as well? I'm sorry, what?
The operation.
The operation.
The function pointers that you have there are not the foo ops. They can't be const.
They're not what?
They're constant. Like you don't have a constant.
Yeah,
but
it's just
yeah,
no, it's just a model. It's pseudocode.
Yep.
Okay, so now if this makes sense, well, if it doesn't make sense, then thank you for attending my talk. But I hope it does. So the thing is that every subsystem does its own thing. And right now I'm working towards making GPIO compliant with what I presented to be the first good citizen in the kernel. But we have so many subsystems, they are not centralized. So I was thinking, what if we abstracted a set of those operations? So if we created an abstraction for that wrapper, an abstraction for that implementation, put the code that actually does the SRCU, the critical sections, inside some kind of a library, and and simply create a library that providers will be able to use. And this could look like this. So whenever you do GPIO get or regulator get, you first enter, your entry point will be this, let's say, resource manager abstraction, which will deal with entering the critical section and doing whatever lookup you need, and then you can. Okay, I admit I made this up, but maybe this is a starting point for a discussion on how to do it, how to start converting subsystems into doing a unified thing. And yes,
I agree. Because so this is why we create the driver model, because we had to have a unified way to do this stuff. We wanted to make it easy for everybody. It's grown and gotten messy and it's harder. But yes, because we don't want buses and every subsystem to have to do the same thing and us audit the whole thing. And I mean, Andrew's not here, but I mean, he was always mad at KREF because everybody can write a reference count. But the goal is you have a library. If you use the library, you know when you're reviewing code as a maintainer, it's right.
Mm-hmm.
So that's the goal. We can handle a little bit of abstraction in order for correctness. So that I agree. Yeah, we should try.
One suggestion on the way forward, because I know I've done my share of drivers and subsystems in the past, but try looking hard at what it would look like in two vastly different subsystems to make sure that your library abstraction covers.
Mm-hmm.
No, that doesn't end up in a direction that fundamentally won't work for something here or there.
That's how we do it for driver core. We did 3, and when we get
Yeah.
the third one, all hell broke loose.
And as much as it pains me to say that, all those little wrapper functions would lend themselves beautifully to a macro that generates them automatically. Yeah. That's just to avoid typos, basically.
I mean, like, pick an easy one like USB. Pick a simple one like USB or PCI where the model's easy, and then I2C where it's crazy. I mean, that's what threw us off, and then the SPIO and GPIO. I mean, once you get pick those three or something, then I think that's a good proof of concept that we can do this. And then go from there, yeah. And platform, of course, platform does.
Great. I think 1 is good for proof of concept. 3 is good for general.
Yeah, well, yeah, exactly. And that's how we rolled. I mean, in the 6 days, we rolled this across subsystem at a time. It doesn't require you to force everybody to do it once. And we can do it this way too.
Yeah. So this was my talk, and
oh, and video for Linux, V for L, those guys.
Oh yeah.
I mean, that's if we can do media. Yeah. That's where the real problems are.
So I admit that this abstraction library, it's a romantic idea, but I expect it to take a long time. And
well, let's try. I mean, you said you're doing something like this for GPIO already.
What I'm doing is I'm making GPIO use this approach. So I'm on this release cycle. I think I hope to introduce the SRCU protection for that implementation pointer. And yeah, some more fixes.
Implement it there and see if it works, and then we can abstract it back out to the common pieces out and go.
The problem with GPIO is that, and I expect that many subsystems have this problem, that there is so much craft and so much abusers of the API. So in GPIO, lots of drivers, and I've been fixing them for the last 3 months. Lots of drivers all over the kernel just include the private header, the one that lives in drivers/GPIO, and just reference the private structures because it's convenient. So
well, I mean, we did that when I changed the bus and driver class code. We did that, and I had to touch everybody's subsystem and fix that up. It's just we'll just we can change everything. It's okay. It's just code, yeah. And Kernel can script it too. So, but no, yeah, let's try. Thank you for doing this. I'm serious.
Thank you, Linaro, for paying me to do that.
Yeah, it's been long needed.
I should tell him probably.
And when you convert the IRQ subsystem, you know you have really done it.
Yeah, I'll note this problem actually goes all the way up to file systems, because when someone pulls out a USB stick, file system has no idea that, the block device has disappeared, and then, the part device disappeared, everything goes away, and then we, end up spewing huge amounts of stuff as opposed to saying, oh, it's gone, let's just try to clean up easily. So yeah, this is a problem that is all over the kernel. Because once you deal with file systems, now you have to think about file descriptors, right? What do you do with an open file descriptor to a file that is on a file system where the block device has disappeared? So it will take a while to get this all right. But I look forward to that glorious day.
We have it done in almost every subsystem in a different way. I mean, you hit all the file systems to make it work, and it took 3 years. I mean, it'll get there, but we have it, so it's just going to be cleaning up the existing implementation, fixing all the drivers that have been abusing it, and then just rolling it forward. So it's there in pieces, but yeah. And then you can finally put a GPIO on a USB device, right?
You did a nice job defining the problem.
Thank you.
Did you think about adding K-unit tests for the subsystems to exercise this problem and then fix? I mean, it's like a test-driven development, right? You fix it, then you are done when the test passes.
Well,
K-unit.
Depends on, no, but you're right.
So what I'm currently working on is like a test suite, which is especially for these object lifetime issues. So we can still track what's going wrong, and if we already are working on it. The problem is it's not so easy to put to existing test suites, because most of the tests will either block indefinitely or crash the kernel real bad. So most self-tests rule that out, because then you don't have a test process anymore. But still, I think these problems went under the radar for too long. So that's why I'm working with this test suite, putting up a website and saying, okay, these are the problems we identified. And since Bartosz and I was playing this ping pong, whenever we meet, the first sentence is, "Oh, it's actually worse." So I expect a lot more tests to come, but then at least they're documented and we can start working on them.
Test for the driver core to document some undocumented behavior of how it works. So yes.
The one more thing is that until recently, it's at least with GPIO, it was possible for user space to just crush the kernel using that problem, because so I fixed it, or I papered over it. So right now it doesn't happen, at least from user space. You can still crush it with a USB stick, but at least a user space process cannot come and crush the kernel. But yeah, it is a problem.
Have you talked a lot about when the device disappears, but like in the case, plugging a USB stick is one thing, but some of the reasons a device disappears because it's actually in a low power state. So what about when the device comes back? Is there anything?
A device that is in low power state is removed?
Yeah. No, I mean like, or take your USB case when the device is plugged back in. Is there like you talked about the teardown process? What about the coming back? Is there anything we need to be thinking about for the coming back process?
How is replugging the same USB stick different from the first time you plug it in?
Well, that's what I'm wondering. I want to make sure like we're coming back. We're not going to have any similar issues coming back up? Okay. But in some embedded devices, when things hit low power state, they actually it's equivalent to disappearing, right?
Like the driver is detached.
That's true. Yeah, that's true. The driver is still there. Yeah. Yeah. Okay. Okay. Yeah, I'm mixing up the driver and the device. Yeah.
But what just Björn told me today is that it can happen that you use a remote proc instance, and then this other processor has a watchdog saying, okay, I failed. And what you usually try to do then is to unbind, reset everything, clock some power, and bind again. So then you're exactly at this problem. And I agree, it's a totally different problem set. And
So the original implementation of that would expect that the highest level driver, the functional drivers, would sort of recover their state in that new spawn representation. But after looking at all the quirks that came with, I ripped all of that out when I upstreamed the solution. So it's really when your DSP goes down, it's the equivalent to pulling the USB plug, and then we reconnect it. There's various cases in there where we have problems with, for example, lingering debug FS nodes from the dying side, which then conflicts with when we recreate devices because of this. So there is more work to do there, but it should be equivalent to just unplug, disconnect everything, and then it comes up again. And then user space has to handle that.
The problem here is that this remote proc is also a provider of resources. So some other drivers are consumers of something which disappears. And even if you handle this, that nothing blows up, right? These other devices, they don't have the provider and they cannot replug. We don't have a callback to rebind.
There's a debugging option to like unbind every driver after you bind it, or detach after you probe it for testing the unbind path. Is there something that like we could do here to make sure, like if I'm running on some platform, make sure all the drivers don't have this sort of problem?
Remember, drivers are not drivers binded devices, but that doesn't expose how they reference like to file systems or anything else. So it's going to be device type specific test, unfortunately. And everybody remembers bind and unbind was a debugging only, but why? That was debugging API only, and now everybody uses it in production.
Greg, I have a question. How did the sysfs unbind attribute come to be? Because this is something.
I was debugging. I was just debugging. Seriously, I wrote it was just to debug, and I was like, let's write this and see it. And I wrote a Linux Weekly News article saying, "Hey, look at this cool thing. We can test our code easier." And now that's how the cloud runs, right?
I mean, this sysfs attribute is such an easy way to crash all kinds of things, and I was wondering, like, if we're making it available, then it should work right, but it doesn't, and it's not your fault, of course. It's just someone else's fault.
It's a great debugging tool, right? So yeah.
Unending source of syspot reports, right?
It's yeah.
Yeah, but not many. I know, but not many drivers use it.
Sprinkle everywhere, suppress bind, and problem solved.
So Wolfram, you said you had a Kernel script to help detect some of these things. Is this something that is easy for other people to reproduce and sort of see like where the issues are or where you think they are? Because I have the feeling that this object lifetime thing, Doug Anderson made the comment about container of, right? And I've seen that in so many of the drivers that I've worked on. So the lifetime of the objects really worries me right now because we're using dynamic objects, right?
So as a note, we're actually a little bit over.
Yeah. Okay.
Maybe we can take one or two, and then we should probably let the AD guy go.
I think for detecting these issues, Kernel is a good thing because I only did this embedded struct device. I made that clear in my talk, but there's also like CDEF device interactions which are problematic, and I think Kernel in general is a good tool to point the finger to potential problematic candidates. Yeah.
Yeah, I think the conversation has started to fracture, and this could go on all night. But yeah, let's thank the presenter.